Hello everybody and welcome to this online Python programming course. Now before we begin with the actual coding, let us talk about a few stuff such as for who is this course and what we will be doing in this course. First of all, what we are going to learn in this course is Python 3. Now let's get that out of the way right away. The reason why we are using Python 3 is because it is 2019 today, and basically next year the Python 2 will be going out of date. Basically it will not be in usage anymore. Therefore what we want to do is we want to learn a Python 3 programming, which is similar to Python 2. If you had any experience before with the Python 2, the syntax is rather similar, except in some functions and some different things that we're going to cover, of course. But most of the time it is rather similar. We're going to use Python 3, as I said, because that is something that is going to be used next year. Basically, every Python 2 platform will have to update itself to the Python 3, and therefore we are going to download Python 3. But more about that in the next lecture. First of all, let us talk about for who is this course. Well, for example, if you're a student and you want to learn some Python programming, this will be a perfect course for you, because we're going to cover everything from the very beginnings of Python programming to some more advanced stuff later on. Now, nothing really too advanced, because this course is mostly aimed towards the beginners. We're going to cover everything from basics in great details, so you can understand Python programming at a whole nother level. Now, of course, even if you want to make this your career and become a Python developer or basically web developer with Python, you can take this course and you will learn a lot from it. Now, we know that there are a lot of subjects covering Python, such as web developing, scripting, networking in Python, writing simple programs, writing something that will automate different tasks, and so on and so on. We will cover all of these things. But first of all, we will be downloading the Python 3 for our Windows 10 machine and also for the Ubuntu and Mac OS. Now, I will show you how to download for the Ubuntu and Mac OS, or I will show you the commands that you will use to download. But we will be mostly coding in the Windows 10 environment. As you can see right here, I have a virtual machine, Ubuntu virtual machine, which we are going to probably use later on for something, such as, for example, networking, where we are going to need two machines to communicate with one another. But as I said before, we are mostly going to use the Windows 10 environment. Now, in the process of installation of Python 3, I will show you on all three platforms how you can download Python and how you can start it up. So that will be about it for this introductory video. Nothing really more to say right here. Let us get right into programming, and in the next lecture I will explain a little bit about Python, what that is, and we are going to also download Python 3 for our Windows 10 environment. Hope you enjoyed this first lecture, and I hope I see you in the next tutorial. Bye! Hello everybody and welcome back to our second tutorial, and right now let us talk a little bit about Python before we actually download it. Now, first of all, what is Python? For those of you that are absolute beginners, Python is a programming language. Well, most likely all of you actually knew that, but Python is a high-level programming language, which basically means that it is rather easy and you can actually write programs rather faster than in some other different languages. Such as, for example, if you want to compare C language and Python language, something that will take around 10 pages or basically 10 pages of code to write in C will take about 1 or 2 pages in Python. It is a programming language used when you need something done really fast. It is also a slower language than C, for example, because it is a high-level language. It is more far away to the processor, as we can say so, and therefore it is not as fast as different programming languages that are low-level, such as C or assembly or basically any other low-level programming language. Now, the Python is also known as the scripting language. Well, basically, what Python allows you to do is actually just write simple scripts that will do simple tasks for you. Therefore, it is called scripting language. Now, even in Python, there is something called idle, which is basically looks similar to a command shell, and what you can do there is just give simple instructions to Python and there test your programs. But we will talk more about that later on once we download the actual Python. And by the way, the Python 3, of course, can be downloaded for free. As I said, I will show both on Linux and Windows. And as I said in the previous video, there are two versions of Python, Python 2 and Python 3. We are going to use Python 3, the newest version. Now, of course, if there is a newer version of Python available, once you actually watch this course, whether it is in 2019 or some other year, feel free to download the newest version. I believe everything will work the same. So, what is Python even used for? Well, Python, professionally, you can use it. It is basically great for the backend web development. You can analyze data, parse data. For example, when you have a huge pile of data, you can use some different libraries such as regex in order to extract some of the things that you need from that certain pile of data. Now, that is just some of the use for Python. It is also starting to have its appearance in artificial intelligence and scientific computing. Now, many developers also use Python to build productivity tools, different games, desktop apps, and basically Python 3 is rather spreaded language, if you can say so. You will find a bunch of tutorials online for it. It is nothing really that unknown. There are plenty of resources to help you learn Python 3. It is also widely used on the server side, and it is, as I said, widely used for scripting. Now, this includes basically various testing, building, deployment, monitoring frameworks, monitoring scientific apps, and just writing some quick scripts, as we said before. Now, Python is also widely used as an embedded language. Now, one thing that you might actually be asking is whether you need something to start Python programming. Well, we said before it is free to download, so that is something out of the way. You don't need any other knowledge. I will basically begin from the beginning, from the basics themselves, and we will then build up our knowledge to more intermediate and later more advanced stuff. So, no is the answer. You do not need any Python programming knowledge or experience, or any other programming experience. If this is a first programming language that you encounter, feel free to enjoy this course. We will explain everything in great details, so nothing to worry about there. So let us just end this real quick, and in the next video we are finally going to download Python 3 and see how it works. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now, let us see how we can download Python for Windows. Now, we have to actually visit a certain link, so open up your Google Chrome, Firefox, Internet Explorer, or whatever search engine you are using, and we're going to navigate to the python.org/downloads. So go up right up here, http python.org/downloads, and then add another slash at the end of this link. Press here enter. Now once again, this will lead us to a page where we can download different versions of Python. It will show us right here, as we can see, that the latest version of Python currently is Python 3.7.3. As I said before, if you have a newer version, feel free to download that one, as long as it is a Python 3 version and not Python 2. We can see the release dates right here and different versions. This is ours that we are going to download, released on the March 25th, 2019. Now, you might be asking whether you are going to download a 32-bit or 64-bit version, but we're going to get into that just in a second. Once you actually check all of these things out, and you can read these licenses, sources if you want to, nothing really important right here. And right here, right upper there, you can read looking for Python with a different OS. We want to click Python for Windows. And right here, we're going to have a different versions for Python 3.7.3. Now note this statement right here that says Python 3.7.3 cannot be used on Windows XP or earlier. So if you are using Windows XP, which I highly doubt, it is 2019, nobody is using XP anymore. But if you are, you're going to have to upgrade or download a different version of Python, since this one won't work on Windows XP. Now, you can see also these different things right here, such as stable releases and pre-releases. Now, pre-releases are basically, as you can see, Python 3.8.0, which is basically a release that hasn't really been released yet as a stable release, so it is something still in progress of working. So what we want to do is we want to download a stable release, because we want our Python to work perfectly. And you can have right here different versions that you want to download, such as the x86 and x86-64. Now, the x86 is 32-bit and the 64 is the 64-bit. Now, in order to check whether your PC is 32-bit and or 64-bit, so you can know which one you can download, you can go right here. So just open up your search bar in the actual Windows 10. You can just type here start, not start. We open start, we want to type control panel. So control panel, open your control panel right here. It will lead you to your settings. You want to go and navigate to the system and security settings. And right here you want to find, let me just see where it is. Okay, so system settings, right here. And right here, you can just under the system type, check out whether your operating system is, or whether your processor is 32 or 64-bit. And you can see mine is currently 64-bit, so I will be downloading the 64-bit version. So let us close this, and the 64-bit version would be this one, so Windows x86-64 executable installer. Click on it. It will start downloading. As we can see, it is 25 megabytes long, or big, should I say. And right here, we have that version right here. Since I already did download it, you can see it is the same name. So all you want to do is run your executable installer program. You can see right here, it opens a window, install Python 3. We want to just click on install now. It will ask for the administrator password, which I don't have. So I will just click here, yes. And it will start installing or setting up our Python 3 for us. And basically all you want to do is follow the actual process of installation. And if you want to later on, you can add the Python 3 to the path so you can run it from anywhere you like. Now this shouldn't take too long to install. Basically it is right now installing and downloading all the additional libraries that it needs in order to be able to run. And what we are going to do afterwards in the next video is I will show you a few commands that you can run in order to install Python 3 for the Ubuntu. Now, those of you who are using Ubuntu probably already know that any Linux type of system basically already comes with Python and Python 3, but we want to install some different usable things, or useful things, should I say, such as pip for Python, installing different modules, libraries, idle, and basically the Python 3 interpreter. So I will just leave this to finish, and I will get back to you as soon as this has finished. Okay, so right here we are getting towards the end of the actual setup. It shouldn't take more than a few seconds more to finish this. It took rather a while, not a while, it took around 2 to 3 minutes to finish this, which is not that long, but I actually thought it would finish a little bit faster. But here we can see everything has finished, and I hope that soon we will get prompted the finish button, which we can click and then run the Python 3. So you can see the last thing it installed is the Python 3 pip bootstrap 64-bit. Let me just move this right here. This installation file, right after you actually finish installing Python 3, you can just delete. There is no need to keep it right here, but if you want to, you can just leave it right there. So right here we can have setup was successful, special thanks to, and then Mark Hammond. Okay, so nothing really important right here. Disable path length limit, change your machine configuration to allow programs including Python to bypass the 260 characters max path limitation. Now this is not really anything important to us, but if you want to, you can just click it. What this means is basically the path is the actual environment in Windows where you can actually run the program from any directory you want. So for example, if you wanted to run Audacity, right here, this program on my desktop, from any other directory that isn't a desktop directory, you can add it. You can add the executable of this program to the actual path, and it will be able to run it from anywhere. But more about that later on. Right now, just click here, close. and we have Python 3 installed. Now, in order to check that out, you can just type here idle, and you can see right here I have a bunch of different versions of Python 3. Right here we are interested in Python 3.7 64-bit, and if you open the idle, it will open up the Python 3 interpreter, which we are going to talk about more later on. As we can see, the version is 3.7.3, which is the version that we downloaded. So more about that later on. What I'm going to show in the next video is for the Ubuntu and the Mac OS users, how to download Python and how to run it. And for those of you who are running this on Windows, you can just skip the next tutorial and get straight into the idle demonstration. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And what we're going to show right here is how you can install Python for the Ubuntu and also for the Mac OS. Now, I will not be demonstrating it on the Mac OS because I really don't have one at the moment, but I will show you what you can actually do in order to download it and just install Python 3. Now, on the Ubuntu, you can just open up your Linux machine, which I have a virtual machine right here. Let me just type in my password. You should have something similar to this. Basically, the installation on different Linuxes will be rather the same, if not exactly the same, but we are going to check out on the Ubuntu, as that is the mostly widely spread Linux distribution. So right here, all you want to do is right click on the desktop and open up your terminal. Now, terminal is basically the same as the command prompt in Windows. It allows you to execute system commands right here, and it also allows you to execute some of the different commands such as apt-get install, which we will use in order to get Python 3 and some different programs as well. So, first of all, as we did in the previous video for the Windows 10, what you want to do is check out whether you're using the or whether your machine is 64-bit or 32-bit. If you just type a command uname-m in your terminal, you will get x86-64, and basically, or you will get i686, I believe, or something like that, which will indicate that you're using a 32-bit machine. So, right after you check that out, what we want to do is actually download the Python 3, and we can do that with a simple command. So just go right here, apt/get, and then install Python 3. Run this command. Whoops, we are getting a lock. So let me just enlarge this. We are going to delete these locks. Unable to require, so we need to be root. Okay, yep, sudo apt-get install Python 3. Make sure to run this as a root so you actually have the actual privileges to execute this command. Enable to acquire the dpkg front-end lock. Okay, nothing really. Let me just enter a root account for a second, and I will simply just delete these locks right here. So if I just type apt-get install Python 3 once again, we get these locks. So we are going to copy the path to the lock. Could not get lock. Let me just check. Open resource temporarily available. Unable to require the front-end lock. Okay, so let us copy it and let us simply just delete it. Okay, now we're going to get another error right here, which is going to be a different lock, so we are going to delete that one as well. I believe there are going to be 3 locks. Now this is a really common error, so just do simply as I do. I believe not right now we're going to get another error. The following packages were automatically installed and are no longer required. Okay, so Python 3 is already the newest version, as it says right here. And there are some different packages that are no longer required, but we are not going to bother ourselves with that at the moment. The next command we want to run is the apt-get install, get install idle 3, which is the interactive development environment for the Python. What you want to click right here is Y, which will indicate that you actually want to download the idle 3. And it is a 10.5 megabytes large, so this will take a few seconds or minutes depending on your internet, and then you will be able to use Python 3. Now there is also another thing that we want to install, which is the Python 3-pip, which we need in order to actually be able to download different libraries that we might not have in our Ubuntu machine. So that is something that we want to get as well. As we can see, the downloading has finished. It will unpack the libraries right now, and we can execute next command. So let us wait for this to finish, just a few more seconds. Okay, it is setting up different things that it needs. Okay, it has finished. And the last command we want to run is the apt-get install. Oops. So install python 3-pip. So press here enter. It will download the python 3-pip. As you can see, this is a little bit larger, 84.3 megabytes. We want to click here Y, so it can actually download it. And this will be the last actual command for installation of Python 3. Now, once this finishes, I will simply show you how you can enter the idle of Python 3 or the interactive development environment. And basically, it is simple. In Linux, you can just specify one word, which is the Python or Python 3, whether you want to enter the Python 2 or Python 3 version of the Python interpreter. Just type that in the terminal, and what it will do is it will open the same Python interpreter that we saw in Windows. So let me just show you while this is downloading. If you just type idle in Windows and open the 3.7 idle, this is something that will be opened in your Python interpreter, or pardon me, in your Ubuntu terminal. So something similar to this. So let me just close this. I will wait for this to finish, and then we will proceed to the next step, which is going to be the installation for the macOS. Okay, so after a few minutes, I noticed that my actual internet actually, for some reason, is only the download speed is only 5,000 bytes per second, which is really, really small, considering that we only need to download 44 megabytes. So I will just quit this right here. I will download it later on. And before we end this tutorial with the macOS, let us just see how we can actually run Python from the actual terminal. So all you need to do is simply just type Python 3. And you can see it will open the Python 3 version, and basically it will give you the same interpreter as in the Windows. And right now, right here, you can import different libraries and so on and so on. Execute different commands, such as, for example, hello world, and basically do anything that you will do in the regular program as well. Now, don't really mind these two lines. If you're new, I will explain them later on. For now on, I just wanted to show you how the interpreter works and that we successfully have everything installed. So right now, let us get to the actual macOS installation. Since I don't have it, basically what you want to do is navigate to the Python 3 downloads or python.org/downloads/ and then there you want to find the DMG file that suits your OS X version. And basically, once you download it, just run it and follow the instructions for installing Python, and that is all you need to do. And it will install the additional and all the libraries that you need, so you will be good to go. And that will be about it for this tutorial. What we are going to do in the next one is take a little closer look to the idle, and I will explain a little bit why do we need it. As I said before, the idle is this Python interpreter, or basically the interactive development environment. I will explain why do we need it, and then we will start doing some simple coding stuff. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now, let us take a closer look at the interactive development environment for Python 3, or also known as idle. Now, we downloaded everything we need for all our platforms such as Windows, Linux, and Mac OS. And right now, in order to start the actual idle or the Python 3 interpreter, just type in Python 3 if you are using the actual Linux, and just go to the start button, type idle, and navigate to the idle Python 3.7 version, whether it is 32-bit or 64-bit. Now I have multiple versions installed right here, that's why I have this many. So I'll just go with the newest version of the 64-bit Python 3. You can see they are rather the same on both of these Linux and Windows systems. And what idle, or the interactive development environment, is basically it is used to help us with the errors, most likely. Now, let's imagine you're writing a program in some text editor or in Visual Studio or wherever you actually want to write the program. So, for example, let's just say you're writing it in the Notepad, and you write a bunch of lines of code lines, different tens and tens of pages, and then you don't know, you get an error, and you don't know where that error is, or what the problem with that error is. What this Python 3 interactive development environment, or the idle, allows us to do is simply just execute a single line at a time. Then we can actually see whether there is a problem with that single line, such as if I type right here, print, and open and close brackets. Now the print function will just basically just print what we type in the brackets themselves on the screen. So you need to open the quotes. So I will open right here. Let me just find where the quotes are. Okay. And then you can just type here hello. As you can see, if you use that function print hello between the single quotes, it will just print hello to the screen. And there you know that this function actually works and that the syntax for this function is correct. But if you, for example, type print and then open and close brackets, add the single quotes, or add one quote and type hello and forget the next quote and type enter, you can see EOL while scanning start string literal. Now, syntax error basically means that you coded something wrong in the program, and what this Python 3 interpreter allows us to do is to notice where that error is. Now, you might notice that this error actually doesn't give us too much of a detail. Sometimes these errors can actually be a little bit of complicated, but right here we know that we forgot to add the actual single quote. Now I will explain everything why we're adding single quotes, what this print function is, but for now let us just see what this idle interactive development environment is. So, you most likely will, while you're coding, have both of these open, such as the Notepad or any other text editor, to write the program, and also have the Python 3 interpreter in order to test a single line in order to see whether the syntax is correct. So you don't have to actually find the errors in the entire program itself. So in order to open idle, I already told you, you can just go to the start, type idle, and open the idle for the version you want to. On Mac OS, you open the idle by going to the Windows Finder, or you can open Windows Finder, click on Applications, and then Python 3, and then on the idle. In the actual Ubuntu, you can either type it like this, just type in your terminal Python 3, or I believe, let me just check out right here, if you go to the application accessories. Okay, so let me just see, show application. Okay, let me just check something out. If I just go back right here, open this, let me exit it to see whether we can actually open it with the idle 3. Idle 3 not found, did you mean idle? Okay, so let us try with the idle itself. And here it is. You can either run it like this, which will look exactly the same like this one, or you can run it from the Python 3, or pardon me, from the terminal as Python 3. That is on you. So that is basically it about idle. We are going to continue coding in the next lecture. For now on, we got some of the basics, such as downloading the Python, navigating to the Python directories, basically interacting with the idle itself, and right now we're good to go and we should be able to start coding. So hope you enjoyed this tutorial, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial. And what we're going to do, or start right now, is we're going to start with the basics of Python programming, such as variables, basically the integers, strings, math operators, comparison operators, Boolean values, and so on and so on. Some of the basic stuff that you need to know before you actually start coding real programs. Of course, you will need to be familiar with the variables themselves. You need to know what integer is. You need to know what string is. You need to know how to do simple calculator operations such as additioning, multiplication, division, exponent, and so on and so on. We're going to take a look at all of that in this lecture right here, or basically we're going to take a look at the math operators in this lecture. And later on we will see more about the variables themselves. So first of all, open up your idle, which I already have opened right here. You can enlarge it if you want to. I have this print statement from the previous lecture. Let me just go right here. Okay, I will just reopen it so we have a new and a clean version open. So idle 64-bit, here it is. Okay, I will enlarge this and we can see that we have a simple 3-line or 3 arrows right here indicating that we are going to type a command right here. So first of all, you can take a look at the idle as a big calculator. So for example, if you just type here 2, it will print 2. But if you type 2 plus 2, it will print 4. So it basically performs a simple addition with the specified numbers. Of course, that can be any other number, such as 2 plus 4 is 6. You can also try to subtract the numbers, so 2 minus 3 will be minus 1. And we can see that the Python interpreter already knows all of this basic stuff. So therefore, we can conclude that the actual addition and the actual subtraction, as we can see right here, is performed same as in the real world. So we can set a variable and set that variable to be equal to 2 plus 2, and then that variable will have a value of 4. But there are some different things that we also need to consider in the math operators. So we saw the addition and the subtraction. The multiplication is done with the star right here. So if you just type 2 times 5, you can see it will print out 10. So the multiplication is actually used with this star sign right here. Now, the 2 star signs, what the 2 star signs will do is basically that is so-called an exponent. So if you just type here a 3 on third, we will get a result of 27. But in order for Python to understand what a 3 on third degree means, basically we need to type something like this. So 3 and then add 2 star signs and then 3 right here. What this will do is it will perform 3 times 3 times 3, which will give us 27. So basically, if you just type here 3 times 4, it will perform 3 times 3 times 3 times 3. So it will times 3 4 times and we will get 81. So that is the exponent. Now let us take a look at the division, since that is also something important. There are different types of divisions, basically based on the actual variable types, such as the float and integer. The integer variable type will be the entire number. So for example, if 3 is an integer, but 3 times 0, or pardon me, 3.0 is a float value because we have the actual digit behind the actual dot. So it is a decimal number. It is not an entire whole number. So once again, the integer is the whole number. The float value is not. So let us see how we can actually get both the integer and both the float value out of a simple division. So if you just type right here 22 and you divide it by 7 right here, you can see we get this number right here, which strangely looks something like pi, but okay. It starts the same, so 3.14, which I didn't even want that to be, but here it is. Something funny happened. And this, you can consider this to be an actual decimal number. So this is not an integer, this is rather a float value. Now, right here, in order to get an integer value, of course, you will need to divide the number with the actual dividable number. So 20 divided by 5 is 4. Now you can see we still get 4.0. That is because you're using a single slash right here. So the single slash will always give you whether the number is whole, or like this 4 right here, or whether it is not, like this 3.14 right here. It will always give you a decimal number as a result. So if you even type 1 divided by 1, so 1 divided by 1, you will get 1.0 as a result. In order to get an actual integer value without any decimal behind it, you can just use double slash. So 1 and then double slash and then 1. And you can see this will only print 1. So make sure to remember that the 1 slash will give you a decimal value, while as the 2 slashes will give you an integer value. So it will not only give you an integer value once you perform the division of the actual divisible numbers. If you, for example, go with the same number right here, which is 22 divided by 7, you will get 3 as a result. Whoops, I used 22 divided with a single slash, so we need to use double slash. With 7, you can see it will circle the number to the closest whole number, which will be 3. Of course, if the result was something like 3.6, it will circle it to be 4. So let me just try it right here. If you just go with 7, okay, so 25 with 7. Okay, so if you just now divide 25 and then 2 slashes with 7, okay, so it will always, it will actually always circle it to the lower number. It doesn't work like in math. So for example, if you had 27 divided by 7, you can see that the 27 divided by 7 is 3.85, which if you actually encountered in math, you would circle it to the whole number, which is the closest, which would be 4. But Python 3 will always circle it to the lower number, which in our case will be 3. So if you just use 27 and the 2 slashes 7, you can see we still get 3 as an answer. Now, another thing that we need to take a look at in Python 3 is the module, which is the remaining of the actual division. Now, the module is referred to in Python 3 with the percentage sign, so this sign is referred to as a module in Python 3. And what this module will do is it will perform a simple division. So, for example, if you just use 22, or let me just divide it normally, so 22 divided by 8, you can see the result of 22 divided by 8 is 2.75, which means the 8 goes in 22 2.75 times. But what this will do is what the module will do is it will see how many times does 8 go in the 22, and we can simply perform it in our mind. We know that 8 goes in 22 2 times, which will give 16, and the remaining will be 6. So 16 plus 6 equals to 22. So what module, so 22 module 6, or pardon me, 8, will give 6 as a result. Because 22 equals 2 times 8 plus 6. So that is the basic understanding of the actual math operators. Those are all that there are. Now we're going to look at different operators later on, such as the comparison operators, the smaller, the larger number, and so on and so on. But for now on, this will be enough. One more thing that you need to know is which of these actually comes first. Now also something to take a look at is the actual privileges of these different math operators. So we know that in math, the actual division has more privileges than the actual subtraction and addition. But in Python 3, the actual biggest privileges have the brackets. So for example, as in math, if you specify open and close bracket, you can see right here, I already tried something, and you type, for example, 5 plus 5, and times it with 2, the result by math right here should be 20, since 5 plus 5 is something that we do first, which is 10, and then we times it with 2, which is 20. And if you just press here enter, the result in Python 3 will be the same. So we know that the actual brackets have the biggest privileges in Python 3 as well. But right after the brackets, if you, for example, wanted to perform something that didn't have brackets, the privilege comparison would be something like this. The biggest privileges would have the exponent, which is these 2 stars right here. Then after the exponent goes the actual multiplication. After the multiplication goes the division with a single slash. We know the division with a single slash will give us a decimal value. After the division with a single slash comes the division with 2 slashes, which will give us the integer value, whether that number is divisible by that actual number or not. Right after the double slashes go the actual module, all these percentage sign, and right after it goes the plus and minus, which is the last privileged math operators in Python, as well as in math as well. So that is something also that you should take a look at. So for example, let us give it a try. Let us try to divide and also multiply numbers at the same time. So if you go 2 times 2 and then slash 2, or let's do slash actually 3. Let me just check out right here. Or let's do 2. Okay, so we know that in math, for example, this would be equal to, or not in math, in Python 3, we know now that this will be equal to actually first executing the multiplication and then the division. So this should be equal to 2 if you press here enter, and it is. Now this is not looked at as the 2 times and then 1, since 2 divided by 2 is 1. This has the most privilege. This star sign has the most privilege, or the multiplication sign has most privilege. So let us try in reverse. So 2 slash 2 times 2. You can see the result is the same. So the order of the signs don't really matter. So that is all I wanted to show. Hope you enjoyed this tutorial, and we will continue coding and we will continue learning in the next tutorial. Hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And in the previous tutorial we took a look at different math operators that can be used in the Python 3 interpreter, whether you're using simply just numbers as we did in the previous video, or whether you're actually storing different numbers in variables and then using them as variables. But what we are going to take a look at now is some strings and or arrays, or however you want to call it, in Python 3. So first of all, let us think what an actual string is. So we know that a number is simply a number, but our Python 3 or our program has to know when we actually want to type a word or a sentence or any paragraph or something like that. What string is basically strings are words. Now you define strings in Python with the actual single or double quotes. So for example, if you just use single quote and then hello, you can see this will print hello as a string. If you just type hello without single quotes, it will give you an actual error saying hello is not defined. Because if you don't have a quotes, it will try to search hello as an actual variable. And we have not defined any hello variable, so therefore we cannot really find hello, and therefore we get the error. You can also use the actual double quotes if you want to, so you can see right here, hello, it will print the same output as in the single quotes, which is just simply hello. So this is what a string is. Basically a word or a paragraph or an actual sentence defined between the single or double quotes. Now, what is interesting in Python 3 is that these strings or the math operators can actually be used on strings. Not all of them, but some of them, such as the addition, the multiplication, you can use that on strings, and we will show just in a second how you can do that. So just open up your idle, whether it is in the Ubuntu like I'm doing right here, or whether it is in your Windows 10 environment. So just open it anywhere you like. And let us use the Windows 10 environment right now. Doesn't even matter. And first of all, before we actually take a look at the math operators using in the strings, let us see how we can actually manipulate strings differently. So if you just type here single quotes, hello, and then add a plus sign right here, and then open single quotes once again and just type here world, you can see that we actually get printed out hello world. Now you might be asking right now, first of all, why did this actually get printed out as a one word? And second of all, why this doesn't have any space between it? Well, the plus sign can actually concat strings for us, same as the numbers. If you, for example, type 2 plus 2, it will give you 4. But if you type string plus string, it will add the second string to the ending of the previous string. And the reason why we don't have any actual space between these two words is because we didn't define any space in our strings right here. So if you want to have space, you can just type hello and then add space and then specify the single quote, and then plus world. And you can see right now we get printed out hello world. Now of course you don't have to do this like this. You can simply just type open quotes hello world and then close quotes, and it will print the same thing without using the math operator plus and concatenating two different strings. Now one thing you can't do is you can't, for example, concat strings with numbers. If you try to do something like this, so hello and then plus 4, it will give you an error can only concatenate string to integer, or pardon me, concatenate, what did I even say? Doesn't even matter. So can only concatenate string, not integer to string. So what this basically says, you can't concat two different types of actual variables. So for example, you can concat an integer or a number to a string, which actually makes sense. You can only add number with number, and you can only add strings with strings. However, you can actually multiply strings with numbers. Since we can't add it, we can try to multiply it. So if you just type here single quote hello and then times 4, you can see what we get as an output is an actual hello 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 printed out 4 times. Now if you want to print it 100 times, you can do that. So hello times 100, you will get printed out hello 100 times. So let us see how we can actually do it with variables, even though we haven't really covered variables yet. Let us see, I will just show you an example of how this would be useful with variables. So let's say string 1 equals, so just copy the same names. I will explain what kind of names variables need to have later on. For now on, just call it string 1 equals open quotes and just type here hello. String 2 will be equal to open quotes and just type world between those quotes. And let's see how we can actually, instead of just typing the actual strings themselves, which really wouldn't make any sense. For example, let's say that you need to type a whole entire paragraph which will be stored in one string. It is rather easier to just type the variable name than to type the entire paragraph when you want to use it. So in order to concat the strings, we can just add some string number 3, which will be equal to string 1 plus string 2. You can see everything worked without an error. And if I just want to print the string 3, which will be the value stored in string 3, you can see we get printed out hello world, which is normal, and that is what we expected. But right now, if we want to change the string 3, we can do it with just simply typing string 1 times times 4 plus string 2. And if you just type here string 3, you can see hello, 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 hello world. So what it does first, since our string 1 has a word hello in it, it will multiply it 4 times, as we can see right here. And then at the end, it will add the string 2, which in our case is just world. So you can perform something like this as well. Or basically, this is something that you will perform. Most likely, you will not be doing anything like this, since this only works in the interpreter itself. If you wanted to write this in any text editor or in any program that you are writing, this will give you out an error saying basically nothing right here is really defined, therefore the program doesn't really know what to do with this. But if you write it something like this, this is something that the Python program will recognize, and it will execute this, printing the hello world string. This as well right here. But of course, if you're wondering, you can't really divide strings. So string 3 divided, or string 3 equals string 1 divided by string 2 will give you out an error saying unsupported operand type. So basically you can't really divide strings because we don't really know what that would be. You can only multiply and add strings. So that would be about it for this simple basic introductory to the strings themselves. Of course, we will manipulate them on a whole another level later on. But for now on, this will be enough. If you're a beginner, this should be enough to actually understand strings at the most basic level. And we are going to continue coding and learning in the next lecture. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And what we're going to do right now is we're going to take a look at how we can add values to our variables. Now, we already saw some of the examples in the previous video as we actually try to concat different strings. We use those string 1, string 2, and string 3 variables. But right now we're going to take a look at more examples of this stuff. So, first of all, open up your idle. I will open it up right here. And to actually give a value to a certain variable, we use an equal sign. So basically just simply equal will give a value to a certain variable. Now, the variable you can call anything you want. In just a few seconds or moments, we are going to discuss how you can actually name variables. There are different types of names that you can use, and there are different types of names that you can't use. Of course, I will discuss all of them, but for now on, let's just name a variable named a. Now, a can have a value of 5, and that is how you simply just put a value into a certain variable. In order to check out the value that is stored in the a, you can just type here a. It will print out what value it has. Let me just enlarge this. We can see a has value 5. You can also do something like this. So print, we use a print function, and in between the brackets you specify a. Now, notice that right now, once I'm using a print function, I'm not really using a double or single quotes in order to define a. That is because a is variable and not a string, and I can simply just put it in between the brackets without the single quotes, and it will print the value of a. Now, let's actually add a value of b to be equal to 7, for example. Doesn't even matter, it can be anything we want. We can now manipulate these variables such as a plus b. It will give us a result of 12. A minus b. It will give us a result of minus 2. We can also do something like this. For example, print. And in between the brackets, a times b. Oops. And we can see we get the result of 35, which is 5 times 7. So this is just simply using, instead of the actual values, you want to use the actual variable itself. Now, variables can also be strings. It doesn't have to be a number, as we saw in the previous video. If c equals, and then a certain string between these single quotes, for example, just like this, string, and if you just type here c, it will print out the string, which is just simply specified between the brackets as a string. Now, you can also concat two different variables, which have to be the same type, so you can't really add the string variable with a string variable. You can only add number with number, or pardon me, the string variable with the number. You can't really do that. You can only add number with number and string with string. So if you just type here d equals, this is, or let's do something like this. So dash dash or star. This is a string. You can use any characters you want between the single quotes. So this is a string. And if you just type here c plus actual d, we get the output of string. This is a string. So simple as that. Now, let us now discuss what or how you can actually name your variables. Sorry everybody, my PC crashed, so I had to actually restart it. So right now, let us continue from where we stopped. Let me open up my idle right here. And what we are going to do right now is talk briefly about the actual naming of the variables. Since you can't really name a variable anything you particularly want, there are certain rules that you need to follow while naming the variables. Now, for example, the most important thing is that you don't name the variables with a name of the actually already used word in Python. Now, what I mean by that is don't name a variable the same as some function that is in Python. For example, don't name a variable print. If you name it print, basically it will mess up with the actual print command. So I tested it out. If you just check out right here, print equals to, it won't print any error right here, but if I just try to print the print variable, it will not know what the actual variable, what the function is, and it will say integer object is not callable, because right now it is referring to the print as the actual integer number and not the function that is pre-built in the actual Python 3 itself. So even if you, for example, right now set some variable a to be equal to 5 and wanted to print that a variable, it will still not work, because right now the print function doesn't even exist anymore. It is set to be equal to 2. Therefore, the print function cannot be used anymore to print the statement to the screen. So let me just restart this and open the next one. And you can see right now, if you don't really mess up with the print function, you can simply just print a and it will work as usual. So that is the most important thing, but right now let us go to the rules of naming the variables. First of all, let us talk about what are the correct variable names. So, for example, let's say we want to create a variable called variable. This would be a normal or basically a correct variable name, so you can use smaller character word as long as it is not used in Python 3, as I said, and you can set it to be equal to 3 and you can just print variable and you can see it will work. You can also use multiple words, such as, for example, variable 1 equals to 5, and if you want to print variable 1, it is still a legit name and it will still work, as it does belong to the actual rules that we are going to cover right now. If you want to separate these two words, you can do that, but you can only do that by specifying the underscore between those two words. Such, for example, if you want to name it variable underscore 1 equals 6, you can do that, and you can also print it. Underscore 1, it will work. One more important thing is that the variable name can start with the dash. Now, it cannot start with a number or with a character or special character such as apostrophe and so on, but however, it can start with a dash. So you can just type it -1 equals 3 and you can print -1. It will print it out to the screen as it is a valid variable name. The usual capital letters can also be used, such as, for example, string equals hello world, print string. Though not many people really use this, but you can use a capital letter if you want to. If you want to interact your variable name with numbers, you can do that by adding the actual number to the end of the string. So, for example, string 2 equals, for example, hi. And you can print string 2. So these are all valid names for the actual variables. As we can see, we can add numbers to the end of the string. We can also print the string in capital, or not the string, the variable can be actually capital name. The variable can also start with the dash at the beginning of the actual variable name. It can have a dash to separate those two words. Now, of course, you do not need to use it to separate words. You can separate any letter if you want to with dash, but the important thing is that the dash is not something that can be used. Also, it can come in the lower letters and also multiple words. Doesn't even matter. Now, let's talk about some of the things that you can't really do with the variables, such as, for example, you can't name a variable like this. So variable, not dash, this is underscore, and this is dash. You cannot name it variable dash 1. As you can see, name 1 is not defined. Even if you try to set a value to it, variable dash 1 equals to 3, it will say can't assign to operator, because this dash sign is basically referring to as a minus, which we use in this abstraction. Therefore, we get this error right here. So this is an invalid variable name. Also, of course, you cannot name it like this. So you can't really name a variable with two separate words. You need to have something in between, and then something is usually the underscore, as we saw right here, because then the Python 3 interpreter doesn't really know this 3 to put it either in the variable or either in the 1, because it is referring to this as two different variables. Therefore, it only prints out the 1 to be the invalid syntax. If you, for example, deleted this one, this would be a valid variable name. One more thing, the variable name can't start with a number, so 5 string equals 3 is an invalid variable name. You cannot start a variable name with an actual number. So that is another thing to take a note of. And also the variables can't really be numbers, which is normal because you are actually adding a value to a variable. If you, for example, type here 23 equals 5, you cannot store a value of 5 into 23. Python interpreter doesn't really know how to do that. It says right here, can't assign to literal, because 23 is already a value, so therefore we cannot really use it as a variable name. So let me just say it once again. Also, you can't use the characters such as the the percent sign, the hash, wherever the hash is on the keyboard, the $sign. Basically, all of those signs shouldn't be used in the variable names, or not shouldn't be. They can be used in the variable names, as well as the special characters such as apostrophe. So that would be about it for the variable names. Hope you enjoyed this tutorial, and I will see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And what we're going to do right now is we're going to take a look at writing our first program. Now this won't be anything really special. We're going to use what we already learned, some of the functions. We might introduce a new function that we didn't cover yet, but don't worry, this is nothing really too extreme. This is still some beginner stuff. And we're going to see how we can run that program in our Python interpreter, and also where we can write it. Now, first of all, for this part of the tutorial, we're going to use idle, and we're going to write the program in the idle notepad shell. That's how I call it. In order to access that shell, or that part of the file that you actually write the program itself, just click on the file, click on the new file, and it should open a window like this, which basically looks exactly the same as this window right here, except this one doesn't really have this printed out. Right here, you're writing the programs, and then you can actually save this to a file and run the program from here. So let us see what we're going to write. Now, of course, if you want to, you can also use Notepad++, for example. Some people use that in order to write their programs. Let me just see what this is. Okay, these were some of the previous DLLs that I actually was watching. Doesn't even matter. You can use any text editor you want to write this program, and we're going to take a look. So let us write our first program now. We are going to use the print function that we already know what it is, and we're also going to take a look at the input function, which allows the user to actually specify or to interact with the program itself. So first of all, let us do something like this. We will select a variable called x. We will call it simply just x, or let's call it, just for the educational purposes, number_1. So that will be the variable name. We can set it to be equal to input and open and close brackets. Now, what this input function will do is basically, once we run the program, it will block the program entirely, and it will wait for a user of the program to actually input something into their keyboard. So for example, it will pause at this part right here, and it will wait for a user to specify, for example, 3 or 4 or 5. Since it is a number, we will need to specify the number to the actual program. So number_2 will be also equal to input, and we can print something like this. So we want to print calculating result and 3 dots, so it looks like the program is actually doing something, and then we can actually perform anything we basically want. We can add these two numbers, we can multiply these two numbers, we can let's simply just multiply these two numbers. We can do that just by actually selecting a variable. We can call it z, or let's just call it result, because we didn't call these first two x and y. So result will be equal to the actual number 1, so number_1 times number_2. And then all we can do right now is actually print the result to the screen. Let me just see, why is this tabbing in by itself, doesn't even matter, we can just print the result to the screen. So we can print something like this. Print the result is, and then 2 dots. Let us add a space, and we can concat, since we know that we can actually concat the actual strings. We can concat 2 strings. But you might notice that this result variable will not actually be a string, it will rather be a number. So in order to make it a string, we will use a function that I will explain later on in another future video. But for now, just for the purpose of the video itself, just use it. It is called str, stands for string, and it will basically make a number to be a string. So let me just type it right here. It has open and close brackets because it is a function, and in those brackets we specify what we want to make a string of. So we want to make a string of the result number. So let us see how this will actually work. If I just go right here, run, and go onto the run module, source must be saved. Okay, so let us save the program. We can save it on the desktop as a first program.py. Save it just like this while scanning string literal. So let us see what the problem is. Input right here. Okay, so let us do something like this. We will in the double quote specify enter the first number. We can do something like this, then it will wait for the actual input, and right here also in between these single quotes enter the second number. And then out of these 2 numbers we can make number 1 equals integer of number 1. Now I'll explain everything, just let me type this out. So number 2 equals integer of number underscore 2. Now let us right now try to first of all save this. So save, run. Oh, okay, I see where the error is. This is an error that I showed you before. Basically, I am missing an actual quote right here because I only opened a single quote right here. I really never even closed it. That's why it actually gave us an error. So let us save this and try to run it once again. Run module. First thing we get printed out is enter the first number. So let's enter the first number to be equal to 5. It will ask us enter the second number. Second number will be equal to 6. And you can see it prints out calculating result. The result is 30, which is correct. Now let's take a look at the actual code right here and explain everything a little bit better. So first of all, as I said before, this input function right here will prompt the user to enter something. Now if we didn't specify this string right here, it will only hang right there. It wouldn't print these 2 strings right here. It will just wait for the input. That's why it's always best to specify to the user what they need to enter. So for example, they don't enter a string. We type here enter the first number, user enters the first number, then it goes to the second line, which is number 2. It performs the same actual function of input, so it will hang and wait for the user to specify the second number, as it says right here, so enter the second number. Then out of these 2 variables, we will make an integer. Now why are we doing that? Well, basically this input function can sometimes return a string, and basically what we want to do is try to make an integer out of these 2 values. Same idea as we did right here. We try to make a string out of an integer. Now, you can't really do that with all of the stuff. So for example, let's take a look at this. String equals hello. If you wanted to make a string to be equal, or let's do it like this. So redesigned underscore string equals integer of this string, this will not work. As you will see right here, this will not work because the hello is not even a number. But if you just type here string 1 equals to actually open single quotes and type a number right here, so for example 3, not 3 and this letter, let me just do it once again. So string 1 equals open single quotes, 3. And then we want to try do the same thing, so redesigned underscore string equals integer out of string 1. You can see right now this did work. And if we print redesigned underscore string, it will print number 3. So you can make an integer out of a string that is a number, but you can't really make an integer out of a string that is a word, which actually makes sense. It goes vice versa as well. So you can't make an integer out of a string, and you can make a string out of an integer if they are not a number. So right here, let me just see. So we printed out a calculating result right after we actually converted these two values to be integer. If they aren't, then the result is equal a normal just mathematical equation, which is just multiplying these two numbers that the user inputted, and then we print the result is plus the string of the result. Now the reason once again why we are using the string of the result is because if we set right here result to be equal to 30, as I believe it was, and we try to perform the same right here, so let me just copy this. So copy this line, I will paste it right here. I will delete the string function, I will just concat the actual result. You can see that we actually get an error. It says can only concatenate string, not integer. That's why we need the string function to convert this result number 30 to be an integer. As you can see, if we just type here result, it is now an integer, but if I just type here result equals string of the result, and I just type result once again, it is now a string. You can see the difference because this doesn't have single quotes and this does have single quotes. You can always convert it back if you want to. Result equals integer of the result, and it will once again be a number. So that is our entire first program. It is not really anything special, but it is basically our first program. So that is. Of course, we are in the future going to code more advanced programs. This is just something to show you this input function right here, and to show you this string and integer function, which we are going to take a look at in the future videos in more detail. But that would be about it for this video. Hope you enjoyed it, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back to this tutorial. And what we are going to take a look at right now is the certain functions that allow us to convert the actual values from the certain variable into different type of values. Now we also took a look at something like that in the previous tutorial once we coded our first program, but right now we're going to experiment a little bit more with it, and we're also going to take a look at two different functions that we didn't cover. So first of all, open up your idle right here. And we're going to use the Python interpreter for this program. We don't really want to write anything to a file for now on. We want to take a look at these two functions first of all. So let us remind ourselves with the actual string and integer function. So first of all, let's set a variable a to be equal to 3. So simple as that. We know that the a is the name of the variable and the 3 is the value that is stored in that variable. We also know that the 3 is an integer, so the value is integer in our variable a. Let me just see if I just use this. As you can see, if you use a function called type, it will tell you what type of variable that is. As we can see, class integer. So we notice that our variable really indeed is integer. But for example, we know that the integer is an actual whole number, which means that it doesn't have a decimal value or point something behind it. In order to turn that into an actual float value, you can use a simple function called float. So in order to do that, we can just use something like this. So b will equal to float of a. Now what this will do is basically it will take the value from a and it will turn that into a float value. And the float value will be basically 3.0 or 3.000 depending on how many zeros you actually added to be stored in this variable. As we can see right here, currently it is only 3.0. we can use a type function in order to see what type of actual variable this is. So let us take a look at that as well. So type and then open bracket b, close bracket, we can see that the type of b is float. So we successfully converted the a variable to be a float variable and also stored that into a different variable. Nothing really too hard to do, but still it is something. The more we learn, the more we know. So let us continue and let us see what we can do with the string function that we covered in the previous video. So right now we currently have two different variables. One of them is an integer and one of them is the float. So let us check out right now whether we can make both of those values to be equal to string. So we can just type here a equals, and we want to use a string from the a. That will be the first integer value as we saw right here, which is the value 3. And if we just type here a, you can see we now have the a or the 3 between the single quotes. We can try to do the same thing with the actual b variable. So let us do something like that. B equals string of b. Nothing, we didn't get any error. We just type here b, we also get the actual string value of the b variable. In order to check it out, you can just type b and it will say class string. So both a and both b right now are both strings, no longer integer and float. And that's how you can convert the values or the type of values one to another. Right now, let us take a look at another function, which is called the length function. What the length function does is basically it shows you what is the length of a certain either list or something like that. So let me just show you right here. If you just type here length a, it will say it is 1. Now the reason why it is 1, first of all, we know that currently, because we changed it, the a is now a string, as we see right here. And the length of a will print out 1. Now, you might be asking, why is that? Well, basically because the length of the string that is stored in a, which is just 3, is equal to 1. There is only one character. If you just type here, for example, let's say like this, string equals hello. We know that the hello string has 5 letters, so if you just type here length of the string, you can see that we actually get the result of 5. Now this result right here is an integer value and it can be stored into a different variable. So for example, set equals length of string. Or we can use length of b right now. We know that the b is string 3.0, and if you just type here set, it is equal to 3. It is an integer value of 3. Now of course, the good practice would be to not name it set or c, or however you, pardon me, not set, c, or however you want to call it. It is best practice to name it something like this. So length underscore of underscore b equals length of b. That is how you can actually keep a track of all of your variables. And right now you know what the actual length of b variable is. While as once you actually had c, imagine you had thousands of variables, you would probably forget what c was for. So that's why it's a good practice to actually have variables named appropriately. And right now, if we want to print length of b, underscore of underscore b, it will print out 3. Now this length is also used in the lists in order to, for example, count the number of elements in a certain list, but list is something that we'll cover later on. No need to worry about that at all. It is also used in some for statements. Now for statements are also something that we will cover later on. Basically it is widely used in Python 3, so this is not a function that you should just forget. It is also very helpful in many programs, so that's that as well. Now let's try to see whether the length will count the empty space also as a character. So you can see right here, if we just type here string underscore 1 equals open single quotes, and there we can just type here hello world, our usual string that we also always use. So press here enter, And if we just use the length of the actual string 1, we should get printed out everything, or the length of this actual string, including the empty space as well. As we can see, the hello has 5 letters, the empty has 1 character, which is added to 6, and these 5 add to 11. So let me show you right now, if you, for example, set an integer, so a equals back to 3, it is no longer a string, and if you just type here a length of a, you can see that you will get an error. That's because you can only use the length on the strings and also on the lists. You can't really use it on a number because we don't really know what is a length of a 3. For example, if you set a to be equal to 33 or 333, doesn't really matter, you would still get an error because the a is a number. It will not print out 3 as a result because it would, well, maybe by some logic it could print out 3 because there is 3 digits right here, but it doesn't work like that. You can see object of type integer has no length, which is correct. The integer number really hasn't, you don't know how to count its length. So that would be basically about it for these simple functions. What we learned right here is that we can actually turn specific variables into different variables. We can also check out the length of the certain variables, strings, elements, lists, or however you want to call it. Now that is useful later on once you actually have a huge, for example, let's say you have a huge text right there and you want to check out how many characters are in that text. You, of course, won't go one by one character and count it by hand. You will go and basically use length of that actual paragraph and count how many characters are in that paragraph, including the empty spaces, the special characters, and so on and so on. So, hope you enjoyed this tutorial. It was a rather short one, and we will continue coding in the next lecture. Bye! Hello everybody and welcome back to this tutorial, and what we are going to do right now is we are going to introduce ourselves with the logical Boolean values. We're also going to take a look at some of the comparison operators in Python. So what we did by now, we took a look at some of the different variables, how to store variables, how to name variables, how to convert variables from one type to another type, how to basically count the length of a certain string, paragraph, or the list. And right now we're going to introduce ourselves, as I said, to the Boolean true or false values. Now you might be asking, why do we need true or false values? Well, basically it is really important, especially in loops, as you will see later on. For now on, we will only introduce ourselves with that, and we will see how we can actually set the variables to be equal to either true or either false, and so on and so on. We will also take a look at the comparison operators, which is not the same as the math operators. We saw what the math operators in Python are, and right now we're going to introduce ourselves with the not equal, equal, greater and lesser, and so on, which is also really important in loops especially. So let us open up our idle. First of all, I will close this one from the previous video, then I will open a new one. 64-bit, okay, that is the one. And right now, first of all, let's see how we can actually check out whether something is true or whether something, or how we can set a variable to be equal to true or to be equal to false. Now, if you just type in your interpreter true, it will print out true. If you just type here false, it will print out false. Basically, these are the two values that are already pre-installed or that come in Python, basically, not pre-installed. I don't know what I'm saying, and you can put these variables, and you can put these values in an actual variable. So for example, let's call it a equals true. Basically right now, if you just type here a, you will see that a equals true. Now, it is really hard to explain like this, but it has a really good use, especially in the while true loops, which is an infinite loop. If you create a while true loop, it will basically perform a certain task for as long as that certain element is true, which can, in our case, be forever if we never change a to be equal to false. Now, of course, I will show those examples as well later on. For now on, we just want to see how this works. So, we set the a variable to be equal to true. Let's set the b variable to be equal to false. And if you just type right here, a equals b, you can see that right now a is false as well, and b is also false. So let's set a back to true. So I just wanted to show you that you can actually set the values from one true or false variable to another true or false variable. So that is something you can do as well. It will not give you any error, but what this really has usage for is the equal with. Now, in order to perform the equal with sign, which is a comparison operator, it will basically compare these two numbers or these two values and see if they are the same. Now, we know that they are not the same because A is now true and the B is false. And in order to compare those two values, you just type the value or the variable 1 equals, so double equal, and then the variable 2. And you just press here enter and you can see we get printed out false. Now you might be asking, why did we get printed out false? Well, basically, take a look at this. You have one variable that is true, one variable that is false, and it basically performs, is A equal to B? Is true the same as false? The true is not the same as false, therefore that statement is basically false. That's why we get printed out right here false. If we get something like this, so A equals true, B equals true, and we perform the same comparison, so A equals B, it will get printed out true because true is true. You can do the same thing with numbers, of course. It doesn't have to be the Boolean values, true or false. You can set A to be equal to 3, or pardon me, to 4, and B to be equal to 3. And if you perform A equals B, you will get printed out false because 4 is not equal as 3. Maybe this is a little bit more explanatory example. Maybe you will understand it a little bit better than with these true and false values. Now let's see what it prints out once the actual values are correct. So B equals 4 B equals 4, not 5. And then we compare them, and that now this is true. As I said, this is mostly used in loops, so while true, while false, and so on and so on. We can set the variables to be either true or false. Then make sure that you remember that the equal sign is not the same as double equal sign. So that is really important because with single equal sign, we set a value to a certain variable, and with double equal sign, we compare the value to a different variable. So this right here will set 3 to be stored in A, and this right here will check whether A is equal to B. That is the difference between one equal and double equal. So now, right now, let us also take a look at some of the other comparison operators in Python. The double equal is not the only one, so let us check out how we can actually check if something is not equal to the actual second variable. So what we will do is we will set A to be equal to true, B to be equal to false, and right now, let us check if A is not equal to B. So A, in order to do that, you just type exclamation mark and then equal and then B. And you can see right now we get true, unlike in here where we got false. So what this basically means is it will check if A is different than B. Since A really is different than B, since A is true and B is false, we will get printed out true. Yes, A really is different than B. Let us try with numbers so you can understand it better. A equals 5, B equals 3, A is not equal, or check if A is not equal to B, and it will print out true. A isn't equal to B. If we set B to also be equal to 5, and we print out, and we do the same thing, so A, and then exclamation mark equals B, we get now false. A is equal to B, therefore this statement is not correct. So this is also something useful that we will use later on, but these are not the only comparison signs. Of course, we have the greater or lesser, and we can see right here, if we just type here A greater than B, we get printed out false. Now we get printed out false because A is not bigger than B, because both A and both B have the value of 5 stored in them. But if we set B to be equal to 4 and now perform the same task, we will get true. Therefore, 5 really is bigger than 4. This is basically the same. So this statement right here and this statement right here are exactly the same. Just these two have values in those variables. We can also do the same thing with the lesser sign, so 5 is smaller than 4, which is of course false. We know that. And there is also two more that we need to cover, which is the greater or equal and lesser or equal. So we have these, we have the equal sign, we have the double equal sign, we have the exclamation mark equal, we have the greater, lesser, and we also have the greater or lesser. Greater equal or lesser equal. So let's say both A to be equal to 5 and B to be equal to 5. And right now, if we just check something like this, so A is greater or equal to 5, this should be true. Not to 5, to B, so greater or equal to B, we get printed out true. Also, if you try to reverse it, so A is smaller or equal to B, this is also true because both of those values are 5, therefore, in both of these cases, they will work. Now, this is also something that you can use in the loops as well. So, for example, while A is smaller or equal than 5, do this task. And then in that task, what you do is you basically increase A after every iteration. Of course, we are going to take a look at those examples as well. Maybe right now, this is looking a little bit confusing to you, but it really shouldn't be. This is just basic math right here. What is important is how you actually use this stuff right here. So that would be basically about it for this tutorial. We will continue coding in the next tutorial, so hope you enjoyed it, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial, and let us introduce ourselves with a new thing that we are going to learn right now, which is the if statement in Python 3. Now this is the first actual kind of a loop that we are going to do, and basically this is really important, so make sure to pay attention. It is not that hard, especially this tutorial, which is going to be just the basic stuff for the if statement. In the next two tutorials, we're also going to cover the if-else statement and the if-else statement with multiple else-if statements, if you understood what I'm saying. But for now on, let us just cover the if statement only, so open up your idle as usual. And right here, basically, we can just try to perform the simple if-else statement, or just if statement in this tutorial. So if you just type here, if, you can see it already gets flagged as a word that comes in Python, so it already gets colors. So if, what this basically does is it will look like this. So if something, now of course we don't have variable something, but we'll just use it just for the demonstration purposes. If something equals to something, two dots, then you need to tab the next line. As you can see, it tabs by default, do something. And we can see invalid syntax, of course, because this is not something that actually exists, but this is the basic idea behind the if statement. So for example, we can do something like this. A equals 3. B equals 3. And we can just try to do like this. So if A equals to B, two dots, make sure to tab everything in, because if you don't tab it in, which the actual interpreter in Python 3 does by default, but if you're using some text editor and you don't tab it in, it will not be considered as a part of the actual if statement. So if A equals B, print, and we can print basically anything we want. We can print these two values are the same, exclamation mark. You just press here enter once again, and you can see right here we get printed out these two values are the same. But let's see what happens once actually B is not equal to A. So A equals 3, B equals 4. And we will do basically the same thing. So if A equals to B, and we will print the same string. So these two values are the same, exclamation mark. And if I just press here enter once again, you can see right now nothing gets printed out. So this is an if statement. It is only used once something is equal to something, or when some statement is fulfilled, such as in the first example right here, A was equal to B, therefore we did this. Now, of course, this is not really that useful of an example. What you want to do in a real life program is basically you want to do some useful task once a equals to b, for example. So let's do it. Let's do something like this. So let's set a to be equal to 5, b to be equal to 5, and if a equal to b, we can do something like this. A equals a times b, which will basically make an a after this if statement to be equal to 25. So we can do it like this. Press here enter, our if statement has finished, and if I just type here a, you can see right now a is no longer 5, a is right now 25. So let me just check right here. You don't really need to use always this equal, you can use something like this. So if b is smaller than a, which currently it is, since a is 25, you can print b, or b is smaller than a. Close the actual bracket right here, press enter, and we get printed out b is smaller than a. So this is basically a simple example of the if statement. What we are going to do in the next video is basically cover the if else statement, which is going to add another statement in case that this one is not fulfilled. So for example, imagine if this is not fulfilled, then we need to do something else, and that else will be in an if else statement. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And what we did in the previous one is we actually coded a simple, or we didn't code, we just checked out what the if statement can do for us. Right now, what we are going to do is we are going to check out what the if else statement does, and we are going to code a simple password checker for us. Now, first of all, before we start coding, let us check out the if else statement. So go up, open up your idle, or your Python 3, or however you want to call it, and let's actually check out what we can do with the if else statement. So first of all, we're going to do the same thing as in the previous video. So we will set some variable to be equal to 5, and we will set some variable b to be equal to 5 as well. And then we're going to perform the if else statement. So if a equals to b, we're going to print simply just, let me just find the single quotes. Okay, here they are. These two values are the same. So simple as that. So these two values are the same. What we want to do right now is just go right here. Let me just go right here. So else, oops, unintended does not match any outer indentation level. Let me just see, because I'm not really sure if I am supposed to tab it or not. So we'll just type it once again. If a equals b, print, and we will just print the same thing. These two values are the same. And we will then type here else. Unintended does not match any outer indentation level. What do you mean? Why won't you work like this? Or, okay, we'll just do it like this. It is rather easier, so just go to the new file right here. Or maybe we are not even supposed to tab the actual print statement. So let me just check it another time. Third luck. So print, these two values are the same. And then else. Okay, never mind. It says invalid syntax. We'll just go right here and we will do the same thing. So what we are going to do is set the a to be equal to 5, b to be equal to 5, and we are going to perform the if else statement. So if a equals to b, we'll print right here the same thing as we did in the previous 3 tries. So these two values are the same. in any other case, we will use an else statement, and there we will print these two values are not the same. So simple as that. So these two values are not the same! Exclamation mark. And what this basically will do is it will check, basically it will do as it says, it will check whether A equals to B. If it is equal to B, it will print this statement right here. If it is not equal to B, or if you, should I say else, it will print these two values are not the same. So let us try to run this module right here. So run module. Okay, so it must be saved. So let us go to the desktop, second program.py. Run it. These two values are the same. So you can see it finishes relatively fast. It prints out these two values are the same. So everything works perfectly. Right now, let me just find the program itself. Right now, let us switch it up a little bit. We will set the b to be equal to 3. And right now, if we perform this program or run this program once again, it shouldn't print this. It should actually print this. So let us go right here. Run the actual program, run module. It must be saved. We saved it, and you can see the different string gets printed out to the screen. So these two values are not the same. So that is the simple use of the actual if-else statement. Now you can do different things with it, such as, for example, let's check it right like this. If A is greater than B, let me just do it like this. We will not print this. What we will do is we will actually add B to B. We will add 2 to B. So B equals B plus 2. And then at the end, or right here, let me just first of all switch this as well. Right here, if the A is really bigger than B, or if A is not bigger than B, we will make A to be equal to A plus 2 as well. And at the end, we are going to print these two values. Print A and also print B. So what this will do, since A is 5 and B is 3, it will not execute this statement right here. It will only execute this statement right here. And these two print statements should actually print both 5. So both A and both B will be equal to 5. Now make sure that if you actually copy this right here, so copy these two statements, whoops, where did they go? Okay, so copy these two statements and put them before the if-else loop right here, you will see that we will get two different results. First of all, this will print out these two values, and then it will perform the if-else loop or statement, and then it will perform the different values. So let us run it. If I just click here on run module, save it, you can see we get printed out 5355. Since the first two values were A equals 5, B equals 3, and the second two values after the if-else statement was B equals 5 and A equals 5. So that is our simple if-else statement. Right now, let us code an actual useful program for the first time, which will be a simple password checker. So we're going to do it like this. We can use the same program right here. We're just going to delete all of this. And let us first of all think about it. So what do we need to implement for our password checker? Well, of course, there first of all needs to be a password. So let us just type here password. We will use a simple variable password to be equal to, for example, 1, 2, or let us just do something like this. Capital P or password 1, 1, 2, 3, which is the usual password that everybody uses. So this is the actual password. And let us think what we need to do in order for this to work. So first of all, the user of this program will need to input some password. Therefore, we already know that we're going to use that input function that will pause the program and wait for the user to type something in. Then what we need to do afterwards is actually just compare the inputted password with the password that the actual program has stored in this password variable right here. basically if they do match, which will be in the if statement, if they do match, we'll print access granted. If they don't match, we'll print access denied. Please enter the password again, or please run the program again. So let us see how we can do that. We will make a variable called user or inputted password, so inputted underscore password, so we know what this variable is and we don't confuse it with the password variable right here. We'll make it to be equal to the actual input, so input right here. We are using the input function. Between that, we need to specify the single quotes, and between the single quotes, we're going to specify to user what they need to do. So please enter the password. We'll specify 2 dots and a space, and this will basically just prompt the user with this statement right here. Then once we actually input the password, let us just convert it real quick to the actual string, even though this is not something that you should do, but you can do it if you want to. Sometimes it might present problems, so it is always good to do something like this so your program doesn't crash. So what we did basically is we created our inputted password to be equal to the string value. So if, for example, the user types in an integer right here, we don't really want an integer to be compared to a string because it will give us an error. We want to compare a string to a string. So all we are left to do right now is perform the if-else statement. So if inputted password underscore password is equal, so is equal to the password that the program has specified at the beginning, which is this one right here. We want to print, can print something like this, correct password, and we can print, oops, where is the quote? Okay, so here it is, access granted. And then in the else statement, so if user specifies basically anything that is not a correct password, we want to print simply wrong password, 3 exclamation marks, and also print access denied. So the user knows that they didn't get the password right. So access denied. And 3 exclamation marks. So simple as that. Let us save this program. So save it to the second program.py. And all we want to do is try to run it in our actual shell. So run module. Right here we can see we get the actual string prompted to please enter the password. And let's type here hello world. You can see we get wrong password, access denied. So hello world is not an actual password. Let us try to actually specify a wrong password once again. So run module once again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wrong password, access denied. Let us now try to specify the right password, which is the capital P, and then password 1, 2, 3. Let us run the program. Password 1, 2, 3. And you can see correct password, access granted. So our actual password checker works correctly. This is first useful program that we actually coded. It is rather short one, as we can see. It is only few lines of code. And there it is really easy to understand, nothing really too complicated here yet. And basically that would be about it for this tutorial. What we're going to do in the next one is we're going to take a look at the if-else statement with multiple else-if statements. Now, what I mean by that is sometimes, for example, you want to check three different outcomes. For example, if inputted password equals to password, also if inputted password equals to password in capital letters, else, and then some different things. So, for example, that. Or if number, you will see the example that we are going to do will be if number is greater than 0, print number is greater than 0. If number is equal to 0, print number is equal to 0. And also if number is smaller than 0, print number is smaller than 0. That is what we are going to do in the next video. So hope you enjoyed this tutorial, and I hope I see you in the next lecture. Bye! Hello everybody and welcome back to this tutorial. And in the previous video what we saw is we coded a simple password checker. We also were introduced to the if-else statement, and what we're going to do right now is we're going to see what the if-else statement can do once we have actually multiple statements that we want to specify. We're also going to write a simple example to demonstrate that thing. So if-else statement has something called else if, which you can add in between the if and in between the else statement. So I mean in between those two. There can be as many else if statements as you'd like, or as many as you need, and then you can code them into your program. So let us see how that will work. Open up your idle right here. We're going to open a new file. Let us right away save it as thirdprogram.py. So save as to the desktop, thirdprogram.py, and press here enter. And right now we're going to code this simple program right here, or let me just, there's no need to actually enlarge this. Let us code it like this. So let's think about it. So first of all, let us do something like this. Inputted number, so inputted underscore number will be our actual variable that will store a number that the user will specify in the program itself. So once they run the program, we want to use the input function, and we want to prompt the user to specify any number they like. So specify any number you want. This will get prompted to the actual user. We can then print the number if we want to. So inputted underscore number. And right now, right here, we're going to get into the else if statement. So first of all, we want to check if. So if inputted number underscore number is bigger than 0, so simply just specify it like this. What we want to print is print okay, here it is, inputted number, and then we can concat the string, so plus the string of inputted number, and then plus another string which will be, for example, is smaller, or is bigger, pardon me, is bigger than 0. Let's also add a space right here so we don't actually concat the string right one behind another one. So basically what we are printing right here is if inputted number is bigger than 0, we basically are going to print inputted number plus the string of the inputted number, which will just transform this integer value right here to be a string. So first of all, before we actually convert it, let us type it right here to be an integer. So inputted number is going to be equal to integer of the inputted underscore number. Just in case, we're only going to use the string value of it in the print statements, and we're going to print inputted number, then the inputted number string is bigger than 0. And then we want to type here else for the second statement. So else, it is smaller than 0, of course. So else print inputted number. Basically we want to do the same thing, so plus string of the inputted number itself, so inputted number close the brackets plus, and then we want to write right here is smaller than 0. Right here we do not need, or we can use these actual two dots. So let me just add it right here as well. But you might notice what happens if the user types 0. So let us actually take a look before we actually code the rest of the program. What would happen if user specifies 0? So run module right here, save it, specify any number you want. Let's first of all check it whether it works for the numbers greater or lesser than 0. So 3. we print out the number itself, so right here, and we get inputted number 3 is bigger than 0, which is correct. Now let's try with a different number, so run -3. Inputted number -3 is smaller than 0, so our program works perfectly in these two cases. But we also have a third case where we actually can run the program and the user can specify simply 0. And it says right here, inputted number 0 is smaller than 0. Now the reason why it says this is because it is in the else statement. So what this program basically did is it checked whether 0 is greater than 0. Then it will print this. In any other case, in basically any other case, it doesn't have to be the case where the actual number is smaller than 0. It also can be equal to 0, as in our case, it will print the inputted number is smaller than 0. But we also want to add an else if statement in between, which we can add just like this. So else if, simply just specify else if, it is shortened for else if, then 2 dots, or basically not 2 dots, you want to specify the statement. So else if inputted underscore number equals to 0, then we want to print, let's go right here and print inputted number, and then plus the actual string of that number, string of the inputted number, and then plus open single quotes is equal to 0. And basically this should be the entire program. Let us see how this will work. So we added another else if statement that will check if the inputted number is equal to 0. So let us save this first of all. So save and then run it right here and specify any number you want. We specify 0 and you can see inputted number 0 is equal to 0. You don't need to actually do it like this if you don't want to. You can basically just simply delete this right here. And for your own needs, if you, for example, wanted to do something like this, you can also use a simple if-else statement, but also add right here equal sign, so greater or equal to 0, then print inputted number plus string inputted number is bigger than 0 or equal to 0. Let me just move this so we can see the entire program. And then you can save this right here and you can run it like this as well. Basically, you will not have an else if statement. What you will do is you will simply print out once the number is greater or equal to 0, you will print inputted number is bigger than 0 or equal to 0, which really doesn't make any sense. The previous version is a lot better, but if you need something like this for any case you want, you can do it. So let us run it. Specify -2. Inputted number is smaller than 0. Let us run it once again. So run module. Then let's specify 3 is bigger or equal to 0. And also once we actually specify 0, it should print out the same thing as we can see right here. So the inputted number 0 is bigger than 0 or equal to 0, which is actually kind of correct. It is not bigger than 0, but it is, however, equal to 0. So that would be a simple example of the else if statement. We covered fully the if statement with the if else and with the else if statements. So that part is finished. What we are going to do in the next video is we are going to cover the while loop. So hope you enjoyed this tutorial and I hope I see you in the next lecture. Bye. Hello everybody and welcome back to this tutorial, and right now we're going to take a look at a different loop which is called the while true loop or while loop. Basically there are different types of this loop, whether they are infinite or not. We're going to cover both of them in this tutorial. I will show you different examples for this actual loop, how you can use it, what you can do with it, and where you can use it as well. So open up your idle right here. Let us open it up. let us try to code it right here. If it gives us some syntax error, we will just open up a real program or Notepad or something like that, and we will code the program there. So first of all, while loop is most likely always going to be used with the Boolean values. There are a bunch of these. You will see in different programs there are a bunch of while true loops. Basically, a while true loop is a loop that is most likely going to be infinite until the value is changed or until the loop is broken out of. Now, what I mean by that is basically, if you type while true, so while true, let me just show you, and add 2 dots, and you just type here print hello. Let's imagine what this will actually do. So while true, and true is always true, you can't change true to be equal to false, it will print hello. If I press here enter, you can see it will print hello string forever, which we don't really want. So let us control C this. As you can see, if you control C, it will print out keyboard interrupt, which we actually want to do. If you didn't do this, this would run forever. So same as that, you can just type here something like while true, and then, or let's do it something like this. So I will be equal, let me find equal, okay, I will be equal to 0. So we set a variable I to have a value of 0. Then what we will do is we are going to do something like this. So while true, let us increase I by 1. So I equals I plus 1. You can see nothing is really happening, there is nothing being printed out, but we are also not getting these 3 arrows prompted back to us. That is why this is an actual while true loop, and it will perform this forever until we actually perform a keyboard interrupt to this while true loop. It will increase the I, which we set to be equal to 0, for 1 every iteration. So what it does, it goes to this line, it performs this line, it sees that there is not another line in the actual loop, it goes to the beginning, it performs this line again, and it does that forever. So if I control C this, and just type here print underscore I, you can see that the I now has a value of something around, I believe, 36 millions, or even more, 364 millions, if I can count the digits well enough. Probably can, but doesn't even matter. So you can see the usage of a while true loop. Now, I will show you in the next tutorials how you can actually escape a while true loop, even though it is infinite, without actually closing the program itself. So there is an actual statement or word that we can use that will help us do that. But for now on, let us check out what else we can do with the while loop. So it doesn't have to be a while true loop, it can also be while false loop. But then if you just type here something like this, while false, I equals to 0, and you just press here enter, you will see that nothing will get executed, because while false is always false and it will not execute this loop. Therefore, this actual loop has no meaning at all. So now that we checked out the while loop with the Boolean values, let us check out the while loop with normal values. So we're going to set our I variable back to 0. So it doesn't have this huge value to it. We will set it to be equal to 0. And what we are going to do is while I is greater or lesser than 100, for example. So let's do it like that. Then add the 2 dots. Let's see what we can actually do here. So we can just type it. We can just do something like this. So print I, or let me just add a single quote. So I is still smaller than 100. And then we can add 2 spaces and add the actual string of the I to the actual statement right here, and close another bracket, because we opened double brackets. We also need to close double brackets. And also, if I just run this, this will also become an infinite loop, because we are not increasing I anywhere. If I just simply run this, it will print this statement forever. What we want to do, so it doesn't do that, we want to increase I by 10. So let's just do equal, I plus 10. Oops. And if I run this, you can see it finishes relatively fast. It says I is still smaller than 100, and then it prints I right next to it. So we can see that I was smaller than 100 up to the 90. Then in the next iteration, what this did is it checked out, or let me just go from the beginning. So first of all, I was 0. This then loop checked whether I is smaller than 100. It found out that I indeed is smaller than 100, and then it proceeded to execute the code in the while loop. It printed out this statement right here, and then it increased I by 10. Now, then it performed that until the 90. Then you can see that it checked out whether 90 is smaller than 100. It printed out 90 is smaller than 100, and then it increased I by 10. Then in the next loop, it checked out whether 100 is smaller than 100. It found out that 100 indeed isn't smaller than 100, and then it didn't proceed with the next statements in the while loop. But let me show you how you can actually change the output of this just by switching these two lines right here. Well, let me just think about it. Maybe it is not right here if 90 is smaller than 100. Yeah, let me show you like this. So what we will get right here is we will not have this statement right here. Instead of this statement, we will have 100 statement, which will not be correct. Therefore, be careful which line you write first. So let me just show you. If only I switch these two lines one with another, this statement will become different. So if I is smaller, first of all, let me set I to be equal to 0. And then if I is smaller than 100, pardon me, while I is smaller than 100. And then, first of all, we will increase I, so I equals I plus 10. And then we will print I is still smaller than 100. We will have to add the string of the I, so plus string of the I itself. Whoops. Close double brackets and press here enter, and you can see we get an entirely different output right now just by switching these two lines. Even though we perform the same code in both of them, you can see that right here we don't have this line right here, and we instead of it get the 100 printed out, which is not really correct. I is still smaller than 100, and then I is 100. That is not really correct. Therefore, be careful which line you write first. So first of all, write this line and then increase it right afterwards so it can go to the next loop. So let me just check out what else we need to cover. We can also show another example of the while loop. So let me just show you. It doesn't have to be while I is smaller than something. It doesn't also have to be while true or false. It can be while. First of all, we set once again I to be equal to 0. We will reset it. And then while I is not equal, so we perform is not equal by specifying exclamation mark and then equal right here. So while I is not equal to the, for example, 100, what we want to do is basically, let's do something like this. So I equals input, so we will prompt the user to input a number, enter any number. So this could be something similar to the actual password checking. So we are doing this in an infinite loop until the user actually specifies the correct number that's specified in the program. So I'm going to show you that in the right after this as well. So enter any number. And then we can actually, or we don't really need to print anything. Let us just enter right here. So 92, we get prompted once again, 23, 33, and if I just type here 100, oops. Okay, so 100. Let us try something differently. Okay, yeah, we got a string of 100. You know, I forgot to actually add I equals the integer of I. So let us just rewrite this real quick. So while I, first of all, set I to be equal to 0, while I is not equal to 100, we want to perform the input function. So I will be equal to input, enter any number. Simple as that. Then we want to make I to be equal integer of I. Or you can actually do that in this line as well. So you can do something like this, integer out of the input. You don't have to do it in a second line. So let us delete this right here. Now, since you're firstly encountering with something like this, what this will do is it will perform the function inside first. So it will prompt us to input this, then it will turn it to integer and store it in I. So let us see how this will work. Press enter, 23, 33, 44, and then 100. And you can see once you specify 100, it checks out right here if I is equal, if I is not equal to 100, then it sees I is equal to 100, therefore it will not perform this. So this is another useful type of usage for the while loop, where you simply check whether a certain value is not equal to another certain value. Now let's see how we can actually write this for the password. So password will be equal to, for example, let's use something else. So right here we can use hello world. So that is our password, our standard good old hello world string. So right now we want to enter a while true loop, or not a while true. So while, well, let me just double check this first of all. Okay, so we can do something like this, while inputted underscore password is not equal to the password. We want to prompt the user, so inputted underscore password equals input enter password. So let me just try right here. Input password is not defined. Yeah, I thought so. Let me just go right here. Inputted underscore password equals, or let's think about this. Maybe we can actually approach it with a different principle, also using the if-else statement. Let me just think about it. Yeah, okay, let me first of all try it like this. Enter password, simple as that. And then I enter the actual while true loop. So let me just do it like this. So hello will be our password, and right now while inputted underscore password is not equal to password, inputted underscore password will be equal to another input. I'm just checking something out, whether this will work or not really sure. We'll have to figure it out. Inputted password is not defined. Yeah, because we actually called it input password, not inputted password. So let me just fix that real quick. So input password is not equal to password. Input underscore password equals input. I'm really curious whether this will work. We are going to have to check it out. Okay, so enter password. We are right here getting prompted to enter the password. Let's add 1, 2, 3, hello, and then just world, password. And if we just specify the correct password, which is hello world, I believe, we get exited out of this program, which means we specified the password correctly. So that is good. So basically that is all we actually have about the while loop. Of course, we are going to use it and abuse it later on, of course, in the actual real programs that we are going to code. For now, this is just some of the basics. So I hope you enjoyed this tutorial, and I hope I will see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now we're going to take a look at a different approach to the while true loops, or basically the infinite loops. We're going to learn how we can deal with them, how we can actually close them even though they are infinite, and break out of them with a simple command. So what we are going to do is we will code the same program from the previous video. That's why I was so confused, because I didn't want to show you how to properly code it until we actually get to the break statement right here. And right now we're going to code a password checker with the actual while true loop. What this will do is it will actually prompt the user to enter the password for as long as they don't specify the correct password in the program. So first of all, let us write the simple program. We want to open a new file, so we want to open this right here. Let us save it right away, so save as to the desktop. We can call it fourth program.py. Okay, we saved it, and right now let us actually see how we can do this. Now this will be a little bit harder than the previous videos or the previous programs that we did, especially for the beginners, because we're going to do something which we haven't done before, which is going to be embedding an if-else statement into a while true loop. So you will see, trust me, it is not really that hard. It is rather easy. Just try to make sure that you understand it the best you can. So first of all, we will start off by actually setting the password as usual to be equal to anything we want. So we can set it to be equal to, right now, let us switch it up. Rainbow is the password. And let's actually add the capital R right here as well, just for the thrill. And right here, we are not going to actually prompt the user to input the actual password right here. We are going to prompt the user to input the password in the while true loop itself. So, you know, in the previous video, what we did is we actually prompted the first time we prompted the user to enter the password outside of the while loop. And right here, we want to type while true, and then we want to prompt the user for the password. So while true, inputted underscore password is equal to, let me just check this out. Okay, so is equal to input, and then we want to specify to user enter the password. Okay, so we prompt the user in the while true loop to enter the password. Now if you just ran this program right now, what this will do is it will basically prompt the user forever to enter the password. But we don't want that. We want the user to actually get the access granted string printed out once they actually get the password correct. So we can do that with the if-else statement. So if inputted password, so inputted underscore password is equal to the password. So this is something that we are already familiar with. We did something similar to this, so nothing really to explain right here. If inputted password is equal to password, we want to break out of the loop. So basically what we are doing right here is we are breaking out of the loop. In any other case, we are not going to break out of the loop. It will just go right back right here, and it will check whether the inputted password is equal to password. If it is not, it will go right here and then back to the beginning of the while true loop, prompting us to enter the password once again. And if we manage to get it, we want to print right here password correct, and then in the next line access granted. So let us take a look at this once again. This is a rather short program. We set the password variable to have the password itself. Then we enter a while true loop, which is an infinite loop. Then we prompt the user to enter an actual password. We compare these two passwords, so we check whether the inputted password from the user is equal to the password specified in the program itself. If it is, we're going to perform a function called break. Now, as I said before, this break function will simply break out of this loop, but it will not close the program. Don't confuse it with closing the program. This will only exit the while true loop, and then it will continue executing to the next step, which will be print password correct and print access granted. The reason why we're actually printing this right here is because this part right here can only be accessed once the password is correct. If the password is not correct, this will run forever. So let us see how this will work. If I just go right here, or first of all, let me save it. So save, and then I run it. You can see we get prompted enter the password. If I just type here password, it will ask me again 123, password 123, hello world. Nothing really works. Even the lower letter rainbow will not work, as you can see right here. Rainbow will not work. But once we actually specify a rainbow, we get password correct, access granted. So we were successfully able to actually code a password checker with a while true loop that has an if statement in it. So this would be a more appropriate way to actually code a password checker than in the previous video. What we are going to do in the next video is we're also going to take a look at a continue function in Python 3, which is also going to help us with the loops themselves. So that would be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial, and right now we're going to finish up and wrap up with our while true loop, or just while loop, however you want to call it. Now, the case that we are going to take a look at right now is how we can, for example, break out of the loop or use the while true loop or the infinite loop, however you want to call it, in the case where we actually have a counter, such as in the previous examples where we had I, then we checked whether I is smaller than 100 or whether I is not equal to 100, and then we perform some tasks. So we are going to do the same thing, just right now we are going to use a while true loop. And we are going to see how we can actually make it work even with an infinite loop. So open up your idle. Let me just go right here, type here idle. And right here, what we can actually do is, first of all, we will open the new file. The reason behind that is because we are going to actually use the if-else statement, and the actual idle gives me some problems with the syntax while I try to run the if-else statement. Doesn't even matter. We're going to write a program right here, and we're going to use a function that comes in Python, which is called the continue function. Now, what this function does is basically it just continues the program. It continues the loop, and it runs it back to the beginning. So let me show you right here what we can do. So let's say that the I is equal to 0, for example. And then let's say we want to enter a while true loop, as we do want indeed. So while true, and this is an infinite loop, as we know. We're going to perform some if-else statements, so just add if right here. So let us think about what we can actually perform right here. So if I is smaller than 100, so let us try to perform the same actual example that we did with the while I is smaller than 100, just right now we're doing it in the infinite loop. So while I is smaller than 100, we want to actually continue, and then we want to increase, pardon me, not increase, or yeah, we want to increase, so I equals I plus 1. So what this will basically do is it will increase I by 1 as long as I is not bigger than 100. In the else case, let me just check out right here. If I is smaller than 100, in the else case, we simply want to break out of the loop, because it means that right now I is smaller than, I is bigger than 100. So let us see how this will work. First of all, we need to save this. So go right here on the save. Click here. Let's call it, let's go to the desktop first. Let's call it fifth.py. And then we can run the program with the run module. So let me just see, something is not going well because we are stuck in the actual loop. Let us see what the problem is. So I is equal to 0 if I is smaller than 100, which it is. Continue. Oh yeah, we are not really increasing it. We need to do something like this, which really you can make this work even without the continue, but you can add it if you want to. So I equals I plus 1. Continue. Let me just check out right here. First of all, save it and then run it. Okay, so this worked much better. Let me just check out how we can implement the continue in order for it to actually do something. So if you switched these two, or not switched, if you instead of the break right here clicked continue, you would see that our actual while true loop continue would never really end. This is because it will go right here and it will go in circles. Now the I would never cross 100, but our loop would never end either way. So let me just show you. If you just click here save and run the actual module, you can see that we are not getting our prompt back. We cannot execute more commands because our while true loop is running in infinite mode. It is basically continuing and continuing in an infinite loop. And if I just Control C and print I right here, it is still 100. No matter how long we actually ran that loop, it would still be 100. It would not increase. Basically that loop, what it did, it didn't do anything. It just performed in every check whether I is smaller than 100, and it just continued to the beginning of the loop. So this is just a rather short tutorial showing you the continue function, which can be used in the while true loop, has some useful stuff with it, which we will show later on. But for now on, that would be about it for the while loop, and it is time to actually introduce ourselves with the actual for loop. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now what we're going to do is we're going to take a look at the for loop. So we already covered the if statement, the if else statement, the while loop, the while true loops, how to break out of them, how to continue in them. We coded some of the some of the useful programs such as password checker. Really nothing special yet, but hey, that is something as well. So let us go with the for loop right now. In order to do that, we can just open up our idle, and the for loop usually, but doesn't have to be, but usually comes with the statement or the function range. So what that means is that it allows us for some counter in range, from example from 1 to 100, we want to perform a certain task. Of course, in that counter, in that for loop, we also want to increase that counter every time we perform that specific task, because otherwise that would be an infinite for loop, and that is not really that useful for us. So let us see how we can actually implement the for loop. So first of all, while you are actually using the counter in the for loop, it is good to notice that you don't really need to define it before it. You can actually use it, or the for loop defines it itself. So for I in range, for example, 1 to 100, as I said, so like this, add the two dots, and right here, for I in range 1 to 100, you want to perform some specific actual function or some specific task right here. So we can just print hello. We're not really doing anything specific, but I'm just showing you how you can do that. And then, of course, you need to increase the counter right after you perform that certain task. Otherwise, this would not make any sense. So you want to increase it. I equals I plus 10. Press here enter once again, and we get printed out the actual, pardon me, this is a for loop. Yeah, I forgot. You don't really need to actually increase the counter in the for loop. The for loop increases it itself, which is another good thing. So for example, let me just do it once again, since we actually added a line that we don't need. So for I in range 1 through 10, so let us use it 1 through 10, print hello plus string of I. So this will be printing out hello 1, hello 2, hello 3, hello 4, and so on until hello 10. So just type here, right here, enter. It finishes our for loop. You can see that right here we didn't really increase the counter. Not really sure why I told you that you need to increase it. I maybe mistook it with the actual while loop and if statement. In the for statement, you don't really need to do that. The for does it for you. The for statement does it for you, as we can see right here. For a certain counter I in range from 1 to 10, we're going to print hello. And it printed out hello 10 times. Starts counting from 1 and goes through 9. The reason why it doesn't go through 10 is because the 10 is not basically considered as in the range itself. So there is also another thing that is mostly used in the for statement as well. This is a function that we already encountered before, which is the length. So if we just specify a string, for example, now I will use it with a string, but it is most likely used always with the list itself, counting the elements, but right now we're going to count the characters from a string. Now if you have no idea what I'm talking about, don't worry, right now I will show you. So let's say we have a string that says, let me just find it, that says hello there. Simple as that. String that says hello there. Then you can use a for loop that will actually go through the range of the length of that certain string, which isn't really that useful for us right here as a string, but it would be useful if we had a list. We would go through the range of the length of that list, and the length of that list would be retrieving the actual number of elements in that certain list. So let me just show you what I mean. Let us first of all count how many characters are in this string. So 1, 2, 3, 4, 5 in hello, 1 empty space, and 5 more in there. So 11 characters in this string. Then we can use for I in range, and then open brackets, length, open another brackets, from the string, close to brackets, and then, let me just go right here, 2 dots, print, this is length of string. Doesn't even matter what you print, this is just so it prints something. You press here enter, and it will print this is length of a string the same amount of times that there are characters in the actual string itself. So this right here is the actual, first of all, it performs the inner function, which is the length. The length of string is 11, and what this does is for I in range 11, so 1 through 11, this will get printed out. And that's why it gets printed out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So that is basically a simple usage of the for loop. Now, also, there are a few other things that you can do with it, which we are going to cover, such as, for example, this range right here doesn't have to be an actual specification of 1 through 10. You can actually specify it to count 1 through 10, but every second steps, for example, it will print out every second number. This will get shortened out from 10 times printed out to 5 times printed out. And you can specify that with the another comma and then the number that you want to skip. So for I in range 1 through 10 and then comma 2. What this means is it will go for I in range 1 through 10, but each time it will not increase I by 1, it will rather increase I by 2. So that would mean that, for example, if I is 0 at the beginning, or pardon me, 1 at the beginning, it will be 3 in the next turn of the for loop. So I will show you right now, it will print it only 5 times. So print, this will get printed 5 times. Close this, and you can see this will get printed 5 times. Now if you specified any other number here, such as for example for I in range 1 through 10, and then the actual 5, so that means that this will get printed out 5 times. Print hello. No, pardon me, 2 times, not 5 times. This will get printed out 2 times. Close the brackets, and you can see this gets printed out 2 times. Now also one more important thing, well not so important, but one more thing that you should know is that you can actually count backwards with for loop. So you don't need to type here for I in range 1 through 10, you can simply type here for I in range 10 through 1. But right here, you need to also specify how to adjust the I variable. So we need to actually subtract it every time by 1. This will also print the actual statement 10 times, but it will go from backwards. In case you want I to go from 10 to 1 instead of 1 through 10 for any reason you want. If you want, for example, to print a list like this, so let me just show you. For I in range 1 through 10, and you simply just print I, you can see it gets printed out 1, 2, 3, 4, 5, 6, 7, 8, 9. But if you just type here for I in range 10 through 1, and then comma minus 1, and then you specify print I once again, you can see it gets printed out in 9, 8, 7, 6, 5, 4, 3, 2. So it goes backwards. Now in some cases that might be useful. For us it really isn't at the moment. I just want to show you that there is that option as well. And basically that is all for the actual for statement. Now what we are going to do in the next lecture is we are going to cover some of the modules, importations, library importation, and how you can use different libraries that are already pre-installed with Python 3. We'll take a look at some of them. Now we will not, of course, use many of those functions yet. We're only going to see how you can import them and how you can use them. So hope you enjoyed this tutorial, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we are going to take a look at the import function in Python 3. Now, importing modules is very important because it allows us to import different Python programs into our own program, which allows us then to use different function methods from that specific program. Now, we didn't cover functions yet, but basically our function is everything that performs something. So, for example, the print is a function, the input is a function. We will cover and code our own functions later on. But for now on, let's see how we can use those functions from different libraries that the Python 3 gives us. So open up your actual, open up your idle right here. And in order to import some library that you need, such as basically all of your real actual programs will need some libraries. For example, the OS library, the sys library, subprocess library, socket library for networking, and so on and so on. In order to import any of those, you can just type here import. And then afterwards space and then the name of the library itself. So let's, for example, import first the OS library. Now, the libraries are most likely always going to be imported at the beginning of the program, right at the top. So you import all the libraries you need, and then you perform your own code down below. Now, let's see some of the actual functions that we can actually get from this OS library. So, for example, in order to access a function from this specific library, you need to specify first the name of the library itself. So in our case, that is the OS. So just type OS, then dot, and then you specify the name of the function. So you can see right here, let me just go right here. Right here, by default, the Python interpreter will give you the name of all the functions that the OS library has, so you don't actually have to remember them. But right now, what we are searching for is the system library. The system function. What this function will allow us to do is to actually, for example, create files, delete files, and do anything, or basically send any command to our system. So, for example, let's execute a command cd. If you just type here enter, let me just put that into an actual, never mind, you can't really do that, but you can do something like this. I mistook this library with the subprocess library, which I will show you just in a second. If you just go right here, new folder, create it, call it test, and try to perform the os.remove and then the name of the folder itself. So if you just specify between the single quotes test and press here enter, the system cannot find the specified file test. Okay, maybe, yeah, of course, because this is not really in the actual path that the actual folder is. So just go right here onto the new file, import OS, and then use os.remove, and then between the single quotes type test. Save this on to the desktop or save it to the same folder where your test directory is. So save, I want to save it right here as the remove.py. Save it. We can see that our program, let me just find it. Oops, where is our remove.py? Okay, so here it is. If we run it, run module, access is denied for test. For some reason we get access is denied, but never mind, we can just, oops, let me just try it like this. For some reason we get access is denied, but it doesn't even matter. Let me just check out what happens if I just use system and then, for example, dir in between. Will it list it right here? Yeah, probably not. It will only execute it, doesn't even matter. We will check the output with the subprocess library. What matters is that we can actually create the directory with it. So let me just go right here, save as once again. But not this program, we want to create a new one. And we want to do the same thing that we did, just into a different directory. So import OS, and then file save as. Or let's just try to create an actual directory. So we'll use os.system. Even though this is not how you should create files, we can try to do it. mkdir test. We save it right here, which is in the app data local Python 37. So right here should the test should be actually saved. So let me just save it right here. Let's call it again remove.py because it is not in the same directory. We can call it like that, and I will run it from my command prompt. So cd app data, cd roaming, cd programs, or was it programs? Cd local, maybe there, cd programs, cd python, and change directory to Python 37. If I just type here dir right here, we have the remove.py. So if I just type python.exe, remove.py, and just type dir once again, we have the test directory created, as you can see right here. So we have the test directory. Let us just check if we can go from here. Yeah, it is right here. Test directory has been created. Of course, it is empty. So we successfully created the directory with our remove.py program. No, we don't want to replace it. Okay, so that is our first library that we actually saw. So right now, let us close this and let us try out with a different library. So there is a library called random. So import random. What this library would basically allow us to do is to pick a random number, random integer value. So let us combine this library with a for loop that we covered before. So for I in range to 5, so we want to specify from that I goes from 1 to 5, we want to print, for example, random.rand integer, which means that we are using from the random library a function called randint, which will basically just pick a random integer from the numbers between 1 and 100, for example. So we can specify it like this. If I just press here enter, you can see that this function right here, or not function, this for loop right here, will print out 5 random numbers that are in the range from 1 to 100. This for I in range 5 basically means that we're going to print 5 numbers, and this print random integer basically prints random numbers which basically does it 5 times because we are in a for loop. So that is another example of actual library that we can use. Let us also check the output of our command prompt commands using the subprocess library. So import subprocess. Now, of course, if you're not familiar with any of this and you're actually confused while listening to me talking about this, don't worry, we're going to cover all of this in greater detail. Right now, I'm only showing you examples of importing different libraries and using their functions. So, there is a function in the subprocess library called checkOutput, which allows us to check the actual output of a certain command being executed from our PC. So, for example, if you go to the command prompt, open up your command prompt and type dir, you can see that it actually lists all the files in that current directory, which is this directory right here. So these are all the files in that current directory. What we want to do is we want to get that same output just with our Python. So in order to do that, we can just type here output will be equal to subprocess.check_output, which is a function that we will use from the subprocess library, open and close brackets, and in between the single quotes right here, you need to specify the command that you want to execute, which in our case, since we are on Windows, we want to execute dir. If you're on Linux, make sure to execute ls, because ls lists all the files in the current directory on Linux. Now, after it, we need to specify shell equals true, and that is basically it. If you just type here enter, it will execute this, and if we print the output, it will print it rather in a different format, but it will still print the current directory from this program. Now you can also do something else, such for example, you can execute a different command. So let me just do the same thing. We can use cd command. So output will be equal right now to subprocess.check_output. We want to execute cd, and cd basically in Windows will print you the current working directory that you are located in, and in the Linux, if you're using Linux, just type here pwd, which stands for print working directory. Again, shell equals true, and we want to print the output in order to see in which directory is our program. We can see we are currently in the desktop directory, which is true. And right now, subprocess also allows us to, for example, execute different things. So we can actually create a file with this actual program right here, I believe. So let me just check it out. Subprocess.popen, or not popen. We want to use the, we can use popen, I believe. Let me just check out. Or we might actually get the actual access denied as before, but let us just give it a try. It doesn't even matter. Shell equals true. In this window right here, you can see all the things that you can specify for this function, which we really won't specify right now. We don't really care about them at the moment, so let us click here enter, and we successfully did create the test directory. I'm not really sure if it was here. Yeah, it probably wasn't here, but doesn't even matter. We successfully created a file test on our desktop. Now, this is not the proper way to actually create files. I will show you later on, once we get to the file section, how you can create, manipulate, write, and read from the files. But for now on, that would be about it for this tutorial. Hope you enjoyed this little demonstration of importing different libraries, and I hope I see you in the next tutorial where we will continue coding. So hope you enjoyed it, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to our Python programming course. And in the previous section, what we did is we covered some of the basics of coding in Python, such as for loops, while loops, if statements, and so on. We also introduced ourselves with different types of variables, strings, integers, floats. We saw how we can convert one to another. Basically, what we did are basics. Right now, we're going to go into some more intermediate stuff, which is functions. Now, what functions allow us to do is, for example, once you actually start coding some larger programs that have some part of a program that will actually repeat itself throughout the code itself, you want to create a function that will do that certain part. That's how you can actually call that function every time you need it without coding the same part of the program twice or multiple times. So, we're going to introduce ourselves in this section with different functions. I will show you how you can make a function, how you can create useful functions, and also we're going to take a look at some of the coding examples after we cover the basics of the functions. Now, those coding examples, of course, won't really be anything special. They're going to be simple programs, but for now on, that will be more than enough. So let us start up. We are going to open up our idle as usual. So just type idle, open the idle for Python 3. And basically, we already introduced ourselves with some of the functions in the previous section. We just didn't, if you are a beginner, you probably just didn't know they were functions, such as, for example, the length function, the range function, the print function, the string function, integer, and those functions that we did in the basics of programming. Now, for example, once you type print, and then in between the brackets you type here hello, you basically call a function called print. And what you specified in between the brackets are the parameters to that function. So I will show you basically, let's say we want to create our own length function. So for example, we have a string that is going to equal, let me just find, okay, so equal hello. This is our string. It is a variable that stores this word. If you just type your string, you can see it is right here. And we know that the length of the string will return the number of characters in that specific word. So let us see how we can actually return the number of the characters in this specific word without using the length function. Now we can use different functions, but we cannot use the length function. But before we actually do that, let me show you how you can define a function itself. So for example, let us create a function, let us create our own printing function. So we don't want to use print and then something. We want to, for example, use my_print, and then in between the brackets we specify what we want to print. So in order to define the function with a specific name, you just type here def and space, and then you type the name of the function that you want to create. In our case, let us say we want to create my_print. So this is the name of our function, and that function will take, it will take a parameter of the string itself. So string right here. Now don't worry, I will explain everything twice so you don't get confused. Now this is basically the parameter that we are going to paste to this function, and then once you press here enter, you can see that the code will become indent. That means that you're coding the part of the function itself. So right here we want to create print, and then we want to print the actual string. So print string. We press here enter, and there we have our own function. So right now, if we just type here if we create a string1 to be equal to, let's say, football. Okay, and instead of using print and then string1 in the brackets, we can right now use my_print and then string1 between the actual brackets. We will get the same result right here. This is because we created our own print function that actually uses the print function itself that is inbuilt in the Python in order to print the string. Now this is not really anything useful, but this is just an example of how you can define a simple function. Now, there are different types of functions. This one specifically was the one with the parameter, since we specified something in the brackets themselves. Now, you can specify a function that doesn't have any parameter in it. For example, let's say you want to create a function that will always print hello world. So def hello_world, underscore print. Now you can call it anything you want, I just call it like this. And in between the brackets we don't specify anything. We add the 2 dots after the brackets, and now we want to code the part of the function that will always print hello world. So 2 single quotes and then hello world. Now we have a hello world print function that every time once we call it, so you can see right here, if I just type here hello underscore world underscore print and add the closed and open brackets, you can see it will print hello world. Now, once again, this is not a useful function, this is just an example. As I said before, the functions will be used once you need to cover a large part of the program that you will reuse later on, so you don't actually type it twice or multiple times. That's when you use a function. Right here we saw 2 different examples of a function with the parameter specified that we paste into the code of the function itself, as you can see right here. And one of those is the one that doesn't even have any parameters, it just does simple work such as printing hello world. It doesn't need to take any parameter needed. So right now let us see how we can actually return from the function. So sometime you actually want to return something from a specific function. Let's say our function is a little bit larger now, so let us actually code something useful. For example, let me just open a new file. And right here, what I'm going to do is I'm going to import a library that we used before, which is the random library. Now, what I'm going to do in this program is I will pick a random integer between 1 and 5, and then I will print a different statement for each number that the actual random library picks. We will do that using a function, and then we will print the actual string. Now, let me show you. So we imported the random library. You remember the actual random.randInteger function that we used before, which will generate our random number for us. But before we actually do that, we need to code the function that we're going to use. Now, functions are almost always coded at the beginning of the program, and then down below you're going to code the actual program that will call those functions. So first of all, we need to code the function. Define get number. And what this function will take as an input is a number. Simple as that. Now, since we don't really know what we want to code for now on, we're just going to leave it right here, and we're going to code the rest of the program right now, and we are then going to go back to this function and code it appropriately. So, we want to first of all generate a random number, so we're going to use a random underscore number variable, which is going to take a random number using the random library. So random.randInteger. We're going to take a number from 1 to 5, as it says right here, return random integer in range A to B, including both endpoints. So 1, 5, we want a number between those 2 values. Then, what we're going to do is we're going to call this function and store its value into a certain variable. So what we're going to do is we're going to call a variable pick. So pick will be equal to get number from the random number. Now, if you're confused, don't worry. I'm going to show you right now what we're going to do, and then we're going to print our pick. So this is the actual entire part of the lower program. All we're left to do is actually to code the function itself. Now, what we're going to do right here is we're going to use an else if statement in order to check out what number we got between 1 and 5. So we paste the actual number or the random number to the function right here. So make sure once you actually paste the random number to the function, you need to use the actual word that you specified between the brackets. So you can't really use random number right here. You need to use number, since that is what we specified between the brackets. Now, between the brackets, we could have specified anything, such as, for example, number 1, 2, 3, and then we would have to use a variable called number 1, 2, 3. But for now on, we're just going to use number. So, if our number that we picked from the random integer between 1 and 5 is equal to 1, what we're going to do is we're going to use a return from the function, and what we're going to return is we're going to return a string. So return, and we can use it. The number is 1. This is what we are going to return. So if the number that was picked was equal to 1, the actual value that would return into this pick variable right here would be the number is 1, since that is what we are returning to this variable. Now, if the number, or else if the number is equal to 2, we're going to return the number is 2. Simple as that. It's really not that hard to understand. And we're going to do this for the for every possible outcome. So 3, return, the number is 3. We are left to do 2 more. So else if number equals 4, return, the number is 4, and we are left the 5. So else if number equals 5. Now you don't need to use else if right here. You can also use else, since this is the last actual available option, but it doesn't even matter. We can also use else if. So else if the number is equal to 5, we're going to return the number is 5. So this is our entire program. Basically, let us go over the code once again. We imported the library. We created a random number using the random library with the rand integer function. The random number will take a value between 1 and 5, depending on what the program picks. Then we create a pick variable that will call this function and store its value of the outcome to this pick variable right here. And then we print the pick variable. So simple as that. If we run it, okay, so it must be saved. Let us actually create an actual folder for our program. So Python programs on our desktop. We can paste it right here. And then what we are going to do is I'm going to save this. So save as desktop Python programs. And then we can call it first function .py. Doesn't even matter, call it anything you want as long as it has .py extension. Save it right here, and then we can actually call it, so run module, we call it right here, and the output is the number is 3. So the random library generated a number 3, and therefore our pick actually got the value of the number is 3. Then we printed our pick variable and we got that string. So we can run it once again. You can see it is once again 3. Now it is 1. Now it is 5. So our program works really well. We successfully generated the random numbers and also printed out while returning from the function. So this return variable, or pardon me, this return function right here is also very useful. It can return different variables depending on the outcome of your function code, as we saw right here. Now the function can also be non-type, as we saw before. It can basically return nothing. So the function doesn't have to return anything from it. It can just perform a simple task. The most simple example I can show you of that is basically just creating a variable. Let us call it simply just variable, and using an already inbuilt function which is going to print something. So print, and we print here football. Now variable basically doesn't store anything. If you just type variable right here equals to none, what will pop out is it will say it is true, since our variable really didn't store anything, since the print function doesn't return anything from it. Same as this one right here. Let me just show you. So this my print function also will not return anything, since we're only using the print function and we don't have the return specified anywhere in our code. So variables can also be non-type once you actually use it from a function. So that is also something useful. Now this really doesn't make any sense, but this is just an example of showing you that the function doesn't really have to return anything from its code. So that would be about it for this tutorial. We're going to code different stuff and we're going to introduce ourselves with different things in the next lecture. So hope you enjoyed this simple short tutorial, and I hope I see you in the next lecture. Bye. Hello everybody, and welcome back to this tutorial. And what we saw in the previous video is we took a look at the most basic stuff while using the function. So we saw how we can return something from the function. We saw how we can actually generate a function that will not return anything, so the variable will contain a none type. We also coded a simple program that is actually going to return a value specified by the actual random integer that the random library created or generated. And that is basically all we did. We also did a simple version of our own printing function, just to show you how the functions work. Now, what we're going to do right now is we're going to introduce ourselves with the local and global variables in functions and outside of the functions. So, in our functions, variables are local. So, if you create a function, for example, function 1, let's say we call it, and you use a variable in that function that you actually generated in the function code itself, that variable will not be recognized outside of the function code. So let me just show you. Let me open up my idle right here. Once again, idle for Python 3, and we can use this interpreter right here. We don't need to actually code any program in this tutorial. As I said, in functions, variables are local and can be used outside. Now, variables themselves can either be either global or either local. They can't be both. Now, you can't have a variable that is going to be both global and local. Local is variable inside the function and global is variable outside of the function. So that is the most simple term you can actually remember it by. So let us see an example of using a local variable. So right here, what we are going to do is we are going to create a function. So def function 1. This function will take no arguments as an input, so just open and close brackets. And in this function, we're going to create a variable to be equal to 30. So we created some variable called variable, or let's call it number. Maybe it is confusing if I call it variable. So number equals 13. In our function, we're also going to print that number. So this is going to be our entire function. Basically, once we call it, the number will be equal to 30. And the actual print of the number, and that value will actually get printed out to the screen. So if I call it, let me show you. You call the function just by specifying its name and opening and closing brackets, and also specifying the arguments in between those brackets if they are needed. For this case, we don't need it, so we just call the function with this name, and there we got the output 30. So what we did is we created a variable in our function. We set the value to that variable to be equal to 30, and then we printed that number. Now this is an example of a local variable. It cannot be used outside of the actual function. So if I type right here number, you can see name number is not defined, even though we did define it right here. That is because I'm calling this number. If I just print it once again, if I just show you, if I try to print the number, I will get error name number is not defined, because the number is only recognized within this function right here. If you try to call it outside, it will not be recognized. Therefore, we can conclude that this is an actual local variable. So let me show you right here. If you create a global variable with the same name, so with the same name, and we set it to be equal to 40, you can see right here that we actually have in our function the number to be set to 30, and outside of our function we have the number to be set to 40. If I, after setting the number to be equal to 40, print that number, we will of course get 40 as an output, since this is a global variable and we are printing that variable there, and we get the output of 40. But if I call a function and then try to print once again number, you will see that once again it is going to be equal to 40. It didn't change its value by specifying number equals 30 in the function right when we called it. That is because these two are two entirely separate variables. They are just called the same. Basically, this one is a global number variable and this one is a local number variable. These two don't have anything to do with each other. well, in this example right here, if we specified, for example, our function to take an input using the number, then things would be different. But in this case, these two variables are basically entirely different. As you saw, this part of the code doesn't really influence the rest of the code outside of the function, so that is something that you should know. Now, in order to actually modify a global variable in a function, you need to call that variable with the global prefix. So right here we don't have any global prefix, but let us see how we can perform the same program using the global prefix. So right here we are going to, let me just restart everything. I could have used the OS library to clear, but doesn't even matter. What we're going to do right now is we're going to create the same function. So function 1, it will not take any input, but right here we're going to specify that we are using a global variable number. So, and then we're going to set the number to be equal to 30 once again. We don't need to print it in this case. It's just simply, we can just simply leave it to be equal to 30. In the previous example, we actually printed the number, but right now we don't have to do it. And right now, if I call this function right here, we call it, and I print the number, you can see that right now I can actually access this number outside of the function, and it is equal to 30. That is because we use the global number variable. This means that the variable that we are going to use in this function right here can also be used outside of it. Now also this means that if we change the value right now to 40 as we did in the previous video, so number equals 40, and we print the number once again, this variable and this variable are exactly the same. We are going to use this variable in the actual function 1 by changing its value. So right now, if I call once again the function 1 and try to print the number, it will not be 40 as in the previous video. It will actually change its value right now and it will become 30. So let me show you right here. If I just call function 1 and I try to print the number once again, you can see right now the value is changed and the actual value of the number is 30 and no longer 40. So this is an actual example of global and local variables. Now there is also something called parsing the variable. So let us use it like this. So def function 2. Let's say, for example, number, or pardon me, we need to take an actual argument right here. So number, let's just call it number, and we're here going to use number plus equals 1. Where is my plus? Finally, I found it. So number plus equals 1. This is our entire function. But right now you can see, let me just show you right here, that this is not an actual global variable. We didn't specify the global prefix anywhere. So if we set the number to be equal to actually 30, and we print that number, and then we call the function 2 for that number, and then we print the number once again, you can see that the number is still 30. That is because we actually didn't return anything from this function, we just increased it in the function itself. So let me show you right here. If I just, I'm not really sure if I can add it right here. Okay, and then we actually return the number. Okay. And then what I'm going to do is I'm going to set the number variable to be equal to function 2 outside of the number variable. Now we know that the number was set to be equal to 30, and right now if we print the number, it is going to be equal to 31, because we actually returned this number value to the number variable itself. Therefore it increased it by 1, and therefore right now our number variable is equal to 31. So that is basically everything we have for at the moment for the global and local variables. Now make sure to practice this and really understand it so you don't actually mess up your code once you start coding with multiple functions and multiple variables. But we're going to also take a look at that later on. For now on, this would be more than enough. Hope you enjoyed this tutorial, and I hope I will see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial. And what we're going to do right now is we're going to take a look at some similar, or not similar, some different examples of using functions in Python 3. We're going to code some simple programs. Normally, as you would do before actually knowing how to use functions, and then we're going to implement a function to that program in order to see how we can do that. Now, why we're doing this is because I think this would be the best practice. You actually code a program without a function, and then you think about how you can actually implement the function in that program so it can become a little bit useful. So let us see how we can do that. Let us open up our idle right here. And we're not going to use the interpreter. Let us just open the actual new file. So we are going to code our own program, and we are going to use the random library. So import random. Now, what we're going to try to do in this program is we are basically going to create a secret number that is going to be generated by the random library as we did before. Then we are going to use a for loop in order to actually give a user of this program 3 times to actually guess the number. We will actually perform an if-else statement, whether to check if the actual guess was correct, and then if it was, we will just print congratulations, you guessed the number. Else we will print something like better luck next time, and we will close the program. Then after we code that, we're going to try to implement an actual function for a specific part of this code. So first of all, let us code it. We have import random right here, or let me just lower it. It looks much better like this. So import random. First of all, let us create that secret number. So secret number will be equal to calling the random library using the random integer function from this library, and let us generate a number between 1 and 20. Not 29, 20. Okay. Then we can print something like this. I am currently thinking of a number. So we can print something like this. This will be a simple game of guessing the number. Right now, what we want to do, as I said, we want to enter an actual for loop. We want to give the user 3 times to actually guess. Now, how we can actually give the user 3 times to guess? Well, we can use for example, let's use for I in range 1 through 4. The reason why we are using 1 through 4 is because that will be equal to 3 guesses. So 1 through 4, we want to actually print first. So print try to guess the number, exclamation mark. So we print try to guess the number. Then we want to actually take an input from the user itself, because they are now ready to type the actual number that they think is the correct one. So guess variable is going to be our storage for the actual user value. We're going to use an integer function in order to convert the input value into an integer. So in the integer, we also saw an actual example of using these two functions together. So first of all, we use integer, and then inside we use the input function right here, which is going to actually print out enter number between 1 and 20. So this is what the user will see. Then they will specify the number. The number will be inputted. We're going to perform an integer function on that number, because if we don't, this actual guess variable right here will store a string value of this number. That's why we need to actually convert it to integer first, and then store it into the guess variable. Right after we do that, we can perform our if-else statement within our for loop right here to check whether the number is correct. we're going to check whether the number is actually smaller or bigger than the actual secret number. So if guess is smaller than the secret number, which is the number that is generated by the random library. So if the guess is smaller than the secret number, we can print the number you specified is too low. So we can print something like that. Else if the guess is actually bigger than the secret number, bigger than the actual secret number. Let me just go right here, find it. Bigger than the secret number, we can print same as we did in the upper part. So the number you specify is too high. Let me just type here capital I, so it actually looks better. And at the end, else in any other case, and the any other case is of course going to be that the number is correct, because there is really no fourth case in this, we're going to break out of the loop. So simple as that, we're going to break out of the loop. And once we actually break out of the loop, we're going to perform a check whether this actual guess is equal to secret number. Now, why we are doing this? Well, basically, this is going to end anyway, whether the user guesses the actual number or whether the user doesn't guess the actual number. And you can see right here, we don't really guess, or we don't really perform the checking of the guess equal to secret number in the for loop itself. So we have to do it outside in order to make sure that the user actually guessed the number and didn't just run out of the tries, which in our case, it has 3 tries to actually guess. So if guess is equal to secret number, we're going to print congratulations. So you have guessed the number. Okay, and in the any other case, if it's not equal, since this guess variable right here, once 3 tries are actually completed, will have the last value of the last try. And if the last try was equal to secret number, that means that they successfully guessed it. And if the guess variable is not equal to the value of the secret number, that means they just ran out of they just ran out of those 3 tries that they had, and that then we will print better luck next time. The correct number was, and then we'll just concat it to this string. Now make sure that actually, once again, I can find my plus sign. Okay, so here it is. Make sure to actually use a string function to actually convert the secret number to the actual string value, so you can actually print it. So string from the secret number. So simple as that. And this is our program right here. First of all, we are going to actually test it. Once we test it, we are going to create a function in this program that is going to perform this part of the code. So let us go right here, run our module. Okay, we need to save it. We're going to save it in the desktop right here. Go to the Python programs, guess number.py. Run it right here. We can see I'm currently thinking of a number. Let us have the code right next to it so we can see where we are in the code currently. So I'm currently thinking of a number. We're right here. Try to guess the number right here. And right now we are at this line. We specify 3. You can see right here the number you specified is too low. Try to guess the number. So we finished the first iteration of this program. Let us go with 7. So we know that the actual number you specified, okay, so right now it is too high. Try to guess the number. We know that number is between 3 and 7, so let me just try 5. The number you specified is too low. Better luck next time. The correct number was 6. So we didn't manage to guess the number, though we were really close. Let's just try to run it once again. So 10, too low, 12, too low, 15. Congratulations, you have guessed the number. So the 15 was actually a number. Therefore, we actually managed to guess the number. So our program works. Right now, what we are interested in mostly is using a function to perform a certain task right here. So as I said before, first of all, we are going to code a function up here. And this function, what it can actually do is it can actually have this entire part right here. Let me just check it right here in the actual function. So let us just try to do it like this. Copy. We can paste it right up here. Def guess underscore number will be our function. Now, of course, our function will actually need to take an input, or it will have to take some argument. But before we do that, make sure to tab each line once so it can actually belong to the function. Okay, so we tab each line once. So the code actually belongs to the function. So now let us see what else we need to change. We have a function guess number. We create a random integer. We perform we print I'm currently thinking of a number. And right now we can call the function. So guess underscore number. Okay, for I in range 1 through 4, print this, then guess equals integer input, enter number between 1 and 20. Right here, what we are going to do is we are going to use a global guess variable, so global guess. Now remember why we are doing this is because we can actually access it outside of the function itself. We saw that in the previous video. Therefore, right here, we need to actually use a global variable guess because we are using it right here later on. So for I in range, let me see whether there is something else we need to change, or we can just actually try it. Okay, it is saved. Think a number between 1 and 20, 3, 7, 14. Okay, better luck next time. The correct number was 9. So we successfully implemented a function that will actually check the values of these, or not check, it will actually prompt the user to actually input 3 times the value. So our guess number right here is in a function. Therefore, you can call it as many times as you want throughout your code. So we call it right here. But let us also code a function for this part right here. Now this function will have to take arguments. First of all, I will copy this, then I will delete it. And let us call this function def check. Okay, let us just call it check. It will take an input from the actual guess variable. So let me just make sure that it is guess. So we called it guess right here, global guess variable, and the secret number. And right here we can paste the actual code of the function itself. Once again, make sure to tab each line so it actually belongs to the function itself. Okay, now let us separate also this part right here. Oops. Okay, and we actually can call the check function right after the actual guess number function, and we need to parse the guess and the secret number. Okay, let us see how this will work. We save it. 5. Okay, we got an error. Let me just see what the error is. First of all, did we save it? We should have saved it. Okay, so run this. 3. Okay, invalid literal for integer with base 10. Let us think about this. So def check guess secret number. If guess equals secret number, okay, for I in range, yeah, let us try to actually return the guess right here. Maybe that is the problem, maybe not. So return guess, and we are going to return it right here. So going to equals to guess number. And then we are performing the check function with the guess and the actual secret number. So let me just save this. Run this right here. 4. Try to guess the number. The number is too high. 2, 3. Okay, so our program works. The correct number was 1. We actually managed to not guess the number, but doesn't even matter. Our program works. That is what matters. What we had to actually do is, because we didn't really have this guess variable outside, so we actually had to store it back and return it from this guess number function right here. We returned it after the actual for loop. Now make sure to tab this at the same line as the for loop. Now this is not tabbed into the for loop, so don't do this. Just tab it one time out. It has to belong to the guess number function. Therefore, the last try of our user will be returned from this function right here. It will either be a correct try or it will either be a wrong try. Then it will store itself in the guess variable right here. And then we perform the check function with this guess variable, which is going to be the last guess of the user, and the secret number, which is an actual number generated by the random library. So let us run it once again, just to make sure it actually works. 10, too low, 15, too high, 13. Okay, so better luck next time. The correct number was 14. Okay, so our program works. We successfully coded it, and we're going to code a different program in the next tutorial, also using functions. So hope you enjoyed this lecture, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now we're going to take a look at some of the different functions that we can do in Python 3. In the previous video we saw an example of a program that actually performs the guessing of the number. Now that was a successful example, since we actually managed to implement 2 different functions into that program, and then you can call it whenever you need them. But right now we're going to take a look at some of the more simple functions that actually make sense in Python 3 and that you will rather understand very easy. So let us open up our idle right here. We are not going to actually use the programs themselves. We can code everything right here for now on. So let us first of all create an actual function that will reverse a string. Now, there is an actual easy way to reverse a string in Python. Basically, if you just use something like this, so input underscore string will be equal to actually this is a test. So this is our string. Where is my single quote? Okay, there it is. Then we can actually create a function def reverse underscore string, which will take an input of the actual string itself. And what we will do with that string is we will basically print, we want to print the reverse string. So what we are going to do is we're going to print this string and then open and close square brackets. We just change the keyboard to English, maybe it will be easier. So open and close square brackets, and right here type 2 dots, 2 dots, and then -1. So this is just basically a string manipulation. What this part right here, 2 dots and 2 dots and then -1 do is basically it will reverse a string. So let me just press enter right here. And right now, if we call a reverse underscore string function on our input string, you can see we actually get a reversed string from this actual string right here. Now we can do that for every string we want, so we can actually create our input string. Sorry about that. Actually, my keyboard bugged out. So input string equals to actually input, and we can just type here enter any string you want. we can enter hello world right here, and then we can actually call the reverse string onto that string. Simple as that. And you can see it will reverse the sentence or the string, or however you want to call it. So this is a simple function that will actually take an input of a string, and then it will perform the reverse value of that string. It will print it to the screen. Now you can also, if you don't want to print it, you can just return it from this function to a different variable and then print it onto the screen then. So right now, let us actually perform the function that will actually check whether the number is even or odd. Now we can actually simply check that the number will be even if its module, or if 1 divided by 2, it doesn't give any remain. That means the number is even. If it does give a remain, that means the number is odd. So we're going to create a function that will do that. We can create it right here. So def even and or odd, or we can just call it even underscore odd. It will take an input of a number. So let us just use an input num. We will call it like that. Now remember, right now throughout this entire function, we need to use num as an actual value. Don't rename it. So if we can do something like this, if num and then module 2 is equal to actually 0, then it means that the number is even. So we can print the number is even. We can then use else, print the number is odd. Simple as that. So the number is odd. This is our entire function, so let us go over it once again. We will parse an argument of the number to this function, then we will perform an if-else statement that will check whether this number is even or odd. Then we can actually have a number as a variable to be equal to integer out of input, and then here we will specify to user enter any number you want. Right here, enter any number you want, we specify 20, and then we can actually perform even or odd from our number, and then we can see the number is even. So right now, let us also try to do the same with an odd number, just to see whether it works. So copy this statement right here, paste it right here. We can use 13, and then even underscore odd from number. And right now, the number is odd. So we successfully created a function that will check whether the number is even or odd. We also successfully created a function that will reverse a string right here, even though this simple part right here will reverse a string, but doesn't matter. This is just us showing some different examples of using functions. And we're also going to continue coding different programs, simple programs, in the next lectures. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to this tutorial. And in this example, let us see a simple math example. So if you're good in geometry, you will know how to calculate the area of a circle. So what we're going to do is we're going to create a simple program that will calculate that. And then once we actually create it and see that it works, we're going to implement a function for a specific part of that program. Now, don't worry, this is not a large program. This will be a rather simple example. So we can do something like that. So let me just open up my idle. We're going to actually create it in the normal shell itself. So let me just find, okay, so new file. Right here, we are going to code our simple program. So one thing that I didn't show you before is that in order to create an actual comment, you need to use hashtag. Now what comments are is basically if you have a print statement and you are printing something right here, so print hello, And if you add a hash after it, you can type anything you want afterwards, and that part of the code will not be executed. Or basically anything, it doesn't have to be code. So you can just type here, this function prints hello. And you can run this, and this will not be executed by the program itself. So let me just save this, desktop, Python programs, circle area.py, because that is going to be our actual final project. And you can see it prints hello. It doesn't actually give us an error because we have a normal sentence right here. That is because it is actually behind an actual hash. You can type here anything you want, it will still work. Basically, this is used as a comment, just so you can write something that you don't understand. You can just write next to it what it does. So later on, once you actually visit the program code once again, you don't really have to take your time to remember what certain parts of program do. You can just read a comment next to it and specifically know right away what that certain part of code does. So I just wanted to get that out of the way. We can actually use it in this program. So let us type hash at the beginning and let us call it Python program calculate area of circle. So this is going to be our reminder what our program is doing. Basically right here, let us think about it. So we know that we actually need to take an input of the radius of the circle itself. So we will prompt the user to actually specify the radius of the circle itself. Then we will check whether the radius is actually equal to something. So we can actually do this in a while true loop. So if the radius will be equal to x, then we will close the program. So let me just show you right here. First of all, we are going to enter a while true loop. Why? Because we are actually going to prompt the user forever for actually entering radius and then specify, and then we'll print out the actual area of the circle. But if, for example, the user specifies x or any other number or basically anything as a value, we will then break out of the loop. So let me just check out right here. So radius equals input, and right here, let us just use something like this. So enter radius of circle. Okay. Right here, we know that the radius of the circle is p times radius square. So, or pardon me, the area of the circle is radius square times p, and then after we actually input or prompt the user for the radius, we store it in the radius variable, okay, and then we will check if radius is equal to x. Now the reason why we are checking whether it is equal to x, because this will be a command that the user will specify once they actually want to close this while true loop and break out of it. So let us just print right at the beginning to the user, specify x to close the program. Okay, so now the user knows what they need to specify if they want to actually exit out of the program. We can simply just break out of the loop right here, because we're in a while true loop. If we break out of the loop, we're actually going to close the program because we are not really going to have any other code outside of the while true loop, except for this print statement at the beginning. Okay, so first of all, we know that the red will actually store a string, whatever the actual user inputs. So if they input an x, it will be a string, as we saw right here. If they input an actual radius, for example, a number 2.7, it will still be a string. So in the actual else statement, first thing we need to do is we need to convert the value to the float or integer value. Now, since the user can actually specify a decimal and not just an entire number, we need to convert it to the float and not to the integer. So we'll create a variable, radius will be equal to float value from the red variable that we prompted to the user. And right here, once we do that, right now we can actually calculate the circle or the area of the circle. So area variable will be equal to 3 times 14 times radius times radius. Simple as that. So this is the actual formula for the area circle, and then we can print the actual area. So we can print at the end right here. Let me just show you. So the area of the circle is, and then when we can concat a string from the actual area and print it to the screen. Okay, so simple as that. We created a simple program. It still doesn't have any function. Let us right now just try to test it. So we run it. Enter radius of the circle, 3. The area of the circle is this one. Okay. Enter radius of the circle, 3.5, or let's go 3.54. We can see now the area of the circle is this. And if we want to close the program, we specify X and it will exit the program successfully. So our program works. Right now, let us see where we can actually implement an actual function. Now, by looking at this, we can actually store all of this in an actual function. So let us just copy this, then delete this, and at the beginning of the program, we will paste this right here, and we will store it in a function called calculate radius. It will take an input of the actual radius itself. Let me just think whether this is correctly specified. So calculate radius, then we check whether the radius is X. We will break out if it is, then we will convert it to the float value. If it is not, calculate the area and print the area. All we are left to do is simply just call the function right here. So calculate underscore radius with the rad or RAD variable right here. So right now, if we save this and run it once again, break outside of the loop. Okay, yeah, we can't really break outside of the loop, but we can actually exit. So we use the exit function to close the actual program. So right now, let me just go and save it and run it once again. Enter radius of the circle, 3, 2, 1, X. The program is still running. Do you want to kill it? Okay. Yeah, this is not an actual good way to kill, so we will actually need to fix something right here. We can do something like this. So first of all, we will not have this in the program itself. Let me just go right here, tab everything one time back. This will be our function, but before we go into that function, we will check if rad equals to actual X, then we will break out of the loop. If it doesn't, then it will skip this part right here and it will go straight to the calculate radius. Okay, so let us save this and run the program right here. Enter radius circle, 3, 4, 5, X, and then it closes the actual program. So it works correctly. Now what we did right here, in case you are actually confused, basically our calculate radius function will only calculate it once we actually specify the integer value or the float value. Before we actually go to that function, we need to check out whether the user specified X string as the actual value of the rad, meaning that they actually want to close the program. If they did, then we will break out of the loop, closing the program. If they didn't, then we will go into the calculate radius function, which will actually calculate the radius itself. And right now you can actually call this function wherever you want in your program. You don't have to calculate this every time. You can just call this function onto the specific value of a specified, or basically of a specified radius. So that would be about it for this tutorial. We're going to continue with our example in the next tutorial. So hope you enjoyed this lecture and I hope I see you in the next one. Bye. Hello everybody and welcome back to this tutorial, and right now we're going to take a look at simply coding a simple Python calculator. So we're going to, as always, first of all code it in a normal programming and by normal programming I mean without using the actual functions. And then as a practice we're going to implement functions where we actually can and where we actually think that we will need it. So let us start off by actually opening up our idle as usual. And we're going to code program, so new file. We can move it right here. First of all, save it so we can actually run it as soon as we finish coding it. So simple Python calculator. A little bit of a long name, but it doesn't even matter. We will save it right there. And let us use a hash as in the previous video. Call it Python program. And simply simple Python calculator. So we actually know what this is once we visit it in a month or two. Right here, let us see what we need to implement. So there are 4 things that we need to implement: addition, subtraction, multiplication, and division. We're actually going to prompt the user for entering 2 numbers, and then we're also going to prompt the user for deciding whether they want to add those 2 values, to subtract those 2 values, to multiply, or to divide those 2 values. We will also have an actual option if the user wants to exit the program, so then so they actually have that option as well. So right here, first of all, we're going to code it just like this: print. First option will be addition. The second option, we can actually code it to be subtraction. So let me just code it right here to dot and then subtraction. Okay. The third option, right now what we're doing is we're basically just specifying the options that the user will have with this program. So multiplication. This is really simple calculator, so not really anything useful, but this is a calculator that we're going to code. Of course, later on we're going to code more advanced calculator if we want. For now, this will be more than enough, as we are still in the beginner section. We basically just covered the basics, and right now we're covering functions, which can actually be basics, but let's say it is a little bit more intermediate because it is mostly used in a larger codes. After we finish with functions, regex, classes, object-oriented programming, and different stuff, we're actually going to go into networking, into creating files, using Excel, PDF, all those different kinds of stuff, and actually interacting with the web applications, and more advanced stuff later on. From now on, we are actually learning the basics, so let us go with the 4th option. Not really sure why I even told you this, but just to make sure that you know that this is not actually everything we're going to code. There will be more advanced stuff later on. So the 4th option is division, and the 5th option will be an exit option, because we want to specify to the user that they can exit the program whenever they want, because at the end we're going to put everything in a while true loop as we did in the previous video. So first thing, after we print all of this, we can actually enter the while true loop right away. Okay, let me just check out. Yeah, while true loop. And then first thing we prompt to the user is to enter the choice whether they want to subtract or divide. So choice will be equal to integer. So integer right here. We want to make an input function, and in the input function we're going to prompt the user to enter choice. 2 dots. Right now, once they enter the actual choice, we need to make sure to check if the choice is between 1 and 4. Then we're going to proceed with actually calculating the stuff. If it is a 5th choice, that means that they actually want to exit the program. Therefore, there really isn't no point with going through all of those addition, subtraction code. We can just specify the exit function. So else, or first of all, if the choice is smaller or equal, let me just find where the actual equal sign is. Yeah, really interesting. Can't seem to find it. Let me just go back to different type of actual keyboard. Okay, so if it now the reason why I'm switching with these keyboards and all of this stuff and mistaking different characters is because I'm actually used to Linux on my laptop, and it is a little bit different keyboard there. That's why I'm missing so many times. So pardon me for that. So first of all, if choice is bigger or equal to actual 1 and choice is smaller or equal to 4, we want to proceed with the calculations. Let's first of all put this in brackets. Basically this AND right here will actually just check for both of these values. If they are both fulfilled, then we're going to proceed with the actual calculation. So if choice is bigger or equal to 1 and choice is smaller or equal to 4, we're going to calculate different stuff. But before we actually calculate, we're going to prompt to the user, first of all, print. Oops. Enter 2 numbers. And then we are going to prompt the user to input 2 different values. So we can call it number 1 will be equal to actually integer of the input. Make sure that we always use the integer once we actually want to prompt the user for a number, because the input function returns string, as we already know. So integer input, enter first number, and the number 2 variable, so num2 equals integer input, and then enter second number. Simple as that. So enter second number. Okay, once the actual user enters both of these numbers, then we can proceed to checking out what the choice was between 1 and 4. So if choice is equal to 1, we're going to simply just add these 2 numbers, because the number 1 is addition. But let us call a function called addition. This function will take an input of number 1 and number 2. And that is simply the function that we're going to call after we finish this main part of program. So else if choice equals to 2, that means that the actual choice was subtraction, and then we're going to call subtract function. Well, once again onto the numbers num1 and num2. Okay, subtract and addition. Now, of course, these are not an actual existing functions. We are going to have to code them up here. But for now, let us just name them like that. Else if choice equals to actual 3, that means that the multiplication. So we're going to specify multiplication from the numbers 1 and numbers 2. And the last choice will be the actual, or we can just use else. Doesn't have to be else if, because this is the only possible solution. Pardon me, the only possible choice left. We want to perform division, which we can just call divide from number 1 and number 2. Okay, so simple as that. This is our main if part. Now else if, so we are going to tab 2 steps back. Else if the choice was equal to actually 5, that means that they want to actually exit the program. Therefore, we're going to just break out of this loop, closing the program. And the last part, else, since we want to cover every possible example, we want to print you entered wrong choice. Because if they actually don't enter anything between 1 and 5, that means that they entered a number that is not specified right here. Therefore, we are going to print to them that they entered a wrong number and that they should enter once again. So then they will go to the beginning right here and they will have to enter the choice once again. So what we are left to do right now is we are going to actually code these 4 functions. Now they are basically 1 or 2 line functions, so don't worry, nothing really too large. So let us start off with the actual addition function. So addition, it will take number 1 and number 2 as arguments. And then basically what it will return is it will return a result, which will be the number 1 plus number 2. But in this case, we don't really want to return it. We want to print it. So what we're going to do is we're going to create a result variable, even though we can do it a little bit shorter, but doesn't even matter. Result variable will be equal to number 1 plus number 2. And then we're simply going to just print the result. Okay, so basically this is the entire actual addition function. Let me just print it a little bit better, so we can just print something like this. The result is, and then we can concat the string of the actual result. Okay. Now, since we finished with the addition, we can go to the subtraction, or subtract, however we call it. However we called it, or you called it, if you didn't call it the same as I did. It is also going to take number 1 and number 2. And it will perform same thing as in the upper part of the function. Just right now, we're going to subtract these two numbers. So number 1 minus number 2. And then we're going to print the result is, and we're going to concat the string value of the actual result. Okay. Let's just copy this right here, so then if we actually code it 2 more times, we can just paste it and change what we need. The third function will be the actual multiplication, so define multiplication. Once again, number 1 and number 2. And right here we can paste these two. Oops, not here. Just delete this. I didn't want to paste it there. I wanted to paste it right here. Okay, good. And then we actually want to multiply these two values. So the multiply, we use the actual star sign right here. And then we can print this same thing. And the last function that we need is going to be the actual division or divide function. As we called it, make sure to call it the same as you specified right here. Otherwise, you will get an error. So it will take the input of the number 1 and number 2. And simply we can just, let me just see why is it once again printing it right here. Okay. For some reason it is printing it in this section right here, but doesn't even matter. In order to divide these two numbers, we use a slash. And then the result is the string of the results right here. So let me just save this program right here, and then we can actually test it right away. So run the program, run module. We have our 5 available options. Let's try to exit it right away. The exit option works. So let us run it once again. Let's start with the addition. So enter two numbers, enter first number 3 and 4. The result is 7. Then we are prompted once again to enter the choice since we are in a while true loop. Let's go with the subtraction. Let's go with the 10 as the first number and actually 2. The result is 8, so that one works as well. The multiplication, let us go with 100 and 100. The result is 10,000, which is correct. And the last one will be the division, which we can just simply try out for the 27 and 5. So we can actually see whether we get a decimal value, and we indeed do, 5.4. And that means all our available options work. If we specify 5 once again, we manage to actually close the program itself. Let us also check one more value, which I forgot to check. What happens once we specify, for example, 7 as a choice? You entered wrong choice. Okay, so that one works as well. So our program works really well. It is nothing really too far-fetched, but it does the work. So we will just keep it right here and we will continue with a different example in the next lecture. So hope you enjoyed this tutorial and I hope I see you in the next one. Bye! Hello everybody and welcome back to this tutorial, and right now what we're going to do is we're going to create a simple Python program that is going to remove vowels from string. So we know that the vowels are A, E, I, O and U, and we are going to try to remove them from any specified string that the user inputs. So let us see how we can actually do that. Open up your idle as usual. So right here we open up our idle. We're actually going to start opening the new file as we're going to write a new program, and let us save it right away. Go to desktop, Python programs, let's call it vowels.py. Now pardon me if I'm actually pronouncing them wrong, because I'm not really sure how to pronounce that, but I believe it is something similar to that. Let us start off by actually specifying what our program does. So Python program remove vowels from string, or let's say from specified string, so we can actually be really precise about our program. So specified string, simple as that. Now what we're going to do is we're going to take the same approach as in the previous tutorials. For example, the user will have a bunch of inputs. If they specify X, then we will close the actual program. If they don't specify X, that means that they actually inputted a string and that they want to actually us to remove the string from the actual, to remove the vowels from the string. So first of all, we're going to print as usual to the user to enter X for exit. So just so they know. And then we're going to take a string input. So right here, input a string. Right now we don't need to use a string function in order to convert it because it will already be a string. And right here we will just specify enter any string, to remove all vowels from it. Okay, this will be stored in the string variable. Right here, we need to perform a check on it. So if string is going to be equal to X, we want to simply exit the program. Simple as that. In any other case, if it is not X, we want to actually create a new string that is going to be a simple copy of this string, and then we're going to remove the actual new string from all the vowels. Now, in order to be able to actually remove the vowels, we're going to create something called tuple, which we really didn't cover yet, but don't worry, just follow what I do. So new string str will be equal to the string. Then we're going to print to the user that we are actually removing the vowels from the string. So removing vowels from the given string. Just like that. So, and then we need to specify what the vowels are, so our actual code can know what the vowels are. Now we are going to use something that we didn't really cover yet, but just specify it right here. Don't worry, we are going to cover it later on. So specify all of the vowels separated by single quotes, in the single quotes separated by comma. Okay, O and U. So this should be it, all 5. And then what we need to do is perform a check for the vowels in the actual string. So we need to perform for I, for each letter in our string.lower. Now the reason why we are using lower is because in our tuple right here, what we have specified is the lower characters. Basically, that's why we need to check out for the vowels in the lowercase string in order to turn a string into a lowercase string. So let me just show you. String equals, if you just type here hello, capital, remove this space, and use new string, so new underscore string will be equal to string.lower. you can see if we print the new string right now, it will be the same string just in lowercase. That's what we are doing right here. So we are checking for each character in string.lower. So we can, let me just call it C and not I. So C as for character. Then for each character, we are going to perform if that character is in vowels, which we specified right here in this line, then the new string, we call it new string, will be equal to new string dot replace the actual character, or the vowel in our case. So we replace the character with an empty space, which we specify just like this. So let us go over this one more time, because this might be new to you. What we did right here is, first of all, we created a simple vowel list, or tuple, however you want to call it, right here, containing all 5 letters. Then we perform in for loop for each character in our string right here. We perform the check for that character if that character is in vowels. If it is, we're going to replace that character with an empty space using the replace function. Okay, simple as that. And then once we actually perform check for every character, we're going to print the new string after successfully removing all the vowels is going to be equal plus the new string. So simple as that. Let me just double check everything. Okay, and if I just save this program first of all and try to run it, we get the actual enter any string to remove all vowels from it. Okay, so let's remove from the hello. And we can see removing vowels from the given string. The new string after successfully removing all the vowels is HLL, which is correct. So it removed E and it removed O. Let us go once again, running this program. And let us try with the actual hello world. So right here we also have the spaces, and it managed to remove all the vowels from the entire sentence. So you can just paste the entire paragraph right here, and it will basically prompt you back with the entire paragraph just without any vowels. Okay, the reason why we specified X to exit is because right now what we want to do, let me just enlarge this right here. Let me just check this out. What we want to do is we want to create a function. Let me just see what we are going to do in that function. For C in string lower, okay. We can actually paste this code right here into a function. Okay. Let us delete this. Then right here, let's call a function called remove underscore vowels. The function will take an input of an actual string. And then in this function, we're going to paste the code. Okay. Let me just see whether there is something that we need to change. String.lower. We actually have to return. So at the end, we want to return the new string from this function. And we are going to return it into the new string variable right here. And we're going to, so new string variable will be equal to remove underscore vowels from the specified string. What we don't need is this line anymore, so we don't really need this. Let us just double check everything. First of all, this has to be one line in. We just check everything. I will just tab everything properly, because it seems to be tabbed incorrectly. Okay, so it is good right now. What we did right here, first of all, we print this, then we prompt the user. If the string is equal to X, we exit, else print removing vowels from the given string. Then the new string variable will take an actual return value from the function remove vowels. So we go to the function, we paste the string value to the function, then we create the vowels right here. For character, okay, so everything is the same, and at the end, we return the new string. So let us see whether this will work. First of all, save this, run it. Let's create football. Okay, local variable, new string, reference before assignment. Okay, yeah, right here, we actually created a new string to be equal. We need to use string instead of the new string. String.replace C, the character with the empty space. Let me just save this and see if that will fix the problem. I believe it should. So football. The new string after successfully removing all the vowels is football. But for some reason, it didn't actually remove the double O. Let me try with different string. Maybe that is something. Let's use hello once again, as we did before. We get hell, so it doesn't actually remove the first vowel for some reason. Let us see why is that. Okay, so we parse the string to the actual function. So for character in the string.lower, if C is in these vowels, new string will be equal to string.replace C. Or let me do it like this. New string will be equal. Yeah, I think I know what the problem is. New string will be equal to new string.replace. Okay, and right here, we need to use the line new string as before that we deleted. Now maybe we don't really need it, but let me just check it out. And then right here, we're also going to parse the new string as well as the string right here. Okay, save this. Let us see whether this will fix the problem. And if I just type here, hello. Yeah, okay, so this did fix the problem. As we can see right now, it does remove everything. Okay, so the problem was because we didn't really have this new string variable right here. And in the previous error, we can see right here, local variable new string reference before assignment. So we used it right here, but we didn't really define it anywhere. That's why we got the error. Therefore, we actually use this line right here, and then we will parse both of these values to the remove vowels function. Therefore, we are not going to get this error anymore, and our program will work correctly. So that would be about it for this tutorial. We managed to create a function that will remove vowels. Hope you enjoyed this lecture, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And this will be our last coding example in this section. Now what we are going to do right here is we are going to perform or actually code a program that will find the largest out of 3 numbers. So we will prompt the user to specify 3 numbers. Then what we are going to do is we're basically going to check out which one of those 3 numbers is the largest. Now this is a rather easy program to code, so we will going to do it right now. And right after we finish that, we're going to go into the next section where we're going to start a new chapter where we actually introduce ourselves to the lists, tuples, dictionaries, and so on and so on. So first of all, let us start off with this program. So open up your idle and open up your new file, which we are going to call the largest out of 3. So let us go right here, go to the desktop, Python programs. Let's call it largest out of 3.py. Basically, these names, you can call them anything you want. You don't really have to call them as I do, or you can, however you want. And right now, let us start off by specifying what our program will do. So Python program, find the largest out of 3 numbers. Okay, so now that we specified what our program will do, let us see how we are going to do this. So first of all, we will prompt the user for the first number. Once they specify the first number, we will check whether that number is an actual X, which will specify that they want to actually exit the program, as in our previous tutorials. If it is not X, then we will proceed to actually prompting the user to specify the second and the third number. After they specify the second and the third number, we're simply just going to perform some if-else statements that are going to check which one of those numbers is the largest. Once we actually figure out what the largest number is, we're going to print to the screen the largest given number of the three is this one. Now we will also take note of a case where they actually specify the equal numbers. So we actually want to print in that case that all three numbers are equal. So let us see how we can actually implement all of that. So first of all, we're going to use the print statement to let the user know that they can exit the program with the X. So enter X to exit the program. And then we're going to print the user to enter the three numbers. Enter three numbers. And then we input the first number. So number 1 will be equal to the input. Of course, let us make sure that we actually use the integer value so we don't actually get an error. So input. And there we will specify enter the first number. What we're going to do before actually specifying the, let me just perform 2 dots right here. So what we're going to do before actually prompting the user for the next 2 numbers is we are going to, as I said, check whether this first number is an X. If number 1 equals to X, we're going to simply just exit the program. In any other case, that means that they actually specified the number, but let me just check right here. Because we are using the number 1 to be equal to X, we cannot really perform the integer right here. It has to be a string. Or basically, let me just double check everything. Yeah, let us do it like this. So first of all, we will not convert it to integer yet. We will simply just leave it to be a string, whether it is an X or a number. Then we will perform a check, and if it is not an X, right now, we can actually convert it to integers. So first of all, we're going to type number 1 equals integer from number 1, and the number 2 will be equal to integer from the input, because the number 2 is something that they didn't specify yet, so they have to actually specify it first. Okay, enter the second number. And the number 3 will be the same, so integer, input, and then enter the third number and the last one. So enter the third number. Okay, so now that we actually got all 3 numbers that we need, we're going to take an approach where we actually select randomly one of those numbers to be equal to the largest. Now, what I mean to be equal to the largest, we will just simply create a largest variable right here. And we will say that the number 1 is an actual largest variable. Now, it doesn't have to be, but we will just assume that it is. Then we will perform the check. So if largest is smaller than number 1, or pardon me, than number 2, what we're going to do is simply we're going to set the largest variable to be equal to number 2. Because if we actually set the number 1 to be equal to largest, and then we notice that the largest is now smaller than the number 2, that means that the number 1 is also smaller than the number 2. Therefore, we can set the largest to be equal now to the number 2. Okay? But before actually set it to be equal to number 2, we also need to perform a check. So we're going to do a nested if statement. So basically an if statement inside the if statement. So if number 2 is bigger than number 3, then we are going to perform this, as I said. So tab it right here. Take a few seconds to actually figure out what this does. But until then, let me just code an if else statement. So basically, what we did right here, as I said, if number 1 is smaller than number 2, And if number 2 is bigger than number 3, then the largest will be equal to number 2, because the number 2 is bigger than number 3, and also it is bigger than the largest, which is equal to number 1. If this statement is fulfilled, but this statement isn't fulfilled, that means that the number 3 is actually bigger than the number 2, then we are going to set the largest to be equal to number 3. Simple as that. Okay. Then right here, we can just code else if largest, which is still number 1, is smaller than the actual number 3. Okay. Oops, not number 3, but num3. And then we're going to perform a check. So else if number 1 is smaller than number 3, then we're going to perform if num3 is bigger than number 2. This is once again an if statement inside an else if statement. If this is fulfilled, that means that the largest number is going to be number 3. So we are going to just set the largest to be equal to number 3, or num3, however you want to call it. In other case, so else, that means that the actual number 2 is larger, therefore the largest is going to be equal to num2. In any other case, outside of these cases, this means that none of this is actually fulfilled, therefore the actual largest number is assumed correctly in this statement, so we can just set the largest number is going to be equal to number 1, even though it already is, but it doesn't really matter. Let's just reset it right here. And that means that the largest number is number 1. Okay, so now that we actually got everything out of the way, we figure out that the largest number is number 1, or number 2 or number 3, doesn't even matter. Now we need to check whether the actual number 1 and number 2 and number 3 are equal. So in order to do that, we can just type here if num1 equals to num2, and also if num1 equals to num3, we want to print all the numbers are equal. But we can also do it in a different method, so we can use a counter, or basically any variable, which we will set at the beginning of the program. So let's go right here. We can set the count to be equal to 1. And if these two statements right here are fulfilled, that means that then we will set the count to be equal to 0. And then right here, we're going to perform a check if count equals to 0. Okay, so I will explain it once again. Just let me code this right here. If it is equal to 0, we will print all three numbers are equal to each other. Okay, so let us go through this once again. Basically what we did, we set a global variable count to be equal to 1 right here. Then we parse all of this program right here. Then we come to this part right here. So if number 1 is equal to number 2 and number 1 is equal to number 3, now you didn't have to do it through a nested sentence, through a nested if statement right here. We can also do it like this. Let me just go right here. And num1 equals to num3. You can do it as like this if you want to. Okay, then we will set the count to be equal to 0. And then afterwards we will check if count equals to 0, we'll print all three numbers are equal to each other. Else, if count is not equal to 0, that means that this is not correct, therefore the numbers are not equal to each other. Therefore we are going through this code, which means basically we are going to print largest of the given numbers is, and then we will concat the actual largest number, which is going to be stored in the largest variable, as we can see by the code right here. Okay, so if I'm not mistaken, everything right here should be good. Let us save the actual file and let us run it right here. As we can see, enter X to exit the program, enter three numbers. Let's go 3, 5, and 7. Okay, so let us see what the problem is. Okay, so right here, yeah, we forgot to actually concat a string from the largest because you can't really print an integer, concat it to a string. So let us save once again, print it, run it, pardon me. Let's use the same numbers, 3, 5, 7, and it will say the largest of the given numbers is 7. Let's try to specify all same numbers, so 3, 3, 3, and it says all three numbers are equal to each other. If we specify x at the number 1, your program is still running. Do you want to kill it? Okay, we exit the program. So simple as that. Let me just go right here, run the module, check one more time, 10, 15, 3. The largest number is 15. Okay, so it works really well. Right now, what we actually want to do is let us simply code a function that will perform some part of this code. So we can actually go copy this part right here, I believe. Yeah, we can actually try with this part right here. Or we can simply just go right here. Let me just check everything. What are we going to add to the function? Yeah, let's add this part right here. We will copy it, then we will delete this. Let's just delete it faster like this. And then right here, we will call a function that will be called, for example, check_for largest. It will take an input of num1, num2, and num3. Okay, and we will code that function right here. So def check_for largest, which takes an input of num1, num2, num3. Right here, let us paste the actual code of the function itself. Whoops, count. Let's tab everything one time, so it belongs to the actual function. Okay, everything belongs to the actual function right now. Now let me just check everything. First of all, let me make a space right here. There is something that we actually probably need to return from this function. What is this? Count equals 1. Yeah, count equals 1 shouldn't really be in this function. Let us remove it. Let us paste it right here. Or count equals 1, we can just type it. So count equals 1. Not really sure how that ended up in our actual function, but doesn't even matter. What we need to return from here is we need to return largest at the end of the function. Okay. Now we need to store it in a variable down here, so we are going to do it like this. Either we can create a global variable largest, or we can actually, let us try a different way. So let us try with the global variable largest. Global largest. Let us save it. Let's not return it. If we specify the global variable, we don't really need to return it. We have it already, so we can print it right here. And let us run the program once again. Run module. 3, 5, 7. The largest number is 7. Okay, so it does work. Let us try one more time. 10, 15, 20. The largest number is 20. Let us try with actually specifying three same numbers. So 4, 4, 4. They are all equal to each other, so our program works. We successfully implemented a function that will check for the largest number given three inputted numbers, and therefore our program is finished and we can continue to the next section. So hope you enjoyed this tutorial, and we will continue in the next section where we'll start off by learning what lists are in Python. Hope I see you there, and take care. Bye. Hello everybody, and welcome to this section of Python 3 programming. So what we did in the previous section is we were introduced to lists. We also saw some of our coding examples using lists, were functions. We also saw some of the coding examples using functions. So we coded a bunch of programs, not really anything special, but some simple programs. And then we implemented the functions to those programs. Right now, what we're going to do is we're going to introduce ourselves with the lists in Python. So first of all, let us say what lists are. So list, first of all, is a value that can store multiple values in a specific array. Now the syntax for a list in Python is square brackets. So we most likely, you know by now that once we actually use, for example, functions, we specify the values, the arguments, the parameters into the normal brackets. So the normal brackets you see everywhere. And in the lists, once you actually want to specify multiple elements in a list, you will use a square bracket in order to do that. Now, lists are most likely always used in order to store different types of elements that belong to the same group, such as, for example, animals, numbers, strings, any type of elements. It could be also integers, whatever you want. But it can also be used to store different types of elements, so you don't really need to store the strings in a certain list. You can also store strings and numbers in a one list. And we're going to take a look at that right now. So open up your idle. We're not going to code any program this time. We're just going to go over the syntax of lists and how on basically basics of the lists. And first of all, the most simple list you can create is, let me just switch it right here so I don't type the square brackets with the different keyboards. So right here, you specify the open and closed brackets, and if you just press here enter, it will spit out the empty list. If you specify just open and closed bracket, square bracket, that means that you're specifying an empty list. In order to put something in that list, you can simply just put some numbers, for example, 1, 3, 1, 2, 3, 4, 5. You simply right here created a list that has 5 integer values in it. This list has 5 elements, and those 5 elements are 5 numbers. As you can see, they are separated by comma, and they are all in between the square brackets. Now, if you want to actually create, for example, a list that is going to store animals, for example, you can do that by simply specifying the names of those animals in the list. But be careful, right now those are strings, so each of those elements have to be in between the single quotes. So for example, bat, comma, dog, comma, elephant, comma, and then snake, for example. And right here you have a list that actually has 4 animals in it. Okay, they are all in between the single quotes and separated by comma. And also, you don't really need to store the same type of elements in a list. As I said, you can actually store different types of elements. So let me show you. If you open square brackets right here, and you type here cat, for example, and then use 3, and then use, for example, 5.4 as a decimal value, and then you can use a Boolean value, which is true, and then you can also use a non-type value and simply just specifying none. This will work as well, even though I'm not really sure why would you need something like this. But if you do need, you can actually have it. As we can see, we have multiple variable types right here. Boolean values, float values, non-type, strings, integers, basically anything you want. Now, you can also store a list or the list elements into a certain variable, which will be actually a list once you actually give the value from this right here to the variable itself. But you can call it like this. So list, or let's call it like this. So numbers underscore list will be equal to open square brackets and close square brackets, and then 1, 2, 3, 4, 5. So we created a numbers list that actually has these 5 elements. If you just print it, it will print out the list itself. So number underscore list. Oops, it's not number list, it's numbers list. So print numbers underscore list. And you can see it will print out the list that we specified before. Now, you can also select a specific element in that list and store it in a variable if you want to. So we know that the numbers list contains numbers from 1 through 5. And let's say we want to create a variable element which is going to be equal to the third element in this list. And the third element is number 3. Now be careful, the indexes of these elements right here don't start from 1, so this is not element 1. Pardon me, the third element will be element 4. And the reason behind that is because the actual counting of elements starts from 0. So this will be element 0, element 1, element 2, element 3, and element 4. It doesn't start counting from 1. So in order to actually give the value of the third element, this will be the value 4. So let me just show you right here. Element equals numbers underscore list. And then in the square brackets, all you specify is the 3. And you can see right here, if I just print element, you can see that the element variable is actually an integer and it is a 4. If I just type right here, type element, in order to check the actual type of the variable itself, it is an integer. And if you just type numbers list, you should see that it is a list. As we can see right here, class list, and this is a class integer. But what you might find confusing is why did we get the numbers list from the third element to be equal to 4? Well, as I said, this is element 0, element 1, element 2, and element 3 is the 4 number. Okay? In order to select, for example, the first element in the list, you will need to specify, let me just copy this so I don't write it twice. You will need to specify same right here, just in the brackets you will specify 0, and right now the element would store a value of 1. So if I just print element, it will be equal to 1. Let me just go right here. I just wanted to enlarge these fonts right here. Apply. Okay, so you can see everything better. Not really sure why I didn't do this before, but okay. Yeah. You should see everything really well right now. Let us go with the 16, and that should be it. Okay. Now, right now, let us go over this once again. So what we did is we managed to actually select a specific element from the certain list. So right now, if you, for example, want to select a second element from the list, you would need to specify 1 between the brackets right here. And now printing element will be equal to actually 2, since that is the actual second element in the list. Okay, so now that we got that out of the way, there is one thing that you should know. For example, you can't really, or you can concat strings with elements from a list. So for example, if you want to print something like this, let's first create the actual list of animals, because we are going to print strings. So animals underscore list will be equal, open and close square brackets, and let us just paste these animals. So we'll actually write them twice. Let's just paste them right here in between these square brackets. And now we have animals list, which actually contains bat, dog, elephant, and snake. Now, let me just show you before we continue that animal 1 or animal can be equal to a variable animals list. If you want to select the animal to be equal to bat, you simply just specify 0, since the bat is the first element. And then if you print animal, it will say bat, as you can see right here. Okay, so let's continue now. You can concat strings with elements from the list. So if you want to print something like this, this animal is a, and then you want to actually, for example, concat the animals underscore list, and you want to specify the third element by specifying 2 in the brackets, which is going to be elephant. Okay, and then you want to concat, for example, this animal is an elephant. Okay, so we're missing an right here because we need to use proper English. This animal is an elephant and not a, and then we can concat, for example, a dog. So animals underscore list the dog is at the first position or the second element, and then we can print this. So you can see right here, this animal is an elephant and not a dog, which is what we specified in this sentence right here. Okay, lists can also have multiple lists in them, so the list can actually have an elements that are going to be entire different lists. So let me show you what I mean by that. If we simply create a list with a name list, okay, and then we equal it to be equal to, for example, two different lists. So for example, we want to create a list to be equal to a list of actual ingredients for kitchen and integer numbers. We can do that. So for example, if you open square brackets, now you need to open another square brackets in the square brackets. In there you can specify, for example, 1, 2, 3, 4, 5 as a list of integers, then comma after closing the brackets, and open another square brackets and specify, for example, salt, carrot, basically anything you want, water, and for example, doesn't even matter, you can use, for example, apple, doesn't even matter. So if you press here enter, you successfully created an actual list that has two elements, and both of those elements are entire different lists. So the first element, which will be labeled as element 0, will have a list of integers, and the second element, which will be labeled as element 1, will have a list of, for example, kitchen ingredients, doesn't even matter, so food basically. Okay, and in order to actually select those elements from this list, for example, let's say you want to select only carrot and store it in a variable. So you can call a variable, for example, food to be equal, and then you need to specify how you can get to that simple element in a different element in a bigger list. So you need to specify the list, then open and close bracket, select the element from that list, which is the second element, because the second element is food. So this is the entire second element. And then another open and close bracket, and there you need to specify which element from the second element you want, which is number 1 once again, because carrot is at the second position, which is labeled as element 1. And if we just print food, you can see that the food is now carrot. Okay, simple as that. Let's say right now you want to create an integer value that will be number 4. You want to select 4 from this list. So we can select number variable to be equal to a list, first element of the list, which is the integers numbers, and then the number 4 itself, which is going to be at the third position. And then if we print the number, you can see that the number variable will store a value of 4. Okay. Now, also one more thing that you might be interested in is that you can also use negative indexes to select certain element from the list. Such as, for example, if you have a list, so let's create a new list to be equal to simply just 1, 2, 3, 4, 5. You can select, let's say, the value of 5 in two ways. First one you already know, so list and then specify the 4, which will give you the element of 5. Or you can simply do list and in the bracket specify -1, which will also give you 5 because it will start counting from the end of the list, therefore specifying -1 right here. Okay, so that would be basically it about these basics of lists. Now we're going to continue with the lists in the next lecture, so hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to the second tutorial of Python lists. And right now we're going to simply continue and show you some different stuff you can actually do with the lists themselves. So let us get right into it. So open up your idle. Okay, I will enlarge this, since in the previous video I decided to actually enlarge this so you can see everything a little bit better. Should have remembered to do that straight away, but doesn't even matter, better sooner than never. Okay, so basically you can actually create smaller lists out of the bigger list. So what we did in the previous video, we saw how we can select specific elements from a list, how we can use also negative indexes in order to select elements, how we can create lists that contain elements of different lists. But right now, let us say we have a big list, so we'll just call it big list. And that list will contain both the names of certain people and the integer numbers. So let us do it like that. We'll first of all start by names. Let's say John, comma, then we can use, for example, Jack, and then comma once again, and then let's use, for example, Jane. So 3 different names, then comma, and then we will specify some numbers, okay? So 5 numbers, 5 integer values, and that is our list. So once again, our list consists of names and numbers. Now let's say we want to actually divide this list. We want to create 2 smaller lists that are actually going to be a list of names that is only going to contain names from this list, and the other list will be a list of numbers that is only going to contain the numbers from this list. Okay? So simply, we can do that by specifying a new list. So for example, let's start off by name list. And that name list is going to be equal to big underscore list. And then we want to select which elements we want to take in our name list. And we can do that by specifying from the first element, which is the element labeled as 0, to the third element, which is or fourth element basically, which is the element labeled as number 3. If you press here enter and you print the name list, you can see that we successfully got all 3 names stored into the name underscore list, just by specifying which values we want to take from our bigger list that we coded at the beginning. Now let's do the same for the numbers. For the numbers, we can actually do it something like this. So number underscore list will be equal to big list, and we'll take the values from 3 until the end, or till the 8th element, because we have 8 elements in this list. If you just specify right here and you print the numbers list, so number underscore list, you can see we got the 1, 2, 3, 4, 5. But let's say, for example, that this list was a lot larger and not just 5 integer values. We wouldn't really know what this number is. Therefore, what we want to do is basically we want to find a way that we can actually specify it from the third element, for example, till the end. Now you can do that by simply doing the same thing. So second number list, let us call it like that, will be equal to big underscore list, and basically from third and then 2 dots and then just close square brackets. What this means is it will take everything from the third element until the actual end, no matter how big this list is. Therefore, you don't really need to specify the number of elements in order to get all of this. If this was larger, a lot larger, you would be able to get all of it with simply specifying this. As you can see right here, if I just print it right here, so second number underscore list, you will get the same thing as right here. Okay? Now you can simply do it as well with the beginning of the list itself. So you don't really need to specify name list to be equal like this. You can specify second underscore name underscore list to be equal to big underscore list. And then from the beginning specifying with 2 dots till the third element right here. So what this will do is it will take all the elements from the beginning until the number you specify right here. Therefore, this will be the same as our previous name list. As you can see, it only contains names. Now, of course, if you want to, for example, you can also use negative indexes, such as, for example, you can select the name list or the third underscore name list to be equal to the big list from the actual first element, which is labeled as 0, till the element labeled as -5. Whoops, where is -5? There it is. Specify it like that. And if you print the third element or third name list, you can see it will still contain the names. So there are a bunch of ways that you can actually select different elements or same elements on a different way. You can pick any you want. This really doesn't make any sense, but you can use it if you need it sometimes. This one is mostly useful because you will most likely be dealing in real life with bigger lists. Therefore, you will not really know the amount of lists, even though I will show you right now how you can check the exact number of elements in a certain list. So this one is also useful once you have a smaller list, so this can be used too. But for now on, let me show you how you can actually check the exact number of elements that are in a certain list. So let's say we actually, let me just import os.system. Yeah, okay, this doesn't work in a Python interpreter. I mistook it with an actual shell itself. Let me just see, restart shell. Yeah, that should work. Or basically it will not work. Next is to interrupt execution, next is to previous is okay. Yeah, I'm not really sure if there is any option to actually clear this screen. Doesn't even matter, we will just continue it right here. Basically, what I did right here is restarted the shell, which means that we don't really have any of these values stored anymore. So if you want to print, for example, big list, you will not be able to because it doesn't really exist anymore. Okay, so right now, let us create an actual list that will store, for example, 2 words, hello and world. And now we can count by ourselves and we can know that this actual list has 2 elements, but if we actually have a huge list, let's say a list of databases of different names in a certain website, you would actually need to use something differently than counting by yourself how many names are in that certain list. So you can simply just use a variable, length underscore of underscore lists, which is going to take an integer value returned by a function that we already did before and we were introduced to it, so it is really nothing new. The function is called length, so len, and in the brackets you simply specify from which you want to take the length. You want to take the length from the list, and if you print right now the length of lists, you will have 2, as our list really does have 2 elements. Now you can also do it with numbers as well, so it doesn't really matter. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you perform the same, so length underscore of underscore list will be equal to length of this list right here. Print length underscore of underscore list. Oops. And you will have that it has 9 elements, which is actually correct. So this is a way that you can actually get the number of the elements themselves. And it is really useful in most cases. So that will be about it for this tutorial. Hope you enjoyed this lecture, and I hope I will see you in the next one. Bye. Hello everybody, and welcome back to this tutorial. And what we are going to do right now is we're going to take a look at how we can actually manipulate lists in a way that we can actually change the certain value from a certain element in a specific list. Now what we did by now is we actually saw how we can create multiple lists out of a certain list. We also saw how we can actually get the number of the elements in the list itself with easy length function. And right now let us see how we can actually get certain parts of elements and basically replace them with different parts. So basically, what this video will be explaining is changing values in lists. So let us get right into it. Open up your idle right here. Let me enlarge this so you can see everything better. And let us create a standard list that is going to have names of certain people. So we'll use the same names as before. So John. Let's use, for example, Jack, Jane. And let's switch up a letter. Let's use Adam, for example. So this is our list of names that contains the names of different people. We already know that we can select a different element just by specifying the number of the element in the actual brackets, as we can see right here. We can select that the second element or the third element, if you count from 1, will be equal to Jane. Now let's say we actually made the mistake. As you can see, these 3 are basically starting with the J, and we actually want to switch the Adam to be equal to also a name with J. because let's say this list is only a list of names that start with J, and we want to switch it. We can do that just by typing right here something like this, so list, then we need to specify the element number, which in our case is going to be 3. So the element 3 is Adam, and we need to specify equals and basically to what we want to change it. So let's say we want to change it to Jessica, because that starts with J. Therefore, once we type list once again, right now there is no longer Adam, there is Jessica added instead of Adam. Therefore, our list right now has all the names that start with J. Okay? You can also change it to anything else you want, such as, for example, let's say you want to change the John to be equal to Jack. So you want to have Jack, Jane, Jessica. Okay? You can do that by simply specifying list, and then the first element will be equal to the list of the second element. Therefore, you have 2 Jacks right now, because we selected that the first element of a list should be replaced with the second element of a list. Therefore, now we have 2 Jacks right here. So that is also something that you can do. If you want to, for whatever reason, you can actually specify, for example, Jessica to be equal to true. Therefore, right now you have Jack, Jane, true, which really makes no sense. But as I said, you can do it if you want to. Okay? So also one more thing that you might be interested in is that you can actually add to lists if you want to. So let's say we have a list 1, which is going to be a list of animals. So dog, cat, mouse, and for example, bird. Okay, so we have a list 1, which is only consisted of animals, and in the list 2, we will specify some integer numbers, so 1, 2, 3, 4, 5. If you want to, you can select the list 3, or the sum list, let's call it like that, to be equal to list 1 plus list 2. Therefore, once you print the actual sum list, you will have these 2 actual lists concatenated one to another. Now, in order to actually delete a certain value from the list, you can use a del function, which basically will delete a certain value. So we have a list of numbers, let's say it's list of underscore numbers will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. And we want to, for example, delete the number 7. We don't like it there, we want to delete it. We can do it by simply typing del, and then the list of numbers, and then the element of the, or basically the element that we want to actually delete, which is in our case at the position 6, I believe. Yeah, it is at the position 6. And if you just type here list of numbers, you can see right now it is 1 through 9 without the number 7. You can also, if you want to delete a certain part of the list, so you can do del. And let's say we only want our list to have 1, 2, and 3 in it. We can delete everything from the second element towards the end. So delete list of numbers. And then right here we can specify from the second element till the end, and their list of numbers will only have 1, 2, and 3. Whoops, pardon me. It will actually have 1 and 2 because it also includes this right here. If you wanted to actually cut it from 3 until the end, you will need to specify from 3 or 3 right here, referring to the actual 4, and then till the end, which will cut 4 in, and which will cut out the 4 and all the other numbers after it. Okay, so another thing that you can do with the list is you can simply check whether a certain value exists in that list. So for example, let's say we have a list of strings, or let's say we have a list that is a sentence separated by each word. So for example, my, comma, name, comma, is, and then comma, list. So for example, our list has the values of my name is list in it. You can simply check whether a certain value is in the list. So for example, just by specifying it like this, so name in list, and you will see that it will say right here that it is true. Now it can be used in some if statements. So for example, if name is or not is, you don't really need is. So if name in list, print, or not print, let's say a equals 2, else a equals 0. And now I type here a, and you can see a is equal to 2. So it's not really that useful example, but you can do something like this if you want to. Of course, right here you won't really have a equals 2, a equals 0. You will have some useful code right here. But you can check whether a certain value is stored in that list. Of course, if you specify, for example, dog in list, you will have a false value because dog as a string is not stored in the list. There is no an element that is equal to dog. So that will be basically it about this video. So hope you enjoyed this tutorial, and we're going to continue learning and coding in the next lecture. So hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And right now, what we're going to do is we're going to take a look at some of the functions in list usage, such as, for example, appending till the end of the list, inserting certain elements in the list, sorting out lists by numbers, by letters, or however you want to call it, and also using some of the lists in a loops. So this will be a rather informative video, so make sure to stick till the end, and so you can learn everything really well. And let us get right into it. So open up your idle. Once again, we are not going to code any program. We're only going to introduce ourselves with different functions. And first of all, let us create a simple list that is going to be a simple ingredient list. So for example, we have milk in the list, we have cheese, we have ham, we have, for example, soda, and let's say that's about it. We don't really need any more. Now, you can use a list in a for loop, for example, if you want to print something to the screen. So, for example, we need to buy all of this stuff. How will you print that? So you can print that, for example, for E as an ingredient. So for I in range, open brackets, and then the length of the list. So for I in the range of the length of the list, we can print something like this. Oops, where is the single quotes? Okay, here they are. We need to buy, and then we can plus I. Okay, and if you just press here enter, let me just see. We need to buy plus I. Concatenate string to integer. Okay, let me just try it like this. Maybe for I in list, print, we need to buy plus I. Okay, I'm not really sure why we'll use the range length. The range length is basically, let me just show you. Let's say number is equal, the range length will actually return an integer value, as we can see by the arrow right here. So number equals range length of the list. And you can see if we print the number, we actually get the range of the length, which is going to be an actual 0 to 4, as we have 4 elements right here. So this is not really something that we want yet. We only wanted to print this for now on. So for I in list, so for each ingredient in the list, we can print we need to buy plus that ingredient, and that this I is different element in each iteration of this loop. Okay. We can also check the list index number by using index function. So for example, if you have, we have a list of actual ingredients, so we will use that one. And let's say we want to actually check out what the index of the milk is. So, or let's say ham is, we're going to use the index of the ham. Just in the brackets, all I need to specify is the name of the element. As you can see that the index of the element ham is at the second position, or at the third, or as a third element, since the counting starts from 0 once again. You can also do that with the actual soda, so list.index soda, which will return 3 as an outcome, so soda, and you can see you can get the index of a certain element name just by using the index function right here, okay? So next thing that we want to take a look at is we can actually use different functions to insert or to append different elements to a list, okay? So we have our list right here. Let me just copy it right here. We will just redo it. Not really sure if we changed it throughout this code, but just in case we did, we're going to type it right here once again. And right now, let us say we want to append a certain ingredient at the end of this list. Now, in order to append that, we can use the append function. What it will do is it will add an element at the end of the list. So if you just type right here, list.append, and in the normal brackets, you need to specify what are you appending, and let's say we want to append water. And then if you just type your list once again, you will see that list no longer has 4 elements, it right now has 5 elements, and the last element is the element that we appended in the previous line, which is water, okay? Now, also, you don't really need to append it. Now, maybe you actually want to type it or to insert it somewhere in the middle of the list at a certain position and not at the end, as the append function will do. So the append function will always append at the end of the list. You can't really append in the middle or at the beginning. It will always append at the end. But in order for example, let's say we want the water to be at the, or not the water, let's say we want the apple to be at the 3rd position, which is right after cheese or between cheese and ham, we can do it using the insert function. So you can just type here list.insert, and this function will take 2 parameters. One of those is the actual position where you want to actually place it, and the second one is the actual element that you want to place. So in our case, it will be apple. So we want to place it at the 3rd position, which is labeled as number 2 in lists, then comma, and then we want to type what we actually want to place, which in our case is going to be apple. So apple. And right now, if you just type here list once again, you can see right between the cheese and the ham, we have apple inserted. So of course, you can actually do it multiple times. So list.insert. Let's say you want at the 1st position to insert carrot, which is labeled as number 0, and then carrot right here. Print the list once again, and you can see carrot is now the 1st element in this list. Okay, so this is good. Right now, let us say we want to actually remove a certain element from the list. We can do that just by simply using the remove function. So let me show you right here. If you just type here list.remove, and in between the brackets, you need to specify what element you want to remove. You don't specify the position of the element, you actually specify the element itself. So let's say we want to remove soda, and we print list once again. You can see soda is no longer in the list. We successfully removed it. Now, in order to remove a number, let's say we have number list. So this number list actually has 5 integer values, and in order to remove it, you can just type here number_list.remove, and in between normal brackets, you simply specify the number that you want to remove. For example, 4, and then number list. You will see that 4 is no longer there. So you can also remove numbers, just make sure to not specify single quotes as it will read it as a string, and then you will get an error, okay? So the next thing we can take a look at is the sort function. Now what the sort function will do, it will basically sort numbers from lowest to largest, or it will sort strings from A to Z. Now make sure to not actually use the sort function onto the actual list that has multiple types of variables, otherwise you will get an error. Therefore, this can only be used on a specific types of elements, such as, for example, let's say we have a numbers list, once again, which will contain different values than right now. It will contain 0, 7, 6, -3, 10, minus 2, minus 1, minus or 11, let's say, and that's about it. So the sort function, what it will do in this list is it will sort it from the minus 3 till 11. So if you just type your numbers underscore list dot sort and you print numbers underscore list once again, you can see it sorted it out from the lowest number till the largest number, so from minus 3 till 11. Now you can do the same for the words as well. So if you say, let's say we have strings list, so strings underscore list equals, for example, street, comma, then for example light, comma, then for example add. Now these are just some random words and bullet. Okay, and then basically you type your strings underscore list dot sort, and you want to print the strings list once again. You can see right now it goes from A to Z. As you can see, the first word is now add, then bullet, then light, and then street. But if you try, for example, to have a mixed list, so mixed underscore list equals to 1 and then bullet and then football and then 2 and then 2, 3, 4, then 5.7, and let's say that is our list, and you try to sort that out, so mixed list dot sort, you will get an error as it says not supported between instances of string and integer. Therefore, you can conclude that you can only use the sort function onto a list that is only integer wise or that is only string wise. You can't really use it on mixed lists. Okay? So basically, that would be about it for this tutorial. I hope you enjoyed it, and I hope I can see you in the next one. Take care. Bye. Hello everybody, and welcome back to this tutorial. And what we're going to take a look at right now is something that is similar to lists. Now, we actually saw how we can create lists, manipulate lists, remove elements, add elements, insert elements, sort lists, and all of that stuff. But right now, let me introduce you to some of the things that are actually similar to lists and that are called tuples. Now, basically, the difference is that you can't really change the values in here as you did in the lists. But before we do all of that, you might have noticed that there are certain similarities between a string and a list. For example, if you have a string that is, for example, animal, so animal equals, and then let's say it is elephant, okay, and you can select the first element of this string just by specifying animal and then in the bracket 0, oops, yeah, I specified the wrong bracket, so animal. Right here you can see that it will retrieve a letter E, so this is rather similar as to a list, as you can see that we can also select the different elements from the string itself, and those elements will simply be just a single character. So those are some of the similarities between the lists and the strings. As you can see right here also, if you just specify a negative index, it will also work on strings, just by specifying you the last actual element or character in the string itself. You can also do something like this, so specifying from 1 to 5th element. You can see it is left, it does retrieve it, same as in the lists. And you can also use it in for loops as you used the lists in the previous video. I believe we did it in a for loop, or maybe it was 2 videos ago, doesn't even matter. So for letter in animal, you can actually print each letter right here. So print letter. And you can see it will work. It works the same way in the lists too. So there is also, so I just wanted to point out that there are a lot of similarities between lists and strings. Now there is also something similar you can create to lists just by specifying normal brackets instead of square brackets. For example, if you just type here stuff equals open and close normal brackets, which we usually saw in the actual function declaration, but right now this is not a function, so you can just specify multiple things as you do in lists. So word, then separate by comma, 32 as an integer, then separate by comma, 0.2 as a float value. This will still work, but this is not a list. The difference is, as I said at the beginning of the video, is that you can't really change values in this list. You can select them just as we did in the strings and in the lists right here. You can select them the same way, such as stuff, and then the first element will be word stuff. The second element will be the integer value of 32. You can also select stuff and then from first till the third, which will be 32 and then 0.2. You can do all of that, but if you, for example, you can also, let me just show you, you can also check the length of the actual stuff. As we can see, we get 3 elements back. But as soon as you actually try to do something like this, so stuff, and then the third element, which is going to be 0.2 float value, equals to, for example, 20, you will get an error saying tuple object does not support item assignment, because this is something that is called tuple, and it is different in lists, in syntax, as you see right here we use normal brackets, and also it is different because in tuples you can't change values that are in the tuple itself. Okay? Simply specifying the element right here and selecting it to be 20 won't work, while as this will work in the lists themselves. Now, you can do something different if you, for example, want to create or you want to add a value to the tuple or change a value to the tuple. You can do it in a different way by converting lists to tuples and tuples to lists. It works same as converting a string of number into an integer of number, as we saw before using the string and int and float functions. Those are the functions that we use to convert different types of variables into another type of variable. We can use same thing right here. So if you remember, for example, if we have a string number to be equal to 20 between the single quotes, which this is a string, if you just type here type string underscore number, it is not an integer, so don't confuse it. If you wanted to create it to be an integer, you can just do something like this. So integer number will be equal to integer function, and then in between the brackets you specify string of number, and therefore int underscore number will be equal to an integer, as you can see right here. Okay, you can do the same thing with lists as well. So let's say we have a list that has 1, 2, 3, 4, 5 as the elements of the list. So it basically has 5 integer values. And let's say we actually want to create a tuple from this list. So let's say we call it tuple from list will be equal to simply using tuple function onto our list. Therefore, if you just type here type list, you can see it is a list. And if you just type here type tuple from list, you can see it is a tuple, and it also has the same elements. Not type, I want you to just print the tuple from list. It has the same elements, just the difference is these elements right now can't really be changed or removed, or basically, you can't really change the value of 3 to a 7 if you wanted to. And also the brackets are normal and not square brackets as in lists, so that is the only difference. And you can also change it back if you wanted to. So for example, it really has something different once you try to change it back. It's not the same, so you can't really use something like this. So list from tuple equals list from which list is a function that will create an actual list. So list from tuple from list. This will not work, as it will say list object is not callable. So this reverse function will not really work once you try to create a list from a tuple. In order to create a list from a tuple, you actually need to type something like this. So list from tuple will be equal, and then open 2 brackets, close 2 brackets, and in between those 2 brackets you need to specify the elements of the tuple, which in our case are just 1, 2, 3, 4, 5, but right now we can specify, for example, 1, and then a as a word, and then basically 1.2 as a float value, and then it will work. We will not get error anymore. Therefore, if you just type your list from tuple, you can see right now this will be a list. Oops, let me just see. Yeah, I forgot to use an actual function right here, pardon me. We actually need to do something like this. List from tuple. We need to use this. Copy. Paste right here, and then specify the list prefix right here. What? Let me just check this right here. If I just paste it, maybe it is like this. List object is not callable. Oh, okay, that's because I actually used a name list right here. So let me just restart this. Yeah, this is an actual error that I told you even before. Don't use an actual name for certain variables or lists that are also pre-designed in Python 3, as you can see right here. List is a used list to actually make a list, but you should never call list simply just a list, because this is an inbuilt function in Python that will convert anything to a list. As you can see right here, let us create a simple tuple once again. So tuple object equals to, for example, let's use the same value. So 1a and 1.2. And then we want to convert it to list. So list underscore objects, make sure to call it differently than just simply list, will be equal to list from tuple object. And you can see right now list object is the same elements right here, just right now this is a list. And then you can change some value. For example, you want to select list object from the second element will be equal to b instead of a. List object just to check if we successfully created it, and then you can convert it back to tuple. So tuple object, object is equal to tuple from the list object. And now tuple object is successfully changed, even though we can't really change the tuple object. So we had to convert it back to a list, then convert it back to a tuple in order to change this value right here to be equal to this value right here. Okay. One more interesting thing that you actually should know is that you can actually create a list from a string if you want to. So let's say we have a string that is equal to, for example, today is a really good day. And this is our string, and let's say we want to actually convert it to a list. We will also use the simple list function. So list underscore from underscore string will be equal to a list from string. And if we just try to print it right here, you can see our list from string. Oops, oh yeah, I accidentally named this list from sting. Doesn't even matter, let us just type it like that, list from sting. And therefore you can see that right now we have a list that is consisted of all the elements in this actual string that we specified right here. So every single element is a single character, so that is how converting strings to lists work. Okay, so there is also another way that you can actually copy lists using Python 3 library. We saw previously how we can actually copy lists. You simply just select another list to be equal to a third list, but you can actually use a Python library if you feel like that will be easier for you. The library that you can use is called copy, so import copy in order to import that library. And you can simply just, let's say, we create list 1 to be equal to, let's say, some sentence. So in the room there are 8 chairs. So simple as that. This is our list 1. And let's say we want to copy that list to a different list using the copy library that we imported. We can do it simply like this. So list 2 equals copy.copy list 1. Simple as that. And if you just print list 2, you will see that the actual list 2 will have the same elements as list 1. If you just perform a simple check, list 1 equals list 2, you can see that we get a value of true, which means they are exactly the same. So that will be about it for this tutorial. I hope you enjoyed it, and I hope I will see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And what we are going to do right now is we are going to introduce ourselves to something called dictionaries in Python 3. Now what we saw previously is we saw lists and tuples, but right now this is something different. This basically what a dictionary is in a Python is it is a collection of many values just like a list, but in the dictionary we actually have two separate types of values. One of those are keys and other ones are values, and they're all separated by two dots. Now I will show you just in a second. So let me open up my idle right here. Just go right down here, type idle, and right here I will show you a simple example of a dictionary. So let's say we call it our_dictionary will be equal. Now the syntax for actually opening the dictionary is these curvy brackets right here. Now they are not normal brackets, they are also not square brackets. These are some different types of brackets. I call them curvy, not really sure how to call them. But these type of brackets actually reference to Python 3 that we are using an actual dictionary. Now, as I said before, the dictionary has two types of values. One of those are keys and the other ones are the values themselves. So the first value will be a value key, which we can simply just, let's say we use 5 as a key, and the value of 5 will be 5 as an integer. Then you separate comma. Let's say we use a second element, which will be 3, for example, which is going to be a key for 3 integer. And the 2, which is going to be a key for the 2 integer. Whoops, yeah, I actually mistyped this. Here should be 2 dots and not a comma. So let me just copy this, paste it right here, and instead of 2 dots, I'll specify simply, instead of comma, I'll specify simply 2 dots, and this will work, okay? So once again, keys in this dictionary are 5, 3, and 2, and the values are in this dictionary are 5, 3, and 2 as integer digits, okay? Now, in order to actually access a certain value, you need to specify dictionary name and key. Such as, for example, let's say we want to specify a value of integer number 5. In order to do that, we will need to specify our_dictionary. And in these square brackets right now, that is how we specify the actual element. It is the same as in the actual list themselves. We need to specify the key to the value that we are searching for. As we said before, we are searching for the integer number 5, and its key is 5 written as a string. So we'll just type here 5, and you can see the Python 3 interpreter will return number 5 back to us. Okay. Let us try with a different one. So let us try with 2. So our_dictionary. And in between we need to specify the key for integer number 2. It will return 2. Okay. So right now we can also use it. We can also use it basically in printing statements if we want to, such as, for example, let's say we want to print this. So print, open and close brackets. And right here, let's say we want to print there are, and then space, we want to add dictionary. We use the key, for example, 3 right now. So 3 plus glasses on the table, for example. So let's add dot right here, and let's do something like this. Let me just see what the error is. Yeah, we called it our dictionary. We didn't call it dictionary. So let me just copy this. I will just add our in the statement itself. So just go right here, add our. Okay, so yeah, once again, the value is actual integer, and we can't concat strings to integers. So we need to actually convert it to a string before we actually copy it. So go right here, add string. And at the end, also add the bracket. And you can see right here, there are 3 glasses on the table. so we can also use dictionaries in our print statements if we want to. And right now, let's take a look at a simple program using a dictionary. What we're going to do is we're going to write a program that is going to have a dictionary of different people and their different exam marks. So the key would be a name of a certain person, and the value would be the mark that they received on a test. Then we will prompt the user of the program to enter a name for a person that they want to check the mark to, and then we will print out the exam mark that that person got. So let us close this. So I will restart it. I'm not really sure why I did that, but it doesn't even matter. Let us just go right here, open this up, and let's start off by creating our dictionary. So exam, let's first of all type right here, Python program. Let's say we call it exam marks. So it's simple as that. Let us save it. So go right here. We have our Python programs folder, exammarks.py. Save it right here. Okay. And we can start coding. So exam_marks will be the name of our actual dictionary. We need to use these curly brackets right here in order to reference to the Python tree that we are using it. And right now, let us specify some names and different marks. So Jake, we'll use usual names, got A. Now, of course, I didn't mention it, but the key and the value can also be a string. So we saw previously that the value was actual integer, but you can also make it to be a string, comma. Then let's use, for example, Jack got, for example, D as an exam mark. The Jane, for example, got B. And Adam failed the test and he got F. So let us just type it right here, F. So this is our dictionary that consists of people's not usernames, of people's names and their marks on the test. And right now, let us print something like this. So enter a name of a person you want to check the exam mark for. Simple as that. Oops, check right here. Okay, you want to check the exam mark for, and then we will basically just use a variable called person name to be equal to input, and then we will just type here name. Simple as that. So name, just like that. And then first of all, what we want to check out is whether the user of this program actually typed anything. So if person_name is equal to none, we want to break out of this program. And if it is not, so if name is, if name in exam_marks, so if that name that the user specified is in the actual dictionary, we will print exam mark for, and then we will add from the dictionary, first of all, we will add the person name for person name plus is plus, and now we will add from the dictionary, so exam_marks, and we actually need to set the key right here, and the key will be the person name that the actual user inputted. So the plus exam marks, and in the brackets we specify the key, and the key is the person_name. And with the person name key, we will get the value, which will be the exam mark. Okay. Else, since if the name is not in the actual exam marks, and pardon me, it is not name, it is person name. So else, we want to print can't seem to find results for, and then we will concat the person name, letting know the user that that name is not in our database, or basically in our current dictionary. Okay, so let us save this, save it right here. Let us run it, break outside of the loop. Okay, not break, I would just want to type here exit. We don't want to break. Run module, save, right here. So enter name of person you want to check the exam mark for. Let's go with, for example, Jack. Exam mark for Jack is D. So let's check if that is correct. It is correct. So let us run it once again, run module. Let's check for the Jane. Exam mark for Jane is B, which is also correct. Now let us check for a name that doesn't even exist, such as, for example, let me check what name we didn't code right here, Jessica. So Jessica is not here, so let us just type it right here. It will say, can't seem to find result for Jessica. So simple as that. So this is just a simple program using dictionaries, just so you can understand it a little bit better. So hope you enjoyed this tutorial, and we will continue coding and explaining dictionaries in the next tutorial. Hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And what we are going to do right now is we're going to take a look at some of the functions in using dictionaries, such as, for example, items, keys, and values. Now we did the same for lists. For example, we saw some of the functions that are used in order to manipulate lists. Right now we're going to take a look at some of the functions that are used so we can manipulate actual dictionaries. So open up your idle once again. Let's open it up right here and launch this. And basically what these functions allow us is to retrieve certain desired elements similar to the lists, as I said before. So for example, to get values from dictionary, we can use values function. So let's say we have an age dictionary, age underscore dictionary, that will have an actual key as a name of a person, and the value will be the age of a person. So let's say Jack, our usual Jack, is 30 years old. Let's say John is 5 years old. Let's say Jane is 20 years old. And let's say Adam is, for example, 15 years old. Okay? So we got our age dictionary with different names and different value or different ages for certain person. And what we want to check right now is for every value in age dictionary, we want to print that value. So basically we're only going to print the age. So we can use a for loop to do that. So for value, which is going to be our counter, or basically, yeah, it's going to be some kind of a counter. For value in age underscore dictionary dot values, which is the function that will help us retrieve the values from our dictionary, we want to print that value. So print value. If I just press here enter, you can see that we only get the actual output of the ages stored in our dictionary. So same thing we can do with the keys. So if you just type here for key in age underscore dictionary dot keys, which is a function that will help us retrieve the keys, we can print that certain key, which will print all the names in our dictionary. As you can see right here, we got Jack, John, Jane, and Adam. Okay? But if you, for example, wanted to, let's say, print these together, you also wanted to print the name and the actual age in a certain line, you can do that with the items function. So for each item in age underscore dictionary dot items, two dots, let me just find where it is. Okay, so right here, two dots, we want to print that item. So this is all the same. You can see right here, we're going to get the actual key and the value from our dictionary, as you can see right here. Okay, but one more thing, you can also combine and store in two different variables. What I mean by that is basically you can type something like this. So for person and age, so you can do that for person comma age in age underscore dictionary dot items. What this basically right here will do is it will store the first part or the first element, which is Jack, into the person variable, and the second element, which is 30 years, into the age variable. So we'll have two separate variables containing the keys and values. So you can do this without actually doing all this stuff that we did before. So for person and age in age dictionary.items, we can print, for example, let's say the age of, then space, we can concat that to the person plus, then to open single quotes, is, and we can actually concat the age itself. Just make sure that the age is actual string value of age, because otherwise it will not print. And press here enter, and we can see right here the age of Jack is 30, the age of John is 5, the age of Jane is 20, and the age of Adam is 15. Okay, so one more thing before we actually conclude this video, which was rather short. You can also use function get, which is inbuilt function, to select certain key or value from the dictionary. What the get function does is basically it will take two arguments, one of which is the key of the value in dictionary, and the second one is the value that it will return if the key doesn't exist. So let me show you what I mean by that. Let us say, for example, person name is an input, so we prompt the user for this. Enter name. And let's say we enter the name Adam, so we're interested in Adam technically. We want to actually find out how old is Adam. And then we can print the age of plus the person name, which is our variable storing the input information that we prompted to the user, is plus the string, and then by the person name we are going to select the actual value from the dictionary, so string from the age dictionary. Now the reason why we are using string is because we're returning an integer value, so we have to convert it. Age dictionary.get, and in the brackets, as I said before, the get function actually takes two inputs. One of those is the actual key value, which is person underscore name, and the other one is what value will it retrieve if that person doesn't exist. Now, since we know that the person exists, it will retrieve 15, but if the person doesn't exist, let's say we retrieve -1. That way we can actually let users know that that person doesn't exist because nobody is -1 years old. Okay, and then we can actually plus the years because we are printing a statement. So let me just see right here. The age of Adam is 15 years. Okay, and now let's do the same thing just by specifying the wrong name to see what it will say. Let's say we use Jessica because she's not in the actual list, or pardon me, in the dictionary. And then we will copy this right here. We will not change anything right here because we can leave it as the same print statement. And you can see the age of Jessica is -1 years because Jessica is not in this actual dictionary right here. So basically I just wanted to show you that in this video what we took a look at is the keys, items, and values function, also as the get function from here. So we took a look at some of the functions used to actually manipulate with dictionaries, and I hope you enjoyed this tutorial, and I hope I will see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial, and right now we're going to take a look at something called dictionary comprehension. So we're going to actually try to understand dictionaries at a whole another level. Now what this basically tutorial will be about is a little bit more advanced than the previous ones about dictionaries, because we're going to take a look at defining dictionaries in a certain more advanced way. So open up your idle once again. Now if you don't understand this, don't really worry. This is not really something that you will encounter a lot of time and that you will use like this, but it is good to know. So let's say we actually create a dictionary called Dictionary1. We'll just call it like that. What this dictionary will have is basically, let's say A as a key value to 1, B as a key value to 2. So basically we are going to just type some letters and numbers, doesn't even matter what it is. C as a key value to 3. Let's use D and E, and we will basically finish there. So D is 4 and E is 5. Okay, so we defined our Dictionary1. Now let's say how we could actually double each value in the dictionary. I mean the fastest way. So how can we actually double each value in the dictionary? We can do it something like this. So let's create a double dictionary. Dictionary1 will be equal, and let's open and close curly brackets for key value. For each key, we will take a value times 2. So now you might be asking, what is key and v? Well, basically these are some kind of a counter. So key and v times 2 for each key, for each k and v. I'm not really sure why it said key and v. For each k and v in, and we will use a function that we actually saw in the previous video, which is items. So in dictionary1.items. So what this right here will do is it will create a double dictionary one, which will basically have values of keys the same, but the values for those keys will be twice as large. So let me just show you right here. If I just type double dictionary 1 right here, you can see that the A is 2, B is 4, C is 6, D is 8, and the E is 10. So this was a simple way to actually double all the values in the dictionary, which is useful if you, for example, have a huge dictionary and basically you need to double all of those values. You can do it with a certain single line, just like this one. Now, you can also make changes to the key values if you wanted to. For example, let's create the same dictionary as above, but also change the names of the key. So we can do it just like this. Dictionary underscore keys. Let's say we call it like that. So dictionary 1 underscore keys will be equal to, we're going to use this one, not this one. So we're using this one. So it is going to be equal to k times 2, for example, and then we will leave the value to be the same. So the value will be 1, 2, 3, 4, 5, 4, and then the same just in the previous example. So k and v in dictionary1.items. So in dictionary1.items, right, just like this. And then if I just start to print it right here, dictionary1 underscore keys, you can see that right now the keys are switched to be double A, double B, double C, double D, and double E. Okay, so simple as that. Now, let's say you consider the following problem. So for example, you want to create a new dictionary where the key is a number divisible by 2. In a range of 1 through 10, and its value is the square number. So let's see how the same problem can be solved using a for loop and dictionary comprehension. So we want to actually really understand what we're doing. Let me just show you in case you don't really understand. So let's say numbers will be equal to range from 10. As you can see, if I just type here numbers, you can see we got numbers that are going to be from 0 to 10. Okay? Then we will create a new dictionary. So new dictionary equals empty. Oops, not these brackets right here. So it is empty. And right now what we're going to do is we're going to add values to the new dictionary using for loop. So for n in numbers, so for each number between 0 through 10, we want to first of all check if n is divisible by 2. Okay, so if oops, yeah, we actually need to add 2 dots at the end. So for n in numbers, if n is divisible by 2, what we want to do is we want to type here new underscore dictionary, and then n as an element or as a key will be equal to n squared. So n and then 2 stars times 2, which basically stands for squared number, as we saw in the basics section. So what we're checking right here, so for each number in the range from 1 to 10, we first of all check whether that number is divisible by 2. If it is, we will actually, for that key, for that number in the dictionary, we will paste a value that is going to be squared that number. So let us press enter and let us print new dictionary. And you can see right here, 0 is 0, 2 is 4, 4 is 16, 6 is 36, 8 is 64. So these are all the numbers that are divisible by 2. Their keys, basically all the numbers that are divisible by 2 became keys in our dictionary, and their values are squared keys, as we can see right here. Now, another way to do the program above without using the for loop like this, we can use everything and do everything in a one line with dictionary comprehension. So we can just do it new dictionary 2 equals number, which is going to be our key, and then number squared for each number in numbers if number is divisible by 2. Simple as that. So we did all of this in just one line, and if I just print the new dictionary, you can see it is exactly the same as this one, as we can check with this statement as well. So new dictionary equal to new dictionary 2. And we will get a value of true. So these are two ways to actually do this. If you want to, you can use this one. If you don't really understand it, you can always use this one. So this one will work always. And basically that would be about it for this tutorial. Hope you enjoyed it, and I hope I will see you in the next one. Bye. Hello everybody, and welcome back to this tutorial. And right now we're going to continue with our dictionary comprehension. Now basically what we did in the previous video is we saw some of the examples or some of the different examples of how we can create a dictionary which specified certain values and keys. Basically we saw how we can actually change all of the values of keys in a dictionary with a simple command. And right now, let's say for example you don't want to change every key, you want to change all the keys that actually have something in common. We're going to take a look at that. So we're going to take a look at dictionaries with the if condition. And first of all, open up your idle. Okay, so go up here, type idle. Let's open it up. And let's suppose you need to create a new dictionary. Let me just enlarge this. So let's suppose you need to create a new dictionary from a given dictionary, but with items that are greater than 2. Now, this means that you need to add a condition to the original template you know, or you saw above. Let me just show you right here. If we just create a dictionary, let's call it dictionary 1, just for the sake of the tutorial. Open and close the query brackets, and let's add, for example, letters. So for example, a value or a key will equal to the value of 1. Same with the B, just B will be equal to the value of 2. C to the value of 3. And let's add 2 more letters, just as we did before. D will be equal to the value of 4. And E to the value of 5. So this is our dictionary 1. Now, let's say we want to create a new dictionary from this one, and we have to check which items are greater than 2. So for example, for each key and for each value in our items, and just to remember you that the items are both of these, so both key and value. If you just use the items function, it will print out key correspondent to its value. So in order to check out what items are greater than 2, we can check out if the value is greater than 2, because there is really no point in checking out whether the key is greater than 2, because a letter can't really be compared to a number. Therefore, we're only going to check out the values themselves, as they are the integer numbers. Okay, so in order to do that, let us make a dictionary 2. And we're going to use an if statement inside the dictionary curly bracket. So for key or k, so key value, key 2 dots value, for each key and for each value in dictionary 1 dot items, if the value is greater, let me just find the greater sign. Yeah, that is really good when you don't know where it is on your keyboard. And never mind, I will just switch all back to the different keyboard. Okay, if value is greater, let me just now switch back, is greater than 2. So you can see right here we created the same dictionary out of the first one, and if we print out the second dictionary right here, you can see that the dictionary will only contain values and keys that have the value greater than 2. So A and B are not anymore in this dictionary. Okay, so right now, in this problem right here, let's say what if you actually have to not only get the items that are greater than 2, but also you need to check if they are multiplies of 2 at the same time. So what we're going to do is we're going to use the same dictionary right here in order to perform that check as well. And then we're going to print that third dictionary to the screen. So once again, we are checking whether the value is greater than 2, and also if the value divided by 2 will leave some remain behind, or whether it is divisible or not, basically. So let us see how that will go. Also with the if statement, we're going to perform that. So dictionary 3 will be equal, and once again we're going to use the dictionary 1 to do this. So open and close curly brackets right here, and each key and value, as usual, for key and value. So open and close brackets for key comma value in dictionary 1 dot items. And we can basically use this statement right here that we used before, because that is also something we need to check. So if value is greater, and once again I need to change the keyboard, and if value is greater than 2, and also if value module 2 is equal to 1, basically, or pardon me, is equal to 0. If you wanted to, for example, say equal to 1, it would give you the non-divisible numbers. We will check that out later on, but for now on, if you just press here enter with this statement right here and you print the dictionary 3, you can see we only have the 4, because 5 and 3 are not divisible by the actual 2, or they actually have a remain once they divide themselves with the 2. Only number is 4, and its key is basically D, therefore our dictionary 3 only consists of this item. If we wanted to actually have the other 2, which is the C and E, we would just have to copy this statement right here and use the same statement, just change right here from 0 to 1, and you can see right now dictionary 3 will have the other 2 values, as you can see, C and E. Okay, so basically that would be about it for the if statements in dictionaries. Now, if you find this way easier of defining dictionaries, feel free to use it. You can also use the for and if statements outside of the dictionaries if that is something that you are more comfortable with. We saw the example in the previous video of that. So we saw both the example of using for loop outside of the dictionary and for loop inside of the dictionary. So I just want to show you that this is also something that can be done. And basically that would be a wrap up about the dictionaries, and we are going to continue coding in the next lecture. So hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And right now we're going to talk a little bit more about strings. Now, we did talk about them before in the basics of Python 3 programming, and also in the lists we mentioned strings here and there. We said how they can actually be used, and some of the functions that actually apply to the lists also apply to the strings, such as, for example, the defining of each element. Now you can define each element of string as well as define each element of the list itself. Now those are some of the similarities, but right now what we're going to do is we're going to take a look at different functions and useful things you need to know when you are dealing with strings. So open up your idle. Still, we're not going to code anything yet. We're still learning, and the more we learn, the better our programs will be later on. So, as I said, let's talk a little bit more about strings. So, we learned in the beginning that the strings start and end with a single quote. So, for example, if we have a string 1, to be equal, and then you use single quotes, and here you can just type hello. So string 1 is defined by these single quotes. But there is also a definition of strings with double quotes, so you don't really need to use a single quotes to define a string. The actual string 2 equals to the same word, so hello, but right now, let me just find where the double quotes are. Once again, need to change the keyboard. Should have done this at the Ubuntu machine, but doesn't even matter. You can use the double quotes as well and define hello. If you compare these two, string 2, pardon me, not equal, we want to use double equal, because remember, one equal is only assigning the value. You can see that they are true because they are the same actual value, so you can actually use both of these definitions to define a string. Okay? Now, one more thing that is useful about this is that you can actually use double quotes and single quotes whether or once you actually want to use a single quote in the string itself. So for example, if you have a string 3 and you try to use something like this, so let's say I am good today. And basically, if you can see right here, it will say invalid syntax if you try to use a quote inside the syntax itself, inside the string itself. As you can see, this first quote right here was closed by the second quote that we didn't really want to close it, but the Python 3 doesn't really know whether this quote belongs to the actual string itself, or whether that quote is just a quote at the end of the string defining the string itself. So basically, in order to avoid this, you can just use string 3 equals and then use the double quotes and then I and then single quotes am good today dot and then double quotes at the end. And right now our string 3, if we print it to the screen, will have the actual quote right here, and we will no longer get the actual syntax error. So that is also another thing that is useful to know, and also another thing that the double and single quotes are used for. But if you, for example, want to use a single quotes for whatever reason, you can define a single quote in a string that Python will know that it belongs to the string with the backslash. So, for example, string 3, once again, will be equal, and right now we start with a single quote, I, single quote, am good today. Dot single quote. So this will give us a syntax error, but if you go right here and just add a backslash, you can see that the whole string turns green, saying that right now this is an entire string, and if you press here enter, your Python 3 will no longer give you an invalid syntax error as it did right here. So the backslash and then the actual quote right here will let the Python know that this string doesn't really mark the end of it. So that is also something you want to know. Of course, same thing with the double quotes. So you can use something like this, double quotes or single quotes, whatever you want. I and then slash and then double quotes. Am good today, even though this is not really how you would write it, but you can do it if you want to. Wherever you need the double quotes, you can implement it with the backslash and then the double quotes. Same with the single quotes as well. Now, if you wanted to, for example, tab a string or tab in a string, such as this one, you can do that by simply specifying string 4, for example, to be equal, and then open and close single quotes, and then backslash T, which stands for tabbing. And then you write hello. And you can see if we print string 4, you can see that the hello will have the backslash T right here. Now, this is not, let me just show you, so you can see it actually a little bit better. Maybe I should have showed this example instead. So hello, and then backslash T, world. Not word, but doesn't even matter, string 4. Let me just check something out. Yeah, okay, so I need to print it out in order to show it. As you can see right here, the string, now don't really mind right here that it says word instead of world, but doesn't even matter. You can see right here, once you print the string, even though we didn't add any space, the tab value will tab it for us. Therefore, we know each amount of space that is tabbed between two words. So for example, if you have string 5 equals to basically today, and then you want to add tab is, and then tab, and then tab, oops, /t. Today is a good /t, and then day, and then dot, and you define the end with a single quote, and you want to print the string 5. All of these actual words will have the same amount of space between each other. Okay, so that is also something useful to know. The next thing in strings is the \n, which basically stands for a new line of a string. So once you use the \n, it will let Python know that you want to go into the next line and continue the rest of the string. So for example, if we have a string 6 to be equal, and then we type here hello \n, and then world. Not once again world. You can see if we print this string right here, that this string will actually be into lines. So it will not be one next to another. It will be hello and then new line and then world. Okay, so that is also another thing useful to know. And another thing, not so important, but if you want to use a slash in an actual Python string, you need to use double / in order to define it. So for example, string 7, if you wanted to actually use a slash in a string itself, you would just type here hello and then 2 slashes and then world. And then right now, if you print the string 7, it will have a / in it, as you can see right here. So the definition of this / is 2 backslashes. Okay, so really easy to remember. Now, in order to combine all of this, you can print something like this. So print, open double quotes, what is your name? And then you can use basically, let me just add the question mark, and then \n for the new line. Another actual question. So how old are you? \n, \t. And basically, or pardon me, yeah, \n, \t, and then type something like I single quote am 20 years old, exclamation mark. If you just type it, print it right here, you can see how it will print it out. So let's go over the string. What is your name? Then at the end, we only added the \n, which will just go into the next line. And right here, we have how old are you? \n goes to the next line. So our cursor is right here. Then we added the \t, which will tab this next sentence in, as you can see right here. And then afterwards, it will print out I, / and then single quote, which will be defined as a single quote in the string itself, and 20 years old. So those are some of the ways that we actually learned in this lesson that you can actually define in a string to make it look a little bit better. Now, there is also another thing that you should know, is that you can actually define a multi-line string without all of this stuff. So you don't really need to add \n every time. In order to write a new line string, you can do simply something like this. So string 8 will be equal, and then instead of opening and closing single quotes or double quotes, just open 3 single quotes. Then type anything you want. So hello there, my name is Adam, press enter for new line, I am 20 years old, and I like to play football, for example. And then at the end of the string, close the 3 single quotes, and you can see it will not give you any error out, because the 3 open single quotes and 3 closed single quotes will define a new line string, or basically a multi-line string. So if you print string 8 right here, print it out, you can see it prints out everything as we typed it. Okay, so that is also really important thing to know. And also, as we saw before, we know that the actual strings can be selected or the specific characters can be selected from a string the same way that they are selected in the actual list as elements. So you can see right here, if we have a string that equals to hello, you can select the string character 0 or labeled as number 0, which will return H for us. String from 0 to third element, will return first 3 letters. The -1 index also works, which will return the last letter. And also you can use what we did in the lists before, which is from the beginning till the third character, and also from the actual third character till the end, for example, as you can see right here. So this is basically just a reminder that you can do the same with the strings that you did before with the actual lists. So basically that would be about it for this string lesson. We're going to continue with different functions that are used in strings in the next tutorial. So hope you enjoyed this lecture, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now we're going to take a look at the operators in and not in a string. And also we're going to take a look at some of the different functions, such as the upper, lower, is upper, and is lower, that are actually used on strings. So for example, if you have a string that is with both upper and lower case, you can make that string lowercase with a simple function. You can also check whether it is lower or uppercase with a different function. So we are going to take a look at that in this tutorial. So let's open up our idle right here. So I will go right here, type idle as usual, enlarge my window so we can see everything better. And right here, let us start off with the operator in. Now, we maybe saw this in the previous tutorials for a brief view, but right now let us take a look at that in a more detailed matter. So for example, if we have a string that says basically today is a nice day. This is our string. As you can see, once we type it, it will print it out to the screen. But let's say the string is a lot bigger than this, and we want to check for a specific word or a specific thing in a string to see whether it is in it or not. So for example, if we wanted to check for today, whether that string is in the actual string that we typed right here, we can do that with just specifying the string name. So today in, and then the string name, or the string that we are going to check it in. So today is a nice day. And you can see that this will actually return a value of true. Now you can do the same, of course, with the string variable. So string equals, or string1 equals, today is a nice day. You don't really need to type all of this right here. And you can set the string2 to be equal to today. And then you can just type here string2 in string1, and you will return the value of true, because string2 is really in the string1 as well. But be careful on the lower and uppercase letters. As you can see right here, if I just type here today in today is a nice day, you can see that this right here will actually return a value of false, because this is a capital letters today, and today in the actual string is not capital. So therefore we get the false right here. So keep track of the lowercase and uppercase letters once you do this. You can also take a look at the wrong word. So for example, tomorrow in today is a nice day will also return, of course, the value of false. So right now that we got that out of the way, you can also take a look at the not in. So for example, tomorrow not in, today is a nice day. This will of course return a value of true, because tomorrow is not in this actual string right here. So you can just basically read this like normal English. Tomorrow not in today is a nice day, which is true, because it really isn't there. So that is also something to take a look at. And right now, since we notice that right here we actually have a problem once we actually specify a same actual word but with uppercase letters instead of lowercase, it will return a value of false, even though this word is actually in this sentence right here. So let us see the actual functions that help us resolve this. So first of all, we have the actual upper function. So you can see right here, if I set the string to be equal to today, and I just type here string.upper, open and close brackets, you can see that it will print out that the actual string of the today, which we actually made to be a lowercase, and I use string.upper, it will turn that string into the uppercase. So this problem right here can be resolved just by simply specifying. So let's say we have string2, or we do have string2, we can actually use a lower function right now. So let's say we want to actually make this to be true right now. We have a string2, or string upper. Now let's just call it string2 equals uppercase today, and string1 will be equal to normal sentence from before, today is a nice day. You can see that even if I just type here string2.lower in string1, we will still get a value of false, because string2.lower, if I just print it to the screen, will actually return a lowercase today. And right here we actually have a today, which is not a lowercase, which actually has a capital T at the beginning of the sentence. So in order to bypass that as well, we can just type something like this. So string2.lower in string1.lower. And right now we actually get the value of true, because we turned everything into a lowercase. Therefore we actually compare that then, and then we get the actual true value. So you can do that same with the upper. So string2.upper in string1.upper will also return a true value. Okay, so right now you can perform the check right here whether something is capital or not. So for example, let's say with the is upper and is lower function. So for example, let's say you have a name variable that is going to be equal to the input, open and close brackets, and let's prompt the user enter your name right here, and we type here Adam, for example. Let's say the username is the Adam, and if I just print name, it will print Adam. If I just print name.upper, it will print Adam in capital, and name.lower will print Adam in lower. So we already knew this, we just wanted to make sure. But right now, let us check whether the Adam is lower or uppercase. We can do that with the isLower function. So name.isLower will return a value of false, because Adam actually has capital A at the beginning, as well as name.isUpper will not return a true value, because Adam, of course, is not uppercase. So these are two functions that will actually return a Boolean value for the specific word that you are testing. Now, don't actually compare them with these two. What the lower function and upper function will do is they will turn a string into a lower and uppercase, and the isLower and isUpper function will return a Boolean value, either true or false, depending on the string that you specified in the function itself. So you can also check it like this. You don't have to use a variable. You can just type today dot is upper, and this should return a true value because today's string is uppercase. Okay, so that is also something to take a look at. Now you can also try it with a string that has numbers, such as, for example, if you have A1, B2, C3, and you want to perform a check whether that is lowercase, you can do that, and it will actually return a value of true, because all the actual letters right here basically are lowercase. Even though there are some numbers, it skips those numbers and it checks only letters. If you, for example, had A1, B2, C3, and then let me just add the actual single quotes, so let's not forget that as well. And then is lower, this will return a value of false because there is a capital B. Now, what you can't do is you can't really perform this on the actual numbers. You can't really perform it on a single 1, 2, 3 and just try to check is lower. It will return a value of false, which basically doesn't give you an error, which is a good thing. But also if you try to check whether it is upper, it will also return a value of false. So the number string is not either false, is not either lower or upper. So that is also something that you should remember. So basically that would be about it for this tutorial. We took a look at some of these functions. And we're going to take a look at the different stuff in the next tutorial. And we're going to continue coding in the next tutorial. So hope I see you there and take care. Bye. Hello everybody and welcome back to this tutorial, and right now we're going to finish up with our strings and we're going to take a look at the last functions that we are going to use with our strings, which is starts with, ends with, join, split, and strip function. Now basically those are some of the important functions that allow us to manipulate strings on a whole another level. Basically to check whether a string starts with a certain word or not, or basically if it ends as well. So that is the ends with function what we will do. And the join function will actually join two strings, as we will see later on. The split function of course splits strings, and strip function will strip out the string from a specified character or a new line character or tab character or whatever you specify in between the brackets. Now right now we're going to take a look at, first of all, with the starts with and ends with function. So open up your idle if you already didn't. And right here, let's say we have a string one that is going to be equal to my name is John. So my name is John. This is our string one. And right now, for some reason, you want to check out whether this string actually starts with a word my. You can do that on two different ways. So you can use string one dot starts with, and then in the brackets you can specify the actual word that you're searching for. So for example, my, and this will return a boolean value that will either be a true or a false value. Now of course you can also have a string 2 to be equal to 2, or pardon me, to be equal to my, and then you can do something like this: string 1 starts with, and then string 2 in between the brackets, which is exactly the same thing as right here, just by using only variables. And you can see right here, it also returns true value. Okay, now you can also use ends with to check whether this ends with a John name. So you can just type right here, string 1 ends with, and in between the brackets you can specify John. Now, this will return a false value, and if you take a closer look, you will notice why. That is because we actually have a dot at the end of our string. Therefore, John is not really the last string that is in our sentence right here. Okay, so in order to check whether if we add a dot, it will be true, you can just type here string 1 ends with, and then in between brackets specify John with a dot. And right now you can see that we actually have a true value. Okay, so this can be useful in some programs, such as, for example, let's say we have a string 3 to be equal to, let's say, my, or let's type it right here, like this. So name equals input, and then we will specify right here, enter your name to the user. And let's say they type here Adam, and right here we will just perform a simple check. So if name starts with, now we can use starts with or ends with, doesn't even matter since this is a one word string, starts with name, or pardon me, not with name, we want to specify right here starts with Adam, we can just print right here hello administrator, and then plus Adam. Or we can use plus name simply. You can use plus name just to concat the actual string. And else, in any other case, if it doesn't start with the actual Adam, we'll just print hello member, and then once again we will concat the name. As you can see, it will print out hello administrator Adam because this name variable actually starts with Adam. So that is some kind of a basic example that you can perform with these two functions right here. Now, of course, there are more useful ways to do them, but this is just what came up in my head right at the moment. So let us continue with the next actual function that we're going to cover in this lecture, which is the method join. So what the join method, as I said before, will do is it will take a list of arrays or strings and make them one big array. So for example, if you just specify right here list1 equals, and then right here you can specify different names. We will use our regular names, so John, and then Jack, oops, and then Jane, and Adam at the end. So Adam, this is our list1, and in order to actually join all of these strings right here without actually having anything in between these names, you can just type here open and close single quotes, and then dot join, and then open and close brackets, list1. Whoops, not list. We need list1 and not list. So open and close single quotes, dot join, and here in the between in brackets, list1. And you can see John, Jack, Jane, Adam. As you can see right here, if you wanted to add some space, you can just simply just open single quotes, spacebar, single quote, dot join, and once again list1, and this will print everything in a line with the space itself. Now if you want to add comma, for example, you can simply do by specifying it in between the single quotes, and then dot join, and once again list1. And also, if you want to, you don't really need to use, really need to create a list in order to be able to perform this. You can simply just do open quote, comma, close quote, and then right here, dot join, open and close normal brackets, open and close square brackets, and here you can specify the actual names instead of actually specifying the list itself. So that is another way that you can do this. And you can see it will print out the same thing. You don't really need a variable that will contain a list. So the actual thing that is between these quotes right here is what will be placed in between each element of this list. As we can see right here, we didn't have anything, therefore we got a string that is concatenated names. We here specified an empty space, therefore between each element of this list we actually got an empty space right here. Same with the comma, and right here in a different example we also got the same thing. So the reverse function of join would be a split function. Okay, so basically what split function will do is it will make each word in a string an element. As we saw right here, each element was made a string, a word in a string, and right here we'll use a string. Okay, so string to split. So string to split, just didn't want to call it just string, so just make up any name you want, doesn't even matter. String to split will be equal, basically, let's say, the Lord of the Rings. So, Lord of the Rings, this is our string. And then we want to create a list which will contain each word of this string. You can do that by simply specifying string to split equals, or not string to split equals, string to split dot split, open and close brackets without specifying anything in between the brackets, and right here list2 can be equal to this, and then if you just print list2, you can see that the list2 will contain each word as an element in its list. Okay? If you want to split by a certain character or certain specific special character, you can do that. So let's say we have, for example, hello, comma, how, comma, are, comma, you, comma, today. So this is our string, and you want to actually split it by comma and add it to your list. You can just type here split, and then in between the brackets, in between the single quotes, specify the actual comma, and you can see right here we will have a list that will be splitted out by the comma. So that is also something useful you should know. You can also specify, or you can also of course split the string by specifying the letter in the bracket. So you can split by, for example, letter E. Let me just check out right here. Or let's use letter A. So this same string, or let's copy everything. So this same string we want to split by letter A, even though that doesn't really make any sense, but you can do it if you want to. As you can see, what you will receive is hello, how, are you Todd, and then you're missing A. So you're going to split Todd today into two different elements. One of them will be Y and the other one will be Todd. Okay, so that is also something you can do. Basically, now also, I should mention that split is actually mostly used to split by a new line character. So if you have a multi-line string, such as for example something like this, multi_line_string is equal. We will use 3 open and 3 close single quotes, so we already covered that in the previous videos. You should know what this is. Now let's type here hello, comma, do you have any plans for today? Question mark, enter, which is a new line character. I would like to see you. Dot, and then 3 single quotes defining and closing the multi-line string. If we print it out, multi-line string, you can see right here everything is good enough. And in order to split it by a new line character, which is \n, you can just type here multi-line string dot split, and in between the brackets specify \, and then n. And you can see right here, the list that it will return is basically a list that will consist of every line in the actual string itself. So hello is one element, do you have any plans for today is the second element, and I would like to see you is the third and last element. Okay, so that would be basically about it for the split function. Now at the end, let's take a look also at the strip function. It is also mostly used to get rid of empty spaces and new line characters. As you can see right here, if we have a name to be equal to open single quote, and then just basically tab this in and then just press and then just write John, close single quote. You can see that the John actually has the \t once you actually type it right here. And in order to split it from that, or to strip it from that \t, you can simply use name.strip. You don't really need to specify anything in between the brackets, such as, for example, \t. Now you can do that if you want to, but what strip will do by default is it will get rid of every empty spaces in the string itself, as well as the new line characters. As you can see right here, if you have, for example, string 1 equals to open and close single quotes, John \n. If you print string 1, it will also have a new line character. As you can see, we have an empty space right here. That is this new line character that we coded right here. And you want to basically strip it from that new line character. You can simply use string1.strip, or you can use string1.strip from the actual \n, which will retrieve the same value as just simply using the strip function. So that would be basically about it for this tutorial. We took a look at the multiple functions such as starts with, ends with, join, split, and strip. Now those are all the functions that you will actually use in the strings themselves. Now trust me, this is not anything that you will not encounter if you continue coding in Python. So this is an important lecture, and I hope you enjoyed it, and I hope I will see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now, what we are going to do is we're going to take a look at files in Python 3. Now what we did in the previous sections is we saw some of the basics of Python, but we never really interacted with files in Python 3. Now before we even start creating our own files and opening them for reading and writing, let us take a look at a certain library that comes in Python 3 that is going to help us with the navigation through files, directories, and also the creation of files themselves. Also, this library has some of the functions that will help us to check out whether a certain file exists, what's the path of that file, to give us our current working directory, to also change our working directory, and many more. Now, many of you maybe actually know this library. It is the OS library. We used it before. We never really did a detailed look at it, but right now it is the time to do that. So, first of all, before we even do that, it is important to first understand what a file is. Now, file, as we can see right here, if I just open up my notepad, and type something right here, for example, hello there. And I go onto the file right here, save as, and save on my desktop right here. Save it as, for example, file.txt. Press here enter, close this. Right here we will have a .txt file on my desktop. Now there are two parts of this file. First one is its path, and the second one is its name. If we wanted to, for example, check the path of this file where it is currently stored, which is on our desktop, we can go right click on properties, and then right here under the location you can see the full location of this actual file. So it is in the users, this user, and then /desktop, as we can see right here. That is the location or the path of the file. The name of the file itself is file.txt. That is what we gave it when we actually saved the file. So basically, to sum up, name is what you see for a file, and its path is, for example, drive C desktop file 1. Okay? So right now that we know that, even though most of you actually already knew that, we can open up our idle right here, and we will import our OS library in order to check out our current path in the idle itself. So open up this, let us enlarge it, type here import OS. We imported it successfully. As you remember, the import command will import the library that is in the Python 3, and therefore right now we can use all of the functions that the OS library has in its code. The first function we will use is a function that will give us the current path, or as it says, working directory, and the function is called get current working directory, or shortly just type here os.get cwd, open and close brackets, as this is a function, and you can see right here what the current directory for our Python 3 is. So it is users, this user, app data, local programs, Python, and then Python 37. In order to check that, if it is in the same directory as it is in my PC, first of all, the app data folder is a hidden folder, so you can actually access it via command prompt. So just open up your search bar down here, type there cmd, click on the first thing, which will most likely be the command prompt, and then once you navigate to the actual user, as you can see right here, or wherever this path opens, just type here cd app data, or you can just type here ap and then tab it, and you will and the command prompt will automatically go to the app data. There you can type dir, and it will have 3 directories. As we can see, our directory of our Python 3 is in the local directory, so this is the first one. You can change with the command cd, so cd local. There, if you type dir, you will have multiple packages or Python programs, or basically Python libraries, and bunch of other programs as well. As you can see right here, SolidWorks, Sony, Steam, temp directory, programs. And there we should find, under the programs, we should find Python 3. So cd programs, and then there once again, you can see there is Python. We change it to the Python, type there once again, and basically just to remind you, dir command basically lists all the files and directories in the current directory. Therefore we use it to list all the files that are in this path right here. And there, in the actual cd Python 37, we have our python.exe and all the scripts that come with it. So basically that is what a path is. This is the place where our Python 3 is stored, and this function that we saw right here will actually get us the current working directory of our Python 3. So this is also another way to check out where your Python 3 is stored. Once you open up your idle, it will automatically open up python.exe from the Python folder, and when you import the OS and get current working directory, it will be right here. Now, the reason why I am showing you all of this is because we don't really want to create files and navigate through the system in this directory right here. This directory is specifically made for the Python 3 scripts, programs, and necessary requirements and libraries that it needs in order to run, such as this Python 3 DLL, Python 37 DLL, remove.py, and many more. we don't want to create our normal txt files like this one. Let me just find it. In that directory, we simply just want to create it right here, for example, at our desktop. So in order to actually go from our idle to the actual desktop, we need to change our directory. Then in order to do that, we will do it with the help of the OS library. That's why I showed you all of this. So the actual function that will allow us to do that will be the change directory function, or shortly chdir. So if you just notice right here, the OS get current working directory printed out this path. But let's say we, for example, don't want to go here. We want to go to the desktop. So we just type here os.chdir, open and close brackets, and you will notice if you just leave it like that, it will say missing required argument, which is the path. Of course, in order to change directory, you need to specify to which directory you want to change. And in our case, we will change to the desktop directory. So os.chdir, and in between the actual brackets you can specify to open single quotes, and in between those single quotes just paste the actual path. And right here I will just paste the first part of this path, place it right here, add 2 backslashes. Let me just switch up my keyboard so I can find the backslash easier, or never mind, it actually already has it right here. And we can just type here desktop. Press here enter, and you will see there is not any error that popped out during this. If we perform the same function right here, you will see that right now, so os.get current working directory, you will see that right now our path has changed, which is a good thing. So right now we are in our desktop environment, and everything we create will actually be created right here instead of this path right here, which is a Python 3 directory. Okay, so we no longer need this for now. We can close it. The next thing I want to show you is that you can actually create a file and directory in Python 3. Now, basically a file and the directory are two separate things. Creating files we'll take a look at later on, but for now on, to create a directory, you can simply use the OS library, again, with a certain function which is called makeDirs. So you need to specify once again the same argument which is specified in the chdir, which is the path. So just type here os.makeDirs. Or let me just check right here. Maybe it is makedir. We'll just take a look at both of these functions. You can paste this path right here, which is our current path. Or you can simply just type here the actual folder name, which let's say we call it folder 1. Press here enter. Okay, so it doesn't have the actual function makedir, so it's probably makeDirs. Let me just check it out once again. So os.makeDirs folder 1. It worked. We can see folder 1 was created without any error. Now let's see if it is on our desktop. And we saw that we actually successfully created a folder on our desktop environment. Now, if you didn't change the actual path before, this folder 1 would be created in the Python 3 directory, which we don't really want. You wouldn't be able to find it, first of all, especially if you didn't know about the app data directory and it being a hidden directory. You would actually struggle to find this file that you created, or pardon me, this folder. Now, let us delete this folder. We don't really need it right now. What I want to show you is the next thing is that you can actually create the folders in different directories outside of your current directory. So currently we are in this directory, but you don't really need to create a folder there. You can create from this directory to a whole different directory. So right now, let us just create simply another folder 1. We'll call it folder in our directory. Okay, it is on our desktop right here. And now, without changing our directory, let's try to create another folder in this directory right here. So just go right here, os.makeDirs. And there are two different things you can specify right here. Either the full path using this part as well, which we will use. Now this is a good practice to add the actual full path instead of just adding a folder in our desktop directory, then 2 backslashes, and then some directory name that you want to specify. So let me just show you right here. We need to add two backslashes, even though we can add it just like this. We want to go to the folder in our directory, and there in that folder, from the desktop environment, we want to create folder outside of our directory. Now, not really, these are not really original names, but doesn't even matter. It matters that we can actually create folder in different directories as well. If we go right now in the folder in our directory right here, you can see that in that folder, even though this is outside of our environment, we were able to create folder outside of our directory. So this os.makeDirs function actually works both ways, whether you are creating a folder in your current environment or not. Okay? So there are also some other functions to take a note of that will help you navigate through your system, or should I say something similar to the command prompt once you change directory, once you actually list all the files, and so on and so on. First of all, let us take a look at a function that will retrieve the path or the absolute path of the argument. Now the argument is, we already know, something that you specify between the brackets in a function. So let's say something like this, os.path. And to check for the absolute path, you can just use, as you can see right here, our idle prompts it right away. So use appspath. And in between the brackets, you need to specify the actual path to a certain directory. So we can use this one right here. So we don't type it twice, just paste it between. And you can see that it actually prints it out back to us. It will, as it says, the function will retrieve the path of absolute path of the argument. Okay? If you simply just try to use something like this, os.path.appspath, and instead of specifying the entire path, you specify only the folder name, which is folder in our directory, it will retrieve the same thing, which is the full path to this directory, which can be useful if you are on a different PC and you don't really know the user name. As you can see right here, this can be different for everyone, this name right here. Whoops, update failed. Okay, doesn't even matter. We are not connected to the internet, so that's why it doesn't work. But let's get back to our Python 3 programming. Now, what I said is that this can be different for every person using Windows 10. This is basically your user account on Windows 10 machine. And in order to check out the full path of a certain folder, you can simply use this function right here to do that. Okay? And in order to check, for example, a really similar function to this, but in order to check, for example, if a certain path is the absolute path or the full length path, you can use isAbs function that is also part of the OS library. It will retrieve a Boolean value of true or false, depending of the argument you specify in between the brackets, which in our case will be simply the full path or the only directory name. So let us use it right here, os.path.isAbs, and in between the brackets, first of all, let's specify something that we know that is an absolute path. So copy this in between the brackets, add the double or single quotes, paste this right here. Oops, not there. We need to paste it in between brackets right here. Let me just, okay, I managed to actually paste it at the right spot. Press here enter, and you can see that retrieves an actual value of true, which means that this is an actual full path or full length path or absolute path, however you want to call it, and therefore we now know that this is the full path to this directory. In order to get a false value, you simply need to specify some directory name in your environment, which in our case can be folder in our directory. Press here enter, and you can see we retrieve a value of false. Therefore, we now know that this is not an absolute path to this folder. Okay, so those are two useful functions that you might need sometime. The next thing we need to cover is to check the file name and the base or directory path for that file, basically using the base name or dir name functions. So let's go back to our file that we created at the beginning of the video, which is our file.txt. Let me just check something out right here. Okay, never mind. Which is our file.txt. So let's get back to our file.txt. This is a file that basically inside it we have hello there written out, which is not really that important to us at the moment. But this file, we're going to use this file as an example to use the function's base name or dir name to retrieve the actual file name and the actual path with those different functions. So let us go to our idle. And let's say we create a variable called file_path. Whoops, we need to actually define this. So file_path equals, and in between, let's say double quotes, we will specify the full path to the hello.txt, which is under C. Then we need to use 2 backslashes, users, 2 backslashes, the name of the current account on the desktop, 2 backslashes, then the desktop environment, which is where our file is, and at the end we specify the actual file name, which is file.txt, which sometimes the actual Python idle will even prompt it for you, as we can see right here, file.txt. Okay, this is our actual variable containing the path, and right now let's use these two different functions. So os.path.basename, and in between the brackets we specify our path, which is stored in our file_path variable. And as I said, this function will retrieve the name of the file itself. If you use it right here, you will get only file.txt. So what this function basically does is it takes the full path or the absolute path, and it will strip out the last string or the part of this variable right here after the double slashes, because this will mean that this is the actual name of the file itself. In order to retrieve the first part right here, you can use os.path.dirname, which stands for basically directory name. And in between the brackets, you specify file_path. And you can see it will retrieve the path to this file. So those are also some of the functions, not really that useful to us, as we can actually code our own functions that do something similar to this. But if you need it, you know that you have it in the OS library. Okay? Now, instead of these two functions, you can also use os.path.split to split them by directory path and file name. So you can see right here, if you just type here os.path and then .split, and in between the brackets, you specify the path to the file, which we will use the same one right here. So file path. You press it right there, and you can see it will create a tuple that will be consisted of 2 elements, which will be splitted out in the directory path and in the actual file name itself. Now, in order to basically store it into different variables, I believe we can do something like this. So directory, comma, file name will be equal to os.path.split. And there we specify file_path. And then if you just type here print something like this, so the path to the file, and then we add file name plus is at this path, and then we plus directory. And you can see right here, the path to the file.txt is at this path, C, users, this name, and then the desktop environment. So this is also something useful, and if you want to just simply split it and store it into different variables, you can do that by using this line right here. Okay, and also, something that you might need is maybe you want to get the file size or certain specific file, for example, .exe, .mp3, doesn't even matter, any file size. You can do that as well with the Python 3 OS library. So the function that we will check out right now is the getSize function. It will retrieve the size of the file in bytes. So right here, if you just simply type, whoops, let me just go down here. If you just simply type os.path.getSize, and in between the brackets, you simply specify once again the file path, you will get that the actual size of the file is 11 bytes, which is actually normal, because if we open this file right here, we can see it has 2 strings. One string will be 5 bytes, the empty space is 1 byte, and the next string is also 5 bytes, and that combined equals to 11 bytes. So our actual Python 3 idle gives us the exact same number, so it means that it is correct. This is also another function you can use. you can do something like this as well. So for example, for file, let me just think about this. Let me just find where we did that function. Where is it? Where is it? Their name, it's not that one. So for file, okay, we'll take a look at this function once we actually start opening files. For now on, maybe it will get a little bit confusing, so we will leave it for later. And for the end of this video, let us also take a look at different functions in the OS library that you might need. So also some of them are to check whether a certain file exists, or if it is a directory or a file. Now, those actual functions are called exist and isDir or isFile. So first of all, let's take a look at the exist function. Basically, what that function does is, as it says, it will check whether a certain file or directory exists. So right here, we know that we are in our desktop environment, which we can check with simply using a function that we already did before, which is get current working directory. And right now, in order to check what files we have in this current working directory, we can use also OS library and use a system function. And what system function allows us to do is to specify any system command in between the brackets. We know that once we used our command prompt right here, so let me just show you once again. We changed to the desktop directory using cd command. And once we change the desktop directory, in order to list all of the files, we just simply type dir. And you can see it will list all of the files. So by simply specifying dir in between the brackets, oops, let me just check it out right here. Yeah, it will execute it in an actual command prompt, but though it will not print it right here, which we will use another actual library to do that. So import subprocess. We imported subprocess in order to use subprocess underscore check output. Let me just remember whether that actual function exists. So subprocess check. Yeah, I'm not really sure if it is called check output. Let me just check it out real quick on my laptop. Basically, what this function check output allows us to do is to check the output of the system command, which in our command prompt, the output of dir command is simply just the file names themselves. So subprocess dot underscore check output. Yeah, it was dot and then check output. So okay, so subprocess and then dot check underscore output. Yeah, okay, so this function actually exists. So subprocess dot check underscore output, and then in between the brackets simply specify the command, which will be in our case dir, and then comma shell equals true, which basically means it will execute it in a shell. And therefore, even though it is not really that pretty output, we get all of the files that are in our current working directory. As you can see right here, let us try to find the file.txt. Here is our folder in our directory, and here is our file.txt, as well as the size of that file, which equals to 11 bytes. Okay, so that is also something you can do. The OS function that I showed you before, which is the system function, basically does the same thing, just it will not really output it to our screen, therefore it is currently useless for us. But what I wanted to show you is the exist function. So os.path.exists, and in between the brackets simply specify the file that you want to check whether it exists. Now you may want to perform this function once you create a file in Python and you want to just make sure that you successfully created it. You can do that by simply specifying the exist function and checking out whether that file exists. So let's just copy the name of this, paste it right here. Oops, once again I put it at the wrong spot, so I will just copy all of this so I don't type it once again. I will delete this actual single quote and paste it at the beginning. And you can see it will return a true boolean value for this folder because we know that it actually exists. If you simply just specify os.path.exists and in between the brackets specify file that doesn't exist, you will get a false value, of course. Okay, so that is also something useful. And the last two functions that we are going to take a look at in this video are going to be the isDir and isFile function. So first of all, we created in this video two different types. One of them was a file, which we can see right here, even though we created it manually using Notepad. And in the next video, we will see how we can actually create it in Python 3. But for now on, we only saw how we can create directories in Python 3 using the OS library. Right now, we can use the two functions isDir and isFile in order to perform the check which one of these is an actual file and which one of these is an actual directory. So let us open up our idle once again right here and use an actual function, so os.path and then .isDir, and in between the brackets we will specify, let me just find it, this path right here. Whoops. So the path to our desktop environment or to the environment where you actually created these files. I always mistake these actual single quotes at the wrong place, but it doesn't even matter. So isDir, and then we will just type here file.txt. And you can see we get the value of false because file.txt is a file and not a directory. If you simply use this actual same function and specify the folder name, you will see that it will actually return a value of true. So what is the name of our directory? Let me just find it. So folder in our directory. You can see it is a value of true. Same with the isFile function. So os.path.isFile. And let's specify the same path right here, which will retrieve a false value. You can see right here, false value, and os.path.isFile of this path right here. I'll just copy it like this. Oops, I also mistyped it once again. So os.path.isFile. Let's delete the folder name and type the actual name of the file, and we will retrieve a true Boolean value. So basically these are all of the functions that we're going to take a look at this long video. We actually took a look at quite a lot of functions that are going to be useful to you once you actually navigate through the system, navigate through different directories, check for certain directories, check for certain files, and once you basically interact with the system itself. Okay? So basically that will be about it for this video. What we're going to do in the next video is we're going to take a look at the creation of files, writing to files, reading to files, and of course closing and opening files themselves. Whether those are the files that we actually want to create right now or the files that already exist on the system, we're going to take a look at both ways in the next video. So hope you enjoyed this tutorial and I hope I see you in the next one. Bye! Hello everybody and welcome back to our second tutorial of introducing ourselves with the files. Right now we are going to take a look at actually creating, opening, closing, reading and writing to files in Python 3. What we did in the previous video is we took a look at some of the directory creation, changing directory, getting current working directory, checking whether a file exists, whether a certain path exists. We also learned how we can actually split a path to a file into the directory path itself and to the file name itself. We also saw some of the functions that are going to check for the absolute path, also to check whether a certain directory or file exists. And right now, we're going to devote this entire actual lesson to the file creation. So right here, open up your idle right away. So idle, and we learned in the previous video that we can actually change our working directory. So let us import OS right away and let us change our directory with the chdir function to the desktop directory, because there is where we actually want to create our files and navigate through them. Okay, so let us change it right away. Now I won't really explain what I'm doing. We took a look at this in the previous video. So users, desktop, and then press here enter in order to check if we actually got to the right directory. You can just use get current working directory, and you can see we are in the good directory. Okay, so our preparation is over. We changed our directory successfully, and let us take a look at how we can simply open a file or create a file. So in Python 3, that is a rather simple task. You can simply use a function that is called open to open a certain file. So right here, if you just go right here, and let's call it file equals open. Yeah, of course, we need to specify the actual name of the file. So file equals open, and then in between the brackets, you can either specify 1 or 2 arguments depending of what kind of opening you're doing. For the first time, we're simply just going to specify the name of the file, which is going to be our Python file.txt. No such file or directory. Yeah, this is a file that actually doesn't exist, therefore we can't really open it like this. Let us first of all create it. So go to our notepad. So first of all, we're going to take a look at actually creating a file that does exist on our desktop environment, and then we're going to take a look at actually creating a file that doesn't exist. So let's call it or let's simply just call it file.txt. Doesn't even matter. Same as in the previous video. And right here, let us open it right here. So file equals open file.txt. And you can see right now it works without any error. Of course, this file name right here can be anything you want. It doesn't have to be file. It can be named anything you simply want. And right now we have the actual file open. So you can create a file with open function, as I said, or you can also open existing file. But the difference is because if you actually try to create a file, you need to specify a second argument in the open function. The opening of the already existing file is simply just specifying the file name itself. Or you can actually open the existing file also by specifying 2 arguments. And right now we're going to take a look at the second argument, which can be changeable, and we will see how we can actually change it. The first argument will always be the actual file name. So first of all, before we actually open it once again, let us close it first. And let us open it with a different name. So fn equals open. And right now we're going to specify 2 arguments. First one will be the same one, which is file.txt. Then comma, and then open single quotes right here. And in the second argument, there is going to be a certain letter pasted right here. So there are 3 different letters that we can paste right here. The W, the A, and the R. Each of these has a different function. The W is opening file for writing, the A is opening file for appending, which I will explain in just a second, and the R is opening file for reading. So first of all, we will start off by opening file for reading. So we need to specify simply just R right here, press here enter, and right now we open the file for reading. What that means is basically that we open an already existing file only to read the contents from the file. We can't really write to that file with this specific line right here. We can only read what is in that certain file. So in order to read the contents of the file, which we can check right here, it says hello there, nothing really too important. In order to read that in our Python 3 idle using Python, we can use the function read. So just type here fn.read, open and close brackets, and it will simply print you to the screen hello there. Okay. Now, if you, for example, try to write to that certain file, it will not work. So if you just type here fn.write, which is a function that allows us to actually write to this file, and in between the brackets, you can specify hello world instead of hello there. It will say unsupported operation, not writable, because we actually opened the file for reading. Therefore, it will not allow us to write to that file. Now, let us see what happens once we actually open a file for reading. But before we actually open it, for writing. But before we actually open it for writing, let us close it first of all. So fn.close is a function that will allow us to close a file. So fn.close. And let us open it once again. fn.open. And right now we will specify the file name. And we will specify W for writing. There's no, yeah, okay, yeah, we need to actually type here equal and not dot open, so file.txt and W for writings, okay? And right now, if you perform the same function before, fn.read, it will say unsupported operation, not readable. So right now, since we opened it for writing, we can't read from the file. But if we want to write to it, for example, let's say our string will be equal to hello world, and we want to write this string to a file, we can see right here, fn.write, and in between the brackets we specify in string, it will work. It will print you out the amount of bytes that you have written to the file, which is 11, the same amount that it actually already had. And if we open up our file once again right here, oops, yeah, we actually need to close it first. Let me just go right here, fn.write string, fn.close. And right now, if I open the file once again, right now there will be hello world written right here. Now it wasn't written before because the file was actually already opened in the Python 3. And right now you can see hello world is written. But what you might have noticed right here is that we no longer have hello there written to this file. So it basically this string that we inputted in this file with our Python has overwritten the previous string that was already in the file. Okay? So that can present us a problem. For example, if you don't really want to delete what is already in the file itself, basically you might simply want to add something. Well, in that case, there comes the A option in the opening of file, which will allow us to actually append to that string that is already in the file itself. So we close the file right here, and in order to open it once again, we can simply just type here open, specify the file name, which is file.txt, then add comma, and specify A as an option. Now we open the file for the appending, which means we can append certain different strings to the end of the file. So right here, if you just type here fn.write once again, and in between the brackets we can specify hello world. How is your day today? Whoops. Paste it right here, it will tell you that it has written 24 bytes. In order to actually check the file content, we need to close this file in the Python, so we can open it in our notepad right here. Go right here, and you will see hello world, how is your day today? So we basically appended this string to the already existing string in that file. Okay? Okay, so basically there are also other functions that might be useful to you once you actually open the file, and let's take a look at them as well right now. So you can use a special usage of the R function, for example, which stands for reading. You can simply just specify with the T and B next to this R letter, you can specify whether you want to read text or you want to read bytes. So right here, let me just reopen this idle so we can have a more clean screen. Oops, not this. I want to open up my idle. And simply right here, let me just real quick change my directory. Okay, C. Okay, and right here, let us open up our file once again, but in this case, let us open it for the actual reading of text, because our file is a txt. Now, if you just type here the name, and right here, in order to specify that you want to read text, you just simply type R for reading and then T for text. And then if you just try to read from that file, you can see it will say, hello world, how is your day today? In a string format. But right now, if we close the file once again, and reopen it with a different option, so fn equals open, and then here we specify file.txt, and instead of rt we specify rb, and we try to read from that file once again, you can see that it will print the same string. Just before that string it will add this small b option right here, or b letter, which stands for basically bytes. Okay, so it is two different things. Now this is not really useful right now, but it can be useful if you try to transfer something over network or something like that. you might actually struggle to do that. So therefore this option exists there as well. So that is also something you can do. The next thing that I want to show you is that there is a function called readLine or readLines. Now what readLines function allows us to do is basically if you have a file that has multiple lines, which I'll show you right here, if you simply just close this file, go to that same file in the notepad and write right here. So let's write some names, for example, Adam, John, Jane, Jack. So we have multiple lines in our actual file. We close it right here. Let us open it right here. So fn equals open file. Or let's just simply add the file name so we don't really always type the string of that file. So file name will be equal to file.txt and then fn equals open file underscore name and then for actual reading right here. And you can simply just use readLines function, which will read line by line and store it in a, for example, different string, however you want to. You can simply navigate in a for loop through each line. So for example, for line, which is our counter, basically not counter, it is going to be each line for each iteration. So for line, in fn.readLines, specify 2 dots right here, we can simply just print the line. And this will basically print each line from this function right here, as you can see. It also adds the actual new line string right here, as we can see. Well, we can't really see it right here, but by seeing this empty space after each line, we know that all of these words actually have a new line character attached to them. So in order to get rid of that as well, you can simply just use for line in fn.readLines dot, for example, strip print line. Yeah, not like that. Yeah, we can't really do it like that. We can do it like this. So for line in fn.readLines and here print line.strip. Oops. Why doesn't it print out anything? Let me just check it out real quick. fn.read. For some reason, we no longer have anything in our file. Let me just close it real quick and write it back to our... Yeah, it is probably because, as it says right here, list object has no attribute strip. It may be caused some problem. If I open this, you will see that no longer... or there actually is these strings right here, so let us resave them. Close this, open up our idle. Let's open up our file once again and try it once again. So fn.open file underscore name for reading. And for line in fn.readLines, line equals line.strip from the new line character. So \n print line. And you can see it works right here. So we got printed out each line without the new line character. So this is some actual modification that you can perform to your file if you want to. So that is also some function that you have in the files. And what we're going to do in the next video is we're going to take a look at some of the program examples of using files. So hope you enjoyed this tutorial and I hope I see you in the next one. Bye! Hello everybody and welcome back to this tutorial, and right now let us take a look at some of the coding examples of using files. Now these are of course going to be some of the simple examples only directed to the file creation, file copying, directory changing and so on and so on. And right now, first of all, let us open up our idle as usual. This time what we're going to do is we're going to navigate through the file right here and pick new file here. And we're right away going to import a certain library, and you already know what that library is. It is going to be import OS library, which is going to help us navigate through our directories. And right here, first of all, by default, we will go to the directory that the actual user specifies. So first of all, we will create a directory variable which will be equal to the input, and to the user what we will do is we will actually prompt the user to enter the directory. Now for each user that don't really know Python, we will specify in between the brackets that they need to add double slash or double backslash in order to separate the directory. So use double backslash to separate directories, because we already know that the actual directories are all separated by these two backslashes. Therefore we will prompt that to the user. Okay, so right here we prompted the user for the actual directory, which then we will change to that directory. So OS, but let me just first of all, just in case, we will strip this directory from the actual new line character if it is specified. So directory strip, and in between the single quotes what we will do is we will strip from the \n, which is a new line character. Then we're going to os.change directory to the specified directory from the user. Once we do that, we're going to prompt the user for the file name, which we are then going to create. So a file that is non-existent right here. As we can see, we are currently on our desktop. There is not any file right here except for these random files here. And we're going to prompt the user, so file name, so file underscore name is going to be equal to input, enter the name of the file that you want to create. Okay, so right here the user will specify the file name, and then once the user specifies the file name, we're going to write our own string to it. Or we can even actually prompt the user for that one as well if we want to, but for now on, let us just type something like this. So content of file is going to be equal to, and here we can specify, for example, a multi-line string if we want to, or we can simply just do something like this. Hello, and then the new line character, which means that it is basically going to go to the next line in the file itself. So hello, how was your day? Now I'm really not that quite original with these sentences, but doesn't even matter. As long as you understand it, that matters the best. And then \n. And then my day was great. And let's just leave it like that. We can just type here exclamation mark, close the single quotes, and that is our content of the file. So we will have 3 lines. Each of those 3 lines will have a certain specific sentence to it. And right now, we're going to write this content of a file to the specified file name by the user. Okay, so file name. We first of all need to open the file name. So fn is going to be our file descriptor. So file name equals open, which is the function that we took a look at in the previous video. It will open up a file under the name of the first argument, which we will specify to be file underscore name. And then we will open it for writing, and we will write text. Now, the reason why we are doing this is because we have something that we want to write to that specific file. And therefore, we are, of course, going to open it for writing instead of reading. So right here, we open it for writing, and then we will write fn.write content of file. And if everything works well right here, we should have a file called anything we specify in the program itself, and then it should have 3 lines of text in it. So let us see if we run this. First of all, let's save it. Save it in the actual Python programs file text. Let's call it simply like that. So file text.py. And let's run it right now. Run module. Enter directory. So it says use. Okay, so we needed to specify actually 3 backslashes. Let us just close it right away. Yeah, we want to close it. And here let us specify 3 backslashes. Not really sure if this will work. It probably will work. Save. Run module. Yeah, okay, so in order to actually print to the user 2 backslashes, you need to specify 3 backslashes, so remember that. So it prompts us enter directory, so we want to change directory to the C, 2 backslashes, users, and then to the desktop. So this is our directory. It performed this part right here. It also performed this function right here. And right now we are stuck at this line waiting for the file name. Let's call it python3.txt. Well, let's call it simply just 3 lines of text.txt. Right here, we don't get any error, therefore we assume that this actual content was written to a file. Okay, so right now, if we go right here, we have a file, the 3 lines of text. If we open it, for some reason there is nothing written to it, and I actually think I know why. So let us go back to our code. Let's first of all delete this file. Yeah, this action can't be completed because the file is open in Python. Therefore, we actually need to close it. Let me just see if we can do something like this. fn.close. And right here, once we closed it, we actually get our strings right here. So right now, let's fix the actual error, which was not being able to open the file, and we can fix it by simply adding fn.close into our code. Save it, run it once again. Let's just copy this same directory. Let's call it simply text.txt. And if we close this, we have text.txt that we can open right away. So this does work. Right now, let us actually code a program that will, for each line, change a line to a different line. So for example, if we read first line, we will change it to the reverse sentence, and then we will write it back to the actual file. So let us see how that will work. That is a good practice. So let us go right here. What we are going to do is we are simply going to close this program. We don't really need this one. We are going to create a new one. So go File, New File, and let's actually first of all think about what we want to do. So what we want to do, wait, I don't need this window, I need this one. What we want to do is we want to open this file for reading right now. Then what we want to do is we want to read each line by line. Then we want to actually reverse every line, and then we want to write it to that file. Okay, so let us see how that will work. It can be actually a little bit complicated, but we're going to take a look at it right now. I don't have it coded right here, so we're going to see how it will work. So import OS. Then we want to change our directory to the desktop directory. We will do it without prompting the user for the directory. So C, 2 backslashes, users. Okay, so we change our directory, and then we open the file for reading. Let us just type here file_path, or file name, pardon me, equals text.txt. We need to use the same name of the already existent file, and right here we will open file_name for reading. And now for each line in fn.readLines, we're going to perform the same thing as in the previous video. Line is going to be equal to line.strip from the actual new line character. Okay. And right now what we're going to do is, first of all, let us close the file, open it for reading, for writing. So file name, name for writing, and then fn.write. Let me just see it right here. fn.write. And then we want to write basically, yeah, we actually need to first of all reverse the sentence right here. And we can do that by simply specifying a line equals line. And then to reverse a sentence, I believe we already saw it in the previous videos. In order to reverse it, we can simply use two dots specified 2 times and then -1. Now this will reverse a string. Then we will write that actual line to the file. We will close it once again and we will reopen it for writing once again. For reading once again. So let me just take a look at this. So if we open the file, and at the end, of course, after we finish it, we need to close it once again. So we open a file, text.txt. We open it for reading, and then we read for each line in fn.readlines. Line is going to be equal to line.strip from the new line character. Then we actually reverse the line sentence, and then we close the file, open it for writing, write the line, close it once again, open it for reading, and then it should go right here. Okay. Let me right now save this. Now there is a good possibility that this really won't work, but let's give it a try. So reverse.py, run it right here. The file name, director name, or volume syntax is incorrect. So let us take a look at what is incorrect right here. Okay, we are missing an actual single backslash. Let us save it once again. Run it. Oops, we actually had to probably close it from here. So let us run it once again. Okay, it doesn't prompt anything to the screen. But if we open a file, for some reason we only have one sentence, and we're going to take a look at why is that. So in order to actually check out what the error was, we can simply just print the line. So we actually have something printed to the screen. And let us just try to run it once again to see what it will print. Okay, so my day was great. Well, it's good that it printed that out, but where are the first 2 lines? Let me just go right here. Oh, for some reason it actually right now did reverse it. Which is weird. Why didn't it reverse it before? But okay, we successfully did reverse the sentence and written it to the actual file. Let me just check out what happens if the actual file has multiple lines. Hello there world. These are 3 actual strings we're going to have. Let's save this, run it. It prints out all these 3 strings in reverse. It closes the program, we open the program, and for some reason we only have 1 string written to it. Okay, so for line, in read lines, we strip it, so that is the first word, which was hello. It printed the line. Oh yeah, I think I know what the problem is. I even told you that in the previous video. We can't really use W, we need to use append. Because append will actually write the line without deleting the previous one. Because we actually used write right here instead of actually appending, it deleted and overwritten any previous line in the actual file. So right here we want to type append. Let's save it. And right now we need to first of all add these 3 words once again. So hello there world. Save it. Run it once again. It prints them in reverse to the screen. Hello there world. Yeah, okay. Well, basically it will, yeah, we need to add the new line characters in order to write them. Hello there world. It did actually reverse them right here. Just it actually added it to the last word, and we want to have it one beneath another. So in order to do that, we can simply just type here line equals line plus the string of the new line character. Okay. Save it right here. Run it once again. World there, hello world. Yeah, okay, we actually need to rewrite all of this stuff. So hello there world. Save. We just take a look at this once again before actually running it. It reverses it, it opens for appending, it writes the line, which should have the, let me just check out, not the, yeah, the backslash. Okay, so if I save it and run it, open the file. Okay, so it is better right now, but we also have the first word that is written. It is written and attached to the previous word. And we can simply just fix that by having something like this. So hello there, world. And then pressing enter and then saving the file. By pressing enter, we actually added a new line character to this world string right here. And right now, once we finally actually run this once again, save it and run it, it reverses the strings, and if we open the file, we have these three normal strings and then those same strings reversed. So we successfully coded a program that will do that, even though this probably could have been done a little bit easier, but it doesn't even matter. It was just on top of my head. You can simply perform any other tasks you want with the files themselves, write to them, read from them, and so on and so on. So basically that would be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and in this section right here we are going to take a look at the errors in Python 3. Now what I mean by errors is sometimes some error will occur in your code without you actually being able to know that in advance. Therefore, the last thing you actually want is your code to actually crash or your program to crash just because of that simple error. Therefore, we're going to learn right now how we can deal with errors, how we can actually assume some errors coming, and how we can use different syntax in Python 3 programs in order to actually avoid those errors and avoid our program crashing once some error occurs. So, for example, the most common error that you might have all known is the zero division error. What that error actually is, for example, we know that we can't really divide any number with a zero. Therefore, what happens if you actually try to divide a number with a zero in Python 3? Well, an error will occur. So let us open up your idle just to show you. So idle right here. And let's say we have a to be equals to 3. B equals to 0, and then you simply just type here a divided by b. You will have a traceback call to our third line, which will say 0 division error division by 0. Now this will crash your program and it will not continue to execute if you have some other code after it. It will crash it and the program will no longer run. So right now let us see how we can actually deal with this. Now this is one of the errors. There are many other errors that can actually occur. For example, there is also an overflow error. It is raised when a calculation exceeds maximum limit for a numeric type. There is also an attribute error which can be raised in case of failure of the assert statement. So, first of all, what is an exception? Well, an exception is an event which occurs during the execution of a program that will disrupt the normal flow of program's instructions. So for example, let's say we have a program that performs this task right here, but the only exception for this task right here would be if b equals to 0. And in case b equals to 0, we want to perform a different part of a program rather than letting our program simply crash. So that is an exception. Now, in order to use the exceptions, we need to implement in our code the try and except rule. Now the try and except rule looks something like this. So this is the basic concept behind it. You have to specify try, then 2 dots, and once you tab something in, it will tab it by default in Python 3 idle. You do your operation right here. So some task is right here, such as for example this right here. We're going to take a look at a real example just after I specify you just right after I specify to you the actual usage, so some task, and then you have except as a word. So this is also a word in Python 3 that is already used. once again we get the update error. Never mind, let's just close it. So except exception 1, we can use it like this. So this would be exception 1. For example, when b is equal to 0, you just type here, if there is an exception 1, then execute something else, different task. If, for example, b is equal to 0, you can also add multiple exceptions if you want to, but once you actually, but in our case we only have one, and that is that b equals to 0. And basically after it you can simply specify else if you want to, which will basically, if there is no exception, it will execute this block right here. If there is no error, it will execute this. So the example, let's first of all take a look at the example of you dividing by 0, and then let's also take a look at a different error example by using a different error, which is going to be an error while opening and closing files that don't really exist. So first of all, let us write this same code, but right now let's try for our program not to crash. So try, and then a equals 3, b equals 0, and then c equals a divided, oops, where is the, okay, so here it is, print c, and then else, oops, not else, pardon me, we need to specify right here except, and then you need to specify the name of the error, so 0 division error, except 0 division error, print, and then we'll print to the screen, can divide by 0. Okay, press right here, and you can see that this program simply prints out can't divide by 0. Okay, so our program didn't crash. We got a specific string printed out to the screen that will say can't divide by 0. Now, if you actually used same code right here and actually specified something that is not equal to b, that is not equal to 0 right here, it will execute this task and it will print the result. So this is one of the examples of actually dealing with the 0 division error. Now let's take a look at the example of dealing with the IO error, which is raised when an input or output operation fails, or basically such as trying to open a file that doesn't exist with the open function. So in order to check that one out, type here try. What we are going to try to is we're going to have our file descriptor right here. So let's call it fn as usual, equals open. And let's type some random name right here. We know that this file certainly doesn't exist in our directory. We want to open it for writing, okay? And then we want to actually write right here. Or pardon me, this will actually create a file. So let us just do it like this. Open it just like this. So what this will try to do is it will try to open a file that actually already should exist, but in our case it really won't. And then we will try to write to it, this is a test file, which is a string, and then we will accept an error, which is called IO error, which is the input-output error I was talking about, and then we will print, for example, can't open that file, it doesn't exist. Okay? And then we can simply just use the else that I showed you right here. It can be used if you want to. So else is not only used in the if-else statement, it can be used here as well in order to execute a code that will actually be executed whether no error occurs, which in our case will not be executed. So this print statement right here, everything worked well, will not be executed because we will actually run into the error. So press here enter, and you can see the only thing that gets printed out is can't open that file, it doesn't exist. This print statement doesn't get executed, and this file, this write statement or write function doesn't get executed as well because this file doesn't exist. We only run onto this error right here, which says can't open that file, it doesn't exist basically. Now, you might be asking, well, how I can actually know what the name of the error is in my code. Right here we saw that it is a 0 division error. Right here I told you that this is an input-output error, but what, for example, if you don't really know what error you will receive, how you can deal with the errors themselves. Now, you can deal with them by using normal except statement right here without actually specifying any error. For example, you can write this same program right here just without specifying this part. It will actually perform the same task. But this is a bad practice. Well, this kind of try and except statement catches all the exceptions that occurs. But it is not considered good programming because even though it will catch the error and your program will not crash, you will not exactly know what the problem was to your program. So it could be something that you might have missed that is actually important error that you need to fix sooner or later. And with the except statement, you really won't know what the error was. Okay, so let us see, or let us take a look at that one as well. Simply, we can write the same program right here. Let's write it right here. So fn or fd, let's call it like that, equals open non-existent file. Okay, and then, whoops, I'm missing try right here. We try to open this and then we try to actually write to that file some strings. For example, we want to write something like that, and we don't know right now what error we are going to run to, and therefore we are only going to specify except and then afterwards 2 dots, and this is going to be printed out for any error that occurs. So basically, if any error in all of the errors occurs right here, we will print file doesn't exist. But what the danger is because this might not even be the correct actual statement for this error. So it might actually not be the error that the file doesn't exist. It could be something completely different. And for that different thing, we're also going to print file doesn't exist, which might actually not be true. Okay, so that is the problem with the except, even though it will work. And then we can code else print everything worked fine. Now, in order to actually check out whether this else statement works as well, we're going to change our directory to the actual desktop directory, just so we can actually test it with a file that does exist. So os.change directory to my desktop. Okay, so we change the directory, we save this. Let me go to my Python programs, errors.py. Let's run it. And it says file doesn't exist. Okay. Now, let us actually create a non-existent file. Just by going here. Or let's actually create it in our code. We know how to do it right now. So fn open non-existent file, let's call it .txt for writing. And then we write this. Right now, it should work. And not only that should it work, first of all, let me delete the previous file. And not only that it should work, it should also print this statement right here, everything works fine. So let's run it. It says everything worked fine. And if I go to my desktop right here, we should have a non-existent file.txt, which of course will not have anything in it because we didn't really close it. So let's close it right here. Save it once again, run it, everything worked fine, and right now we will have some strings written to a file. And this error will not occur at this specific time. Okay, so basically that would be about it for this introductory video for errors. We're going to take a look at some different examples in the next video, so hope you enjoyed this lecture, and I hope I see you in the next one. Bye! Hello everybody and welcome back to this tutorial, and right now let us continue with our errors and our try and except rule. So what we did in the previous tutorial is I showed you how you can actually use try and except with specifying the actual error to catch an error that will prevent from your program crashing. We also took a look at the later example that you can actually specify only the except, and then you will actually catch any error that might occur in your program. But as I said, that is a bad practice, because then you will not know what the exact problem was, because there are multiple errors that can actually occur for a certain specific task. We also took a look at the else statement, which I showed you that it also can be used in the try and except rule and not only in the if-else statements. And right now what we're going to take a look at is how you can actually deal with multiple errors without specifying only the except. Now, you can actually use a try and except rule with specifying more than just one error. So you can simply just specify something like this. I will simply just show you an example. Let me open up my idle, open the actual new file, and right here, the basic usage or the basic syntax for the usage of multiple errors is something like this. So you just type your try as before. Then right here you will specify your code operation that you want to execute, and in the except, in between the brackets, you can specify multiple errors just by specifying them just like this. So in the open brackets, type here exception 1, open square brackets, comma, exception 2, open square brackets, pardon me, open square brackets, comma, then you can just type here 3 dots, for example, and then as many errors, 3 dots, and then as many errors as you want, so till the error exception n, which is going to be the last error, and of course you will need to close all of these brackets, as well as the ending bracket right here. So there you can, in the brackets right here, define all the errors that you think can occur with the problem that you might have. And then you can print something like this. So if there is any exception from the given exception list, then execute this code right here. So this code right here, execute when error occurs. So simple as that. And of course, if you want to, you can have your else statement, which will execute if there is no exception involved in this program execution. So if there is no error that occurred in the program, run this part. So this is the basic syntax for usage of this kind of exception handling. And right now we're going to take a look at something different, which we didn't really introduce yet. It is called a final block. Now a final block is a part of the code which is a must code to execute. So it will execute whether the try and except rule raised an error or not. The syntax for the actual try and finally statement is this. So just like this, you can simply just type try. Then you can, for example, try to, let's type it in idle. Maybe it is easier for you. So try. And you can just, for example, type here fn equals open, and then you try to open a file, for example, test file. You open it for writing, and then you want to write to that file. So fn.write, you want to write some string. So that string will be, this is my test file. And then instead of specifying except, you can just simply just specify finally. And then you can print right here. So finally, file doesn't exist. Oops, but we actually made a mistake. We need to specify it like this. So try, and then fn equals open, and simply just specifying the name without opening it for writing. And then fn.write. This is my test file. And once you type this right here, then you actually enter the final statement or the finally statement, and you print can't open or find that file. And we will simply just close the file right here. And you can see the actual, let me just find it right here. Yeah, it is because we added it right here. It says can't open or find that file. Then this error right here is prompted because I actually typed this at the wrong spot. I should have typed it in the try statement right here. Then we would not run onto this error. Now basically what this finally statement does is it will execute it either way, But this program, for example, is useful if you do not have permission to open a certain file that you know exists in the writing mode. Then this will produce the following result, which is going to be can't open or find that file. So the same example can be written differently, such as, for example, like this, by specifying the correct error. So go down here and just type here try. And we can use F to define a file descriptor. We can open, let's say, test file for writing. So we open it for writing. Then in the try and except statement, we enter a try and finally statement. So try right after you open it. And if that doesn't work, you will just simply go to the except rule. And in case that does work, you will go to this next try rule, which will be f.write, this is my file. This will be a string that will be written to the file itself. And this try statement will have a finally statement, which will get executed. And it will say something that will be useful in both cases. So for example, going to close this file. So this is something that is going to get printed out to the screen anyway. And then we can actually close the file. And after that, we enter the except, which we are going to take a look at the IO error, which we already covered in the previous video, which is an error that will occur if a file doesn't exist and we try to, for example, open it. So except IO error, we can print that file doesn't exist, exclamation mark. Simply by specifying here enter, you can see it prints out 15, which is going to be the size of the actual bytes that is written to the file. So this produced this number. And then the finally statement will always print this, so going to close this file. We didn't run onto the any error. And right now in that directory, which is going to be our Python directory, we should have the actual test file opened for writing, and then we closed it. So right now let me delete it because I forgot to actually change my directory to the desktop environment. Right now I need to go to the app data, local, programs, Python, and here if I just type dir, I go to Python 37. Let me just find, okay, so here is the test file, let us remove it. Okay, RM is for Linux and del is for Windows. So del test file. And right now our test file is no longer in this directory, which is good. So remember to always change your directory to desktop before actually trying to create some files or read for files, because then you will be stuck if you don't with the files in the Python directory, which you don't really need. So also another thing that we should cover is the exception that can have an argument. Now what I mean by that is basically the argument is a value that gives additional information about the problem itself. So it can be helpful if you're trying to actually debug your code. The contents of the argument vary by the exception itself, of course, so the argument will not be the same for the zero division error and also for the error that will occur when you're trying to open a file that doesn't exist. So, of course, the argument will be different. So right now, let us take a look at that. The basic example would be try, and then we specify the actual operation that we want to execute, and then accept exception type as argument. And then we actually type except and then the exception type as the argument. And then you can print the value of the argument in the except block of the code. So let us see how that will look like. Let's actually create a function that will try to convert different strings to integers. Okay, so that function will be called convert. Okay, so the function convert will take a variable as an input, and what it will try to do with that variable is it will try to return the value of the actual integer. Whoops, not open and close brackets. Right here we need to type here return, then space, and then we will try to return the integer value of the variable. Okay, So this is what is going to be executed in our actual code right here, in our actual try statement. But let's not try to return it, let's actually print it to the screen. So print integer of the variable, open and close two brackets, and then we will just type here accept. Now make sure that you're still in the function, so it has to be indented in the function code, and then accept, and we'll specify value error, which is going to be an actual error that will be retrieved. If you, for example, try to convert a string to an integer, the Python 3 will run into an error. It will tell you can't really convert strings to integers. So accept value error, and we will store it in the argument variable, and then we will print that argument to the screen. So print the argument does not contain numbers, and then we can add the new line character as well as adding the actual argument. Okay, so this is our function. Right now, if you, for example, try to convert, or let's say a equals string from 1 to 3, okay, and you try to convert a, you can see it gets printed to the screen 1 to 3, so our function works. But for example, if we have string equals www, and you try to convert this to an integer, so convert string, you will see that we actually get, let me just find where it is, value error. The argument does not contain numbers. Okay, so here it is. We successfully printed it. I was searching it up here, but it actually went down here. So print the argument. Oh no, never mind. Argument. Wait. Bad operand type for unary plus value error. During of handling of the above exception, another exception occurred. Okay, so we converted it, then we print the argument does not contain numbers. Yeah, probably the problem right here is that it actually needs to be converted to a string in order to be printed out. So we are going to try it right here. So we don't actually type it twice right here. We're going to simply, let me tab everything one step back. And right here, we're going to print the string of the actual argument. Maybe that is the problem. Let's save it. Yeah, before we actually save it, we need to call the convert function of www. Okay, now we can save it. So save it in Python programs, argument error .py. Then we try to run it. Wait, bad operand type for unary. But what if we actually try to print it simply just like this? Save it. Yeah, okay, so here it is. Now, you can't really convert the argument, okay, so I was thinking I thought you actually could, but it doesn't seem that you can actually convert the argument to a certain variable type, such as a string, so you can't really print it like that. You can't concat it to the string right here, though you can print it like this. So we print the argument does not contain numbers, then the new line character, and right below that, it will print out the argument right here. So you can just type here in, so you can just see here that the program outputted invalid literal for integer with base 10. So it gave us an error that we can't really convert a string of 3 letters into an integer, which is actually correct. That is why our program basically crashed. But right here, it didn't crash with an error like this. Right here, it will actually print this to the screen and it will continue executing if there is any other code left. So we can try that one out as well. Right after you type this, you can just print. This part of code comes after the error. So we can see that it actually does execute, or the program execution does continue right after the error. As we can see right here, we run the program once again and it says this part of code comes after the error, so everything works perfectly. So basically that would be about it for this lecture. I hope you enjoyed it and I hope I will see you in the next one. Bye! Hello everybody and welcome back to this tutorial, and right now we're going to enter a section of Python 3 programming that is going to be object-oriented programming. Now, basically, this can be considered a little bit intermediate to advanced part of the Python 3 syntax, or not just some syntax. Basically, this is introducing ourselves to a whole different type of programming in Python 3, such as using classes, using subclasses, introducing to function overloading, data member, class variable, and so on and so on. We're going to take a look at all of that right now. Those are just some basic object-oriented programming terminology that we're also going to cover in this lecture right now. And then you will actually be able to call yourself an actual beginner or to intermediate Python 3 programmer if you know all of this as well as the previous lectures. Then you can actually consider yourself a beginner Python 3 programmer. So, first of all, Python has been an object-oriented programming language since the actual time it existed. If you do not really have any previous experience with object-oriented programming, you may want to actually learn more about it, and then you will be able to understand this on a whole another level, because in the beginning it can actually be a little bit of overwhelming and you might actually consider it a little bit hard, even though it really isn't that hard. Now, Python 3 object-oriented programming is one of the easiest ones, so this is a good way to start learning object-oriented programming, as it will give you an actual beginning knowledge if you actually try to learn a different programming language later on. So let us open up our idle right here. Let's open a new file and basically let us introduce ourselves with some of the basic terminology that you will encounter while learning the object-oriented programming. So the first thing that you will encounter, of course, is going to be a class. Now basically a class is a user-defined prototype for an object that defines a set of attributes that characterize any object of the class. Now, basically that means that the class has data members, variables, and instance variables, and also it can have methods, or if you want to call them, functions. Now, what methods are basically functions that are a part of a certain class. So we already know what functions are. We saw how we can code them before. Now imagine that inside a certain class, you create a function. That function will be actually called a method. Now, the next thing that is going to be in the actual class is going to be a class variable, and that is the variable that is shared by all instances of a class. Now, class variables are defined within a class, but outside of any class methods. Class variables are not used as frequently as instance variables are. Okay? So, basically what you need to remember from all of this is that class variables are going to be most likely coded at the beginning of the class outside of any specific method that is going to perform some part of the code. Okay? Now, as I said before, a method that is a special kind of function that is defined in the class definition itself. An instance is an individual object of a certain class. What that means is basically an object that belongs to a class circle. For example, it is an instance of the class that we will call circle. Now, inheritance is the transfer of the characteristics of a class to other classes that are derived from it. So you can have a class that is going to come from a different or a whole different class that is going to inherit all of its objects. Okay? Data member is, as we said, a class variable or instance variable that holds data associated with a class and its objects, and the object is a unique instance of the data structure that is defined by its class. So those are some of the object-oriented terminology. Now, of course, it might sound a little bit harsh, but it really isn't. You will see it just in a few seconds. So let us start off by showing you how to create a simple class. Okay? So creating classes, we're going to use our, let's just close this right here. Do you want to save? No, I don't want to save anything. let's see how we can actually create a class in Python 3. So the class statement creates a new class definition. So basically just typing here class will create a class that is going to be named as the part that comes after the class definition. So class and then name underscore of underscore class. You can name it just like that, even though that is not really such a good name. You can call it class name, simply as that. And then you specify 2 dots, and all the code that is going to be below it is going to belong to the actual class itself. So the name of the class basically immediately follows the keyword class, followed by a colon as below. So the class has a documentation string which can be accessed via class name .doc or underscore underscore doc underscore underscore, and the class suite consists of all the actual component statements defining class members, data attributes, and functions. So let's take a look at a real example of creating a class so you will understand this a whole better. So first of all, what we're going to do is we're going to create a class which is going to be a class employee. Okay, simply as that. This class is going to be everything defined about our employees in, for example, our already existing company. So right here, we can have a variable that is going to count the amount of employees. So for example, emp count, which stands for employee count, will be set to 0 at the beginning. Oops, I pressed enter too early. So employee emp equals 0. Right here, then we will have an actual init function, and what the init function or method is basically, let me first of all type it right here. So we will define it just like this. So underscore underscore init and then underscore underscore. And this init function or method is a special method which is called class constructor or initialization method that Python calls when you create a new instance of this class. And what this method will take is basically all the variables that are going to be a part of our employees. And you will see just in a second, these actual functions will always take a self argument. And basically, what a self argument is, well, you declare other class methods like normal functions, but with the exception that the first argument right here to each method will be self. Now Python adds the self argument to the list for you, so you do not need to include it when you call the methods, okay? That's why we include the self part right here. And let's say that the actual variables or the actual things that our employees will have is their name, let's say their email address, their salary, and for example, age. Or let's instead of salary use age, okay? Simply as that. These are going to be 3 different values that each employee will have. Then we will define them right here. So of course, right now we will have to define it once again with the self prefix before. So self name equals name. Self email equals email. And then self age equals age. Okay? And as soon as this function right here init is called, or this method right here, we will know that this class has been this class has been actually used on a certain employee, and therefore we can increase the employee count by 1. And in order to increase the employee count, we can simply just type here employee dot and call the actual emp right here, which actually I should have called the emp count, but doesn't matter. We can simply just specify it like here, emp plus equals 1. And we know that this plus equals statement right here basically just increases the variable by 1. Okay, so this is our init function, and this is a function that will always be in a class. So right now, I should have actually, let us actually go right here, since it is a little bit hard to code it in the actual interpreter. So we will just copy it from here, and I will just paste everything we coded to the actual Python program. And right here I will also add emp count, so we don't actually confuse it with an emp. And right here we will add emp count plus equals 1. Okay, so that is our first method to our class. Right now, let us create an actual method that is going to take self argument because it belongs to our class, and it is going to print the total employee number. Okay, so def display count. It takes self as argument, and it will basically just print total employee number is, and then we can add a string of employee, or pardon me, employee.emp count. Okay, so employee.emp count, open and close two brackets right here. And the third function is going to be the function that will actually display the information about a specific employee. So def display information, it will take self as the argument, and right here we will simply just print name will be equal to basically self.name. Then right here we can have email is going to be equal to self.email. And then the last thing is the age. So age is going to be equal to self.age. Let me just enlarge this so we can see the entire code properly. Just like this, okay. Press here enter, and this is basically our entire function. Okay, so simple as that. Now the variable emp count, let us also remind ourselves, is a class variable whose value is shared among all instances of this class right here. So it can be shared between all of these right here. Also, this can be accessed as employee.emp count from inside the class or outside the class, however you want it. Now you can see right here we use employee.emp count. It can be used inside the class, as we saw the example right here. And soon enough we're going to take a look at the example of using it outside the class as well. Let's also remind ourselves that this init method right here is a special method, and it is a constructor initialization method that Python will call once you create the new instance of this class. So as I said before, this will get called every time we actually put a person into this class employee, which shouldn't be employee, it is missing an O. Okay, so class employee. And that's why we actually increase the counter of employees in this class or method right here. Okay. Alright, so right now that we have the actual class, we need to take a look at how we can actually create the instances of a class, or how we can actually add a person to this employee class. So this is rather simple. Now that we have a class right here, in order to add an actual employee, we can simply just type here employee1 is going to be equal, and then in order to add it to the actual class, you simply just type here the class name, and in between the brackets you specify all the needed arguments, and in our case the needed arguments are name, email, and age. So these are the three arguments that we need to specify for every employee that we put in this class. So let us just type here Adam, not this, we need Adam, then comma, then the next thing we specify is the email, so we can just type here adam@gmail.com, and then the last thing will be the age, and let's say the Adam's age is, for example, 15, so it doesn't even matter, that is the age of Adam. And right now we successfully created the instance of this employee class. So you will notice if we just save this, go to my Python programs, employee.py, and if you just simply run it right here, inconsistent use of tabs and spaces in the indentation, okay. Let me just see, what do you mean by that? Maybe this was the problem, not really sure. Let's save it. Nope, it says inconsistent use of tabs, so let's try it right here. Let me just try to actually find where the actual indentation is not specified correctly. This is good, this is good. Okay, maybe now. Let's try to run it once again. Syntax error, inconsistent use of tabs. Where is the actual inconsistent use of tabs? I'm not really quite sure. Maybe right here. Okay, now this is actually presenting us a problem, so what I will do is I will simply just copy this, paste it right here, and we actually get the same error as well here, which is a little bit weird. So let us actually try each line to see whether it is indented properly. This one is, this one is. Okay, I think it is this one. Not really sure why doesn't it want to tab itself. Yeah, okay, so I will just code it real quick right in the idle, because for some reason this is presenting us a problem. So let's just code it real quick right here. Not really sure where the actual error is, but doesn't even matter. Class employee, I will just retype it all real quick. emp count equals 0, def underscore init underscore takes 4 arguments, self argument, name argument, email, and the age argument, okay? Then self.name is going to be equal to name, self.email is going to be equal to email, self.age is going to be equal to age. Now this indentation is a lot simpler on Linux because you actually can see where the indentation is, and right here I have no idea what the error is. Def display count self print total employee number is, and then here we will add a string of employee emp count, and here we have the last function, which is going to be display information, takes self argument because it belongs to this class, and it will simply just print name, self.name, email, self.email, age is the last one, and self.age. Okay, so everything worked correctly right here. And right now let us create our employee once again. So employee1 equals to the employee class, and here we will specify the name Adam, once again adam@gmail.com, and 15 years old. And right now we successfully created the instance, or the Adam. We actually put him into the actual class employee. So right now we have one instances of this class, and in order to get the information for Adam and the information for the actual full amount of employees in this class, we can simply display these two functions. And in order to do that, we can simply just call them. So in order to call them, you can simply just type here employee1 dot display information, and here you will see that it will display information for Adam. As you can see, name Adam, email adam@gmail.com, and age 15. Okay, so simple as that. Let me just check this out right here. Oops, it's not the actual employee1. And we can see that if you just use the display count method right here, you will get printed out the total number of employees is 1. Now, in order to actually create a second employee or add the second instances of the actual class, you can simply just use employee2 equals, and then basically use the employee function to add another person. So for example, Jack, email jack@gmail.com, and age 20. And then if you simply just use the same function or the same method from the actual classes before, which is the display count, you will see that right now the total employee number is 2. Okay? And then you can, of course, if you want to, print the Jack information as well. So display information, open and close brackets, and you will see everything for Jack. Okay, so basically this would be the introductory part for our classes. Hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial, and right now let us continue with our class that we coded in the previous video. So we managed to actually code an employee class, and we also added 2 instances of this class. We added the Adam and the Jack, and their information, of course. Now that we did all of that, let's take a look at some of the other things that we can actually do in this class. So for example, we know that this emp count variable can be accessed within and without, within this class and outside of it. So in order to access it, you can simply just print it or use it in a print statement. There are, and then you can just concat the string value of the employee.emp count plus employees in the company dot. Oops, let me just see right here. Employee, the string value of this, string employee.emp count. Let me just try to print it like this. Well, let's just print employee.emp count. Let's see if it will get printed out like this. Okay, so it will. We can print it in a different way. So like we can print it just like this. There are %d, which stands for printing the integer, employees in the company. And then after the %d, we can specify right here, open and close brackets, and the actual variable that we want to print instead of the %d. So I'm not really sure if we did cover, I think we didn't really cover this before. Basically, %d in a string represents an integer value that you will specify right after you close the single quotes. And you specify it just like this. So you use the %sign, and after it, in the brackets, you specify the actual variable that you want to print instead of the %d. Okay, so employee.emp count. And if we print this, we can see there are 2 employees in the company. Now that we actually covered this, let us also cover the strings as well. So in order to actually print an integer, we saw that we only need to add %d in a string and then specify the variable like this afterwards. If you want to print an actual string, you need to specify %s and then print and then use the same statement like this. So let me just show you right here. Let's say string equals hello, and you want to print it like this, so %s world, and world, and then you need to add the % and then string in between the brackets right afterwards, and you will replace the %s with a certain string. In order to actually change it for an integer, we saw it right here, so let's take a look at another example as well. So number equals 2, print the number is %d for the integer value, then % afterwards, and in between the brackets number, and you can see it will print out the number is 2. But more about that later on. For now on, let us continue with our class. So we have it coded right up here. We have two instances of this class. One of them is Adam, one of them is Jack. And right now, I just want to show you that you can actually change specific values for all of these instances. For example, let's say you want to change an email for Jack. You can simply do that by going right here and specifying the actual employee, and then which employee Jack is. He's employee number 2, and then dot, and you can access the actual specific parts of the variables accessed for the Jack. As we can see right here, we have name, email, and age. We want to access email, and then equal, we want the email to be equal to, for example, jack36@gmail.com. And you will see that right now, if we display information once again for Jack using the display information function, you can see that the actual email for Jack has been changed. You can also, if you want to, delete specific elements with the simple del command. So delete, and then you want to delete employee from the Adam, and then you want to delete his age. You can simply do that by specifying delete employee.age. And if you just type here employee1.show information, or display information, pardon me, we're displaying information for Adam, and you will see that the employee has no object or attribute age. And in order to actually add the age for Adam, you can simply just use employee1.age equals 17 or 16. You can see Adam was 15. Let's say he aged. And right now, if you just type to print it once again, right now, Adam is 16 years old. Okay? So there are also certain other things that you might want to take a look at, such as the get attribute object, the has attribute object, set attribute object, and delete attribute object. Now, instead of using the normal statements to access attributes like these ones, you can use these following functions. So basically, get attribute is the function that will access the attribute of an object. Such as, for example, if you just type here get attr, which stands for get attribute, and in between the brackets, you need to specify from which instance you want to get or basically this function right here will have two actual arguments. The first one will be the instance that you want to access, which in our case, let's say we want to access Jack, so he's employee 2. And the second argument will be which actual value you want to access for the employee 2. And let's say we want to access age. So you specify it in between the double quotes. And basically what this function will do is it will return the value of age attribute. Whoops. Employee object has no attribute age. Yeah, because it is probably small letters. So get attribute employee 2 age. Okay, so here it is, and you will simply just get outputted right here the age of employee 2. Okay, now the next one is basically has attribute. You can check out whether a certain instance, or in our case employee, has a certain attribute. So for example, has attribute of employee 1, which is Adam, I believe, whether he has attribute let's say phone number and you will have the Boolean value of true or false returned if the actual attribute if the actual instance has that attribute, it will return true value. And if it doesn't have, it will of course return the false value. As it says right here, we don't really have anyone with a phone number. Therefore, the has attribute function returned false. Okay. You can also set different attributes by specifying the set attributes function. So set attr, specifying the employee. Let's say we want to change the Adam, and we want to change his, for example, name. Let's say he renamed himself for some reason, doesn't even matter. And the third argument will be the changed value. So Adam is no longer named Adam. He is now named, for example, John. Okay. You basically set that right here. And if you just type here employee and display information, you will see that there is no longer Adam. Now his name is John, even though his email is still adam@gmail.com, but you can change that as well if you want to. And also the last one will be the delete attribute, which is the same as this right here. Just maybe you prefer this version of it right here. So delete, and then attr, and in between the brackets, of course, employee. Let's say we want to delete John's email address because he changed name. So employee1. And the actual attribute you want to delete, which is going to be in our case email. And right now, if you show employee1.display information, it will get an error because the actual John has no longer email. So we have to add a new email for John. So those are just some of the actual functions that you can use in order to change different values of attributes, in order to basically interact with different instances of this class. So basically that would be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now we're going to take a look at the inbuilt class attributes. So basically what I did right now is I actually copied and pasted this actual class to a normal notepad-like file that we will actually run as a real program. I created an instance of Adam with his email address and his age. Then if we display the information for Adam, you will see if I run this, it will display the information for Adam. But right now, let us take a look at how we can actually access a different built-in attributes with our class. So every Python class keeps following built-in attributes, and they can be accessed using dot operator like any other attribute. So for example, if you want to have a //doc __doc__ attribute used, which is a class documentation string, you can simply access it with this. So for example, you can print employee and then dot and then / __doc__ and then 2 dots. And then what we will do is we will actually concat the employee dot __doc__. And if you just save this and print it to the screen, you can see right here the employee is none. So basically it is none if it is undefined, and in our case it is undefined. Now you also have an actual we can also print the same statement just using the built-in class attribute called name. So you can just print it right here, and instead of doc you can just simply type here name, and also in the string itself, let's change it there as well. Name, save it, print it to the screen, and what this will do is it will basically print the class name. As we can see, it prints it correctly because the class name is an actual employee. Okay? So the next thing you basically want or maybe need to do is the module attribute, which is a module name in which the class is defined. Now the attribute will be __main __ in the interactive mode, which is going to be our mode right here. So what we will get outputted with it, let me just paste it right here. So we use module we should get outputted main as a main function, as you can see right here. If I just save this, print it, you can see we get the employee module is going to be underscore underscore main underscore underscore. Okay? So those are just some of the built-in attributes that you can actually take a look at. They are not really that useful at the moment, and these are not all that there are, but maybe they will be useful to you later on. So I just wanted to show you that that actually exists as well. And right now, let us take a look at the example of a different class. So what we are going to do is we are going to create a class that is going to take two different values, which is going to be x and y, which are going to define a single point. So right here we can continue coding that simply by typing class and calling it point. This class point is basically going to have an init function, just like our employee class, which is going to take different variables in it. So def underscore underscore init underscore underscore. We need to use the self argument as always, so make sure to specify it right here. Self argument. We have the x and the y variable, but we will set them to be equal to 0 by default, and you can simply do that just by specifying their value in the brackets right here. Okay, then two dots, and right here we will set the self.x to be equal to x and self.y to be equal to y. Then what we are going to do is we are going to create a built-in attribute, which is going to be a delete attribute, which is simply just going to print the class name of an instance that is about to be destroyed. So you will see just in a second, if I just use it right here, def underscore underscore del, which stands for delete. It only takes self argument as a part of the argument list. And basically we can simply just use a variable class underscore name, which is going to be equal to the self argument, which is going to take the class instance, or pardon me, the class attribute and dot name attribute. Okay? Now this might be a little bit harsh syntax for you, but don't worry. Basically, as I said, this function right here is going to print the class name of an instance that is about to be destroyed. So we will print it right here. Class name, class underscore name, and then comma, and you can see right here, if we just add double quotes or single quotes, destroyed. So what this will do is once we actually use it is going to just print out point destroyed, because the point is name of our class and we called the name of our class right here. Therefore, this variable right here will just print here point. Okay, so simple as that. And let me show you just here as well. So we created our class, and right now let us create point1, which is going to be an instance of our class, and let us make it to belong to point class right here. Okay, then if we want to, we can simply just type delete point1, and you will see that it will just simply print point destroyed. So we actually created a class that has an actual method in it that allows us to actually destroy a certain instance of that object. As we can see, point2 equals point. We can also add it to here. And if you delete point2, it will print point destroyed. If you just type delete point3, you will get an error point3 is not defined. But also if you delete point2, you will also get the error point2 is not defined, because you actually deleted it with this line right here. Therefore, it no longer exists in your Python 3 class. Okay, so simple as that. Now, also another useful thing you might want to know is that these classes are mostly used to be imported. Now, what I mean by imported, as you saw the examples of importing different libraries, such as the OS library that we saw while we actually interacted with different files, we used OS library functions. Well, the same thing is with classes. What you would mostly want to do is you would want to call this class point function in a different file, and then call that file, for example, point.py, and then import it into a different file and use it there as a different program. But we're going to take a look at that in the next tutorial, so hope you enjoyed this one, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial, and this is going to be a rather short tutorial, and I will show you right now how you can import our employee class as an actual library to your new program that you want to code. So right here, open up your idle, and just for the sake of purpose of this video, what I'm going to do is I'm going to paste this employee actual library right here onto our desktop. Then I'm going to open it in Notepad. I'm going to delete all of this unnecessary stuff, and I'm only going to leave this class right here. Now let's call it employee. Okay, so it is called employee. Save it, but save as. We want to change the name, and it will not be called employee with 3 E's, rather it will be called employee with 2 E's. Okay, save it, and now in our idle, let us navigate. Whoops, let me just see if this is the correct one. It should be the correct one. Yeah, it is. Okay, so our class is right here, and in our actual idle, let us navigate to our desktop directory. So import OS, then os.change directory, and here in between the single quotes we specify the backslash users, backslash then the username, and backslash directory, which is the desktop directory. And you will notice right here, if I just type import employee, it will get imported as any regular library, as well as it will create this PyCache folder right here. If you open it up, it will have this employee.cpython, which you shouldn't really take a look at. It doesn't really matter at the moment. What matters is that we imported our employee class as an actual library, and we can use its code in our Python idle, or in your new program, however you want to call it. Just make sure that both of those files are in the same directory, otherwise you will not be able to import this employee library if your program that you're coding is not in the same directory as the library itself. In our case, we're not coding any program, we just changed our Python 3 idle to go to the desktop directory, therefore we can import this employee library. And right now, if you want to, you can simply just create employee1 to be equal to basically employee, which is our class, and then in between the brackets you specify 3 arguments that we had, which is basically, let's say, Jane, email address is going to be jane@gmail.com, and the age of Jane is going to be, let's say, 25. Employee is not defined. Yeah, okay, so right now I made a mistake. In order to actually be able to use the employee class, you need to first specify the name of the file itself. So right now, in order to actually add this instance, you need to type it like this. So employee equals, and then the name of the file that you imported, which is employee, and then dot, and then the name of the class that you are using, which is employee. And then in between the brackets, we can specify these 3 values the same. So it doesn't even matter. We don't really need to change them. Paste them right here. Of course, I mistyped it. So let me just add bracket right here. And right now it will work. So it is different than adding instances in just simply Python idle that we saw before. So right now you need to specify the name of the file or the library, then dot, and then the name of the class that you are using. Same as in the OS library, as you can remember, we actually had to specify first the OS, and then dot, and then the function that we actually used. Okay, and you can simply just use employee1.displayInformation in order to display information for Jane. So basically that is about it for this short tutorial. I just wanted to show you how you can import it, and we will continue coding in the next lecture. Hope I see you there, and take care. Bye. Hello everybody and welcome back to our Python classes. Now, what we did in the previous videos is we saw some of the examples of actually importing our own class into a different program. So what we did is we basically coded our class in a separate file, then we put it in the same directory as our program that we are about to code, and then we imported it using the import function. Now, what we're going to do right now is we're going to do some program example or coding project, or however you want to call it. And we're going to simply use just classes and some other things that we learned before in order to create a simple project. So, open up your idle. Type it right here, open it up. Also, let us open a new file because we are actually coding. And let us actually enlarge this and start coding right here. So what we are going to do right now is we're first of all going to create a simple class. Now that class is going to be, for example, class student. So let's first of all think about what we want to actually create. So what we want to create is an actual program that will be able to select students from this class and display their information for each one of them. We're also going to store the information for these students. For example, if you pick an option 1, then you will store an actual value for the student. And if you pick an option 2, then you will display the value for a certain specified student. So let us see how we can actually code that. First of all, let us code our own class. And right here, we will call it student, as you can see right here. So the next thing we want to do is let us use the same actual thing as in the previous class that we saw, which is the count of the actual employees, which was an example of the previous class. And right now we want to use the STU count, which basically stands for student count. We want to know the exact number of students as well as their marks. So we're going to actually implement their exam marks or something similar to that. And we are going to automate the entire process of that project. So let us go right here. We actually select the student count variable to be equal to 0, because this will actually increase each time we add a new student to this class. So in order to add it, we need to define an init function. Whoops. And the init function will store a certain values. First of all, we by now know that every class needs to have the self argument right here. I mean, every actual method in class has to have the self argument right here. And let us think about what we actually need. So of course we need first name, lname, which stands for basically the last name, and the actual, let's go with the subject. Oops. What was that? Subject. And the grade. Basically, these are the 4 actual variables that we're going to take for our class. So right here, we need to define them by using the self.fname equals fname. And now we need to do the same thing for each actual variable. So self.lname equals lname. Self.subject equals subject, and self.grade equals grade. So we finished these 4 variables, or all we are left to do right now is increase the student count variable by 1. So student, we know that we can access it with the prefix of our own class, outside and inside of the classes, because we actually defined it right here. Therefore, we can access it anywhere we like with this actual prefix. So student.stu count equals, or plus equals, let us do it like that. Basically, plus equals, we already know by now, is the same as equals and then the same variable plus 1. So, and then we will increase it by 1. Because by now we already know that this actual statement right here will only get called once we actually put a new element into this class. Therefore, this will increase each time we add a new student, which we actually want. So this is our init function. Now we can take another function right here, and we can call it the, for example, let's have the same function as the actual previous one, which will display the actual amount of employees. So display students count. This function will only take the self argument because we are in the actual class, and all we want to do is we are going to actually print right here total amount of students is, and then we can use %d, and with the %d we can actually use the calling of this actual variable right here, the same as we did right here. So student dot stu count, and we can close the brackets as we already did. Now make sure to put this inside the actual brackets, even though I believe it really doesn't have to be inside the brackets, but I just like to put it because it looks a little bit better. Therefore we are going to leave it like this. Now we can add another function if we want to. For example, if we want to display all the information for this certain actual user, we can do that. So let us see how we can actually perform that by writing everything in a new line. So right now we're going to implement our knowledge of strings and how we can actually write all of this information line by line without actually using the multiple line string, which is defined by 3 single and 3 open quotes. Pardon me, 3 open single quotes and 3 closed single quotes. So right here we can call it student information. Of course, this student information will take the self argument and nothing else. We add the 2 dots, and then we can code the part of the function. And this function will basically be just a big print statement. So right here, what we can do is we can do something like this. So for example, first name, whoops, we need to actually add a string. So first name, 2 dots. And what we're going to add to this first name is basically, let me just show you right here. We're going to add plus self.firstname plus, and then we can add the new line character. Let me just switch my keyboard. So we are going to add \n for the new line character. We now know that that really indeed is the new line character. So now we know that everything we write afterwards will actually be written in a second line. So we can just simply add plus last name right here, plus last name, 2 dots. After the last name, we need to actually add the lname variable, which is going to contain the element for that specific student. So plus self.lastname. Now make sure that you actually refer to all the variables with the self argument because you're located in the class itself. Therefore, you need to use it. If you simply just write lname, this will not work. It will give you an error. So make sure to add self.lastname. Plus the new line character, \n, and then plus, and then we will add the actual subject, and after the subject we can add simply just grade. So let us go right here, subject plus self.subject, and then plus last time \n, and plus grade or mark, or however you want to call it, doesn't even matter. And right here we are going to add the actual self.grade, and therefore we actually finished this statement right here. Oops, let me just go right here. Okay, we can continue right now with the next statement. So let me just grade. Okay, so we did write then everything. For some reason, this doesn't want to work. Let us do it like this. we're just going to remove some actual empty spaces that we don't need, because I don't see the actual bar below that will actually scroll it to the left. It doesn't even matter, we can just write it like this. And right now we're going to add self.grade. Okay, self.grade. And everything is good right now. Okay, so right now what we're going to do after we coded our actual class, now you can right now choose whether you want to import it as an actual library, which we showed in the previous video how to do that, or you can actually choose to leave it right here and make it a part of your program, whatever you like. We're just going to leave it right here so we don't actually waste time importing it and saving it in a different file. We're just going to continue coding down here the remaining of our program. Therefore, as I said before, all we have to do right now is prompt the user for the available options to actually add to this class. So right here, what we can do is we can enter the while true loop. And the reason why we are entering the while true loop is because we actually want to run this indefinitely until the user specifies that they no longer want to use this program. And how we can do that is we can simply, let me just show you, we can simply just write right here the print option that will actually print, or we can write it outside of the while true loop, so we don't print it every time. We can just print right here usage, and then we can use \n, and right here instead of that what we can do is we can simply just add the help option. Or let's leave the help option outside of this, because we are going to print the actual help option at the beginning of the program. Therefore, the user will not need to specify the actual help command to get this statement right here. So usage and then q equals quit the program \n. What else do we need? Add option 1, or add, let's just leave it like this, I will explain it later on. Add means add student \n, and display means display student information. Okay, so this will print at the beginning of our program, and right after it we are going to enter our while true loop, which is going to actually sort all of these available options. So right now all we need to do is prompt the user for an input. So option equals, we're simply just going to name the command option. So option equals input, and there we are going to specify enter the option you desire. Simple as that. So enter the option you desire. They have 3 available options. One of them is the letter Q, which will simply quit the program. The other one is the add, which will add student that they specify in the actual class itself, and the display student information, which is going to be simply specified by the word display, and then the student name will actually be displaying the student information. So right here they have those 3 options, and right now what we have to do in order to check which one they chose is to enter the actual if-else statement. So right here, if I just specify if equals, or pardon me, if option equals, not if equals, that wouldn't make any sense. So if option equals to the Q, we simply want to break out of the loop, and then we will actually close the program, because our while true loop is actually going to be our entire program. Therefore, as soon as we break out of it, we're going to break out of the program itself. Therefore, the option Q, if we simply just check out whether it is equal to Q, we can quit the program. Now, if you want to, you can add right here .strip, which will strip anything unnecessary from this actual option, but it is not really that necessary at the moment. We will see later on if we need it or not. Right here, we are going to enter the else if statement. So else if the option equals to simply just specifying add. But you will notice that once you actually want to add the user, you're not only going to specify just simply add, because our program would not know any of this information. Therefore, we have two choices right here. We can use this option add as a single word, so we can we can just prompt the user to simply just specify add, and then it will store the word add into the option, and then we will check right here whether the option is equal to word add. If it is, then we will prompt the user to specify the rest of this information. But we can also use it, and we can also prompt the user to actually specify all of these informations in this statement right here. So add, and then the first name, last name, subject, and grade. But that would be more work for us to do. Therefore, this one is easier. Therefore, we are simply just going to check whether the option is equal to add. If it is, then we are going to prompt the user for this information. So enter the first name. So right here, we can simply just do something like this. Fname equals input, enter student's name. Okay. Lname equals input. We can simply, or let us call it so you don't confuse it, let us call it first underscore name, last underscore name. Oops, not lname, last underscore name. Input equals enter student's last name. So this is rather simple for now, nothing really to explain right here. We already covered all of this stuff that we are coding. Next thing is the actual subject, which we can specify to be equal to input, and then enter the subject of the exam. For example, math, some language, physics, or basically anything else, information technology, doesn't even matter. We're simply just specifying it in the subject variable, and the last thing we need to specify is the actual grade, or let's call it mark in this case, equals input, and there we're going to simply just specify enter student's grade. Okay, so these are the four information that we actually specified in our class. All we are left to do right now is actually add the student to the actual class itself as an actual object. So right here, what we can do is we can simply specify the count variable. Now the reason why we need count variable is because if you remember, the way we added the employees in the previous class is something like this: emp1 equals, and then we type employee, and then in the brackets we specify this desired information for that employee. But right here, you will notice that this will not really work like that. Now, the reason for that is because we're going to add right here multiple actual students, and we can't really mark them all as the same value right here. Therefore, what we're going to do is we are going to type right here the student name, or the student will be equal to first underscore name. Well, let us do it just like this, and I will show you why this won't work. So student equals, and then we're going to simply just type here student, and then in between the brackets we specify this desired information, which is first underscore name, last underscore name, subject, and also grade. Or pardon me, we called it mark, so we're just going to type it right here. Let me just divide all of this. Okay, so this is how we define the student to be in this actual class. And right now, if we actually want to display the information, we can simply just type here else if option equals to display. So right here, we're going to display the information with usage of this display student information count right here. We're going to prompt the user for the actual or we're not going to prompt anything. The to the user, we're simply just going to print right here the actual student, or let us just call it like this, print student dot, and then we are going to use student information right here. Now let me just check out whether this will work. If I just save this program right here, save it, go to the Python program, save it as student class.py, run it. Now of course we are going to have some invalid syntax. Let me just check out where it is. Yeah, we are missing the single quote right here, so let us add it, add this single quote, and right now save it once again, run it. Let me just find the second error, because apparently we have another error. Quit the program, add architecture, display student information. Let me just see whether this \n is actually making us a problem. It's not really that important to us right now. We're going to decorate this program later on, but apparently that is not the only problem right here. Let me just delete all of this and just simply type here usage to see whether the actual, error is in the print statement. Okay, so it has nothing to do with the print statement. It could be somewhere right here. Great. We are missing somewhere a single quote, perhaps. Let me just check it out. Let's go right here. Did we close the actual bracket at the end? Yeah, we are missing an actual bracket. Okay, so now it should work. Let me just save it once again and run the program. We can see right here usage. Of course, we have nothing printed out right here because we deleted it. We're going to add it later on. Enter the option you desire. We know there are 3 options. If we just first of all specify Q, we can see the programs quits successfully. But now let's try with a different option. If we specify right here, enter the option you desire, when we specify add, we can see enter student's name. So let's call him Mark. Mark is the last name as well. Enter the subject, math, and the grade B. Enter the option you desire. So right now we know that we actually finished these statements right here. We then went to the beginning of the while true loop, and now it is prompting us for the option once again. If I just specify display right now, we're going to get the actual student information missing one required positional argument, which is the self argument. Okay, let me just check it out right here. Of course, we are trying to actually call the function itself, and we need to call it onto the student right here. Therefore, we need to specify something like this. Let me just go right here, put it in the lower letters and run it once again. Type here display. Student is not defined. Let me actually take a look at this right here. Display information. Display student count is something that we didn't use yet, but doesn't even matter. Let us first of all get this to work. Okay, student equals student. We define the actual student. Yeah, we can't really print that. I just noticed that we actually typed right here print. We need to get rid of the print statement and simply just use it like this. If I just go right here and I go to the add and add Mark, math, and then B, and then type here display, we're going to get displayed all of the information about Mark, as we can see right here. First name Mark, last name Mark, subject math, grade B. Okay, so everything displayed correctly. Now, the only problem right here is if you just specify once again add, and then you enter the student's name to be Adam, last name Adam. Let's go with the Spanish, doesn't even matter. And then A. And then you just type here display once again. you will see that right now, you will only get displayed the information about Adam, because the student right here, which is the student mark, was overwritten, and therefore every time you specify display in the next actual specification of this command, you will only get displayed the last person that you added to the actual program. But no worries, we're going to fix all of that. For now on, we know that our queue option works, our add option works, and our display option works. The only problem is how we're going to actually add the students and select them one by one. But we're going to take a look at that in the next tutorial. So right now we are going to cut this tutorial short, and I hope I will see you in the next lecture. Take care and bye. Hello everybody and welcome back to this tutorial, and right now let us wrap up our program and finish this students count function right here as well. So all we have to do is add right here else if option equals to students count. We can simply just use this student, or pardon me, the actual student, and then call the count variable from the class itself. As we can see right here, we used it so we can call it outside of the class as well. So we will just print right here total amount of students is %d, and then we can simply just add the actual stu count variable. So right here, student dot stu count. Make sure to name it as its name is. So right here, if we call it in the program, so let me just save it, run module. Let us add a certain user. So add Adam, everything is Adam. If we display the information for Adam, we can see everything gets displayed. If we just type here students count, we can see that the total amount of students is 1. So right now, if we go to the add once again and type mark, and we just type students count once again, you can see total amount of students is 2. So our program works correctly. We can see that it does indeed print out the amount of students. So all we are left to do right now is also add the usage option. So actually users know which commands to specify. Usage will be equal to something like this. So let us do it like this. Add a student to the class, \n, q, quit the program, once again \n, and the last option is the actual, let me just find it, where is it, how did we call it, display. Okay, so display the student information, or the last added student information, because we remember from the previous video that once you actually specify the last student or add it to the class, it will print out that student's information once you actually type display. Okay, so display the last student information, and the students count amount of students. Okay, so everything works well. All we are left to do is save this right here, run it. Okay, we get our help option right here, enter the option you desire. If we just try right now to print the students count, we can see the total amount of students is 0. If we go on add, let's call him Adam, last name John, enter the subject, math, and grade C. And then with display, we can see everything displays first name, last name, subject, math, grade. And then we just type here students count, and we can see that the actual amount of students is 1. Okay, and then we press Q, and that will quit the program. Okay, so what we coded right here is a simple program, not really that useful, but it did cover most of the things that we did by now, such as functions, classes, if statements, while loops, the string manipulation. As we can see right here, we use the \n to change the line, which is good. And then we also added some of the input statements right here, print statements using the %d, which, if you remember, stands for an integer value. The %s is an actual string value. And then we print out this certain student information, add students, print the amount of students, and so on and so on. So if you want to, you can make this program a little bit more better. For now on, all we actually wanted to do is check out all of this stuff, how it works together. And we saw that. And what we're going to do in the next video is we're going to take a look at some of the more advanced examples of using classes. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now, what we're going to take a look at is something called class inheritance. Now, instead of starting from scratch, you can create a class by deriving it from the pre-existing class. Simply just by listing the parent class in the parentheses after new class name. Now, basically what that means is that we can actually have a class that is going to be the so-called child of the parent class, and the parent class is the class that we created first. And the actual child class will take an actual argument between the brackets, which is going to be the name of the parent class. So basically the child class inherits the attributes of its parent class, and you can use those attributes as if they were defined in the child class itself. A child class can also override data members and methods from the parent. Now that is also something to take a look at. Basically the syntax, the derived classes are declared much like their parent classes. However, the list of the base, or basically a list of base classes to inherit from, is given after the class name. Basically, we know, let me just open up my idle, we know when we define the actual class, we simply just type something like this, class student, and then we actually add the 2 dots and code the class code. But in order to create the child class, which is going to inherit all of the attributes and actual methods from the parent class, we're going to define it just like this. So class child, this is going to be the name of the class, and in between the brackets, you simply specify the parent class itself, and then you add 2 dots and start coding. Now we don't really need this. We're going to keyboard interrupt, and let us see a simple actual usage of this inheritance, or so-called class inheritance. So right here, we're going to take a look at a simple example. So let me just go right here and create a class called parent. We already know this definition of declaring. Basically, if you want to, you can simply just add it as a reminder right here. Define parent class. Okay. Now, we're going to set something called the parent attribute, which is going to be a simple variable, just like our employee count, student count, once we use the points. Basically, this is just a simple variable, which is going to be equal to 100. Now, what we have to do is declare the init function in this class. We're already familiar with the init function. It is going to take the argument self, and basically what our init function will do is it will call a print statement. So print, and that print statement will say calling parent constructor. Simple as that. Now this will get called every time we actually add an element to this class. So let me just go right here. Go to the next line. The next function that we are going to define is going to be the parent method function. So def parent method, and as every other function in the class, it needs to take the self argument. And this actual method right here will simply just print calling parent method. Oops. Okay, so calling parent method. And the last function to this actual class parent, or not last, actually one before last, is going to be the set attribute function, which is going to take two arguments. One of them is the self argument, as always, and the other one is the actual attribute itself. So right here, if we just define it and go right here and call it from the actual class itself, which we can call it because we defined it right here, therefore this actual variable can be called even outside of the class. So parent attr equals attr. And the get attribute, which is our last function to this class, is going to simply print the value of this parent attr, which is defined at the beginning to be equal to 100. So define get attribute, takes the argument of self, it will print parent's attribute, and then it will, we can basically add the parent and then parent attribute, which is going to be our number that is stored in this variable right here. Okay, so this is our normal actual class. We saw the example of creating a class like this before, so nothing really new to us. What is new to us is now that we're going to actually create another class that is going to be the inherited class of this. Basically, it is going to be the child class, and it will actually be able to access all of this stuff from the parent class. Let me just show you. If you just type here class and call it child, and in between the brackets, we know that by the syntax, we need to actually specify the name of the class that we want to inherit, which is the parent class. Right here, you can simply just add as in the upper class, define child class. And we can simply just use the init, which is going to take the self argument, and it will just write right here, print calling child constructor. You can see the difference is that right here in this init function, we actually print calling child constructor, and in the init function in the parent class, we're printing calling parent constructor. And you will see in just a second. Let me just go right down here, define another class, which is going to be the child method. Pardon me, not class, defining another method. So child method takes the argument of self. And right here, what we're going to do is we're simply going to print calling child method. So simple as that. Basically right here, once we actually code this, let's now go through this code. We created the class parent. It has a variable that is set to be equal to 100. We call it parent attribute. Init function, parent method, which is simply just two print statements. The set attribute function from the parent class is just going to set the parent attr to be equal to the attribute itself. And you will see that the last function, which is the get attributes, will simply print the value of this value or this variable right here. Then down here, we created the inherited class, which is going to be our child class, going to take an argument of this parent class that we created up here. And it simply has two functions, which is the init method right here, which is going to simply just print calling child constructor, similar to this, which says print calling parent constructor, and the child method, which is also similar to the parent method, which simply just prints calling child method instead of calling parent method. And right now, if we simply just try something like this, we create an element to the child class. As we can see right here, we can just call it just like this. We don't provide any elements in between these brackets because in our init method right here, we didn't define any specific values for this actual object for this class. So right here, all we have to do is open and close brackets. It will create the instance of a child class. And then if we want to, we can call the function c.childMethod, which is the actual function right here. And if you, I just typed here comma instead of actually typing dot. So c.childMethod, what this will do is it will call its method. So if I just save this, go Python program, child class.py, and I run it, you will see what this will do is it will simply print calling child constructor, calling child method. Now, the reason why it actually printed this out is because the child constructor is printed out as the init function. As soon as you actually define the instance of this class, it will print, or it will perform any code that is in the init method right here, which in our case it is simply just a print statement. Therefore, it printed this out, which is normal. Then once we call the child method from this actual class right here, whoops, not upper class, down class, it will print calling child method. But right now you will notice that if I just type right here something like this, so c.parent method, and I save this program once again, it will be able to also call this print statement from a different class. If I just run it, yeah, it's because we actually need capital P, or let's just lower the P right here. Because right here we also have the lower C, so therefore everything looks better like that. So let us run this, and you can see it will print calling parent method, even though we define the instance of this class to be the instance of child class. So once you actually inherit a class with a different class, you can simply just use all of its methods from that specific class, as you will see right here. If I just go something like c.set attribute to 300, for example, we know that it is 100 for now on. Let me just change this comma to be equal to dot. So c.set attribute equals to 300. It will call this function right here, which is in the parent class. It will be set to actually, what this actual method will do is it will set the value that is specified in the brackets. It will set to be equal to this parent attribute. Therefore, this parent attribute will no longer be equal to 100. It will be equal to 300. But we also need to call the c.get attribute in order to actually print the value, so we can make sure that we performed everything correctly. It will print this statement right here, and the parent attribute will be equal to 300. So let us save this, call it right here. Get attribute is not defined. Yeah, it is not defined because I always specify comma instead of a dot. Not really sure why. Let us save it once again. Save it. Run the program, and we can see right here calling child constructor, calling child method, calling parent method, and then parent's attribute equals to 300. So basically that would be about it for the parent and child class. What we saw right here is the example of inheriting every method from a different class into a new class. So you don't actually have to code everything twice. You can simply just define a new class and specify in the brackets the class that you want to take all of the methods from. And as we can see right here, we only added these two methods, and we were able to use all of these 6 methods right here on our instance of the child class. So basically that would be about it for this tutorial. Hope you enjoyed it, and I hope I will see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we're going to take a look at overriding methods in the class. So basically what it means is that you can always override your parent class methods. The one reason for overriding parents methods is that you may want special or different functionality in your subclass. Now basically, in order to override the parents class method, you need to simply call it the same as in the parent class. So the name of the method needs to be named the same as it was in the parent class. So I will show you right here. Open up your idle. If you just go right here and basically define a parent class to be equal, parent, which is going to define a parent class. And right here we have defined my method. Let's keep this